global application support for implementing control switching, contributive member representing India for study committees of SIGRE WGA 3.35 guidelines and best practices for commissioning and operation of control switching projects. Contributive member for old IEC, that is one standard, SC 17A WG 61 IEC 62-71-113. He has contributed in this standard also. That means formulation, the guidelines, policy, everything related to this standard. Dr. Urmil Parikh is the expert member in this. And he is also contributing member for the one standard IEC SC 17AWG 67, that is for breakers intended for control switching from Swedish NC. Power system analysis in context to high voltage switchgear behavior and failure analysis for high voltage switchgear including CVs. So Dr. Parikh has a vast experience, industrial experience in circuit breaker, relays and control switching applications. And he is associated with the Hitachi Energy currently right now, and he has joined us today from the Sweden. The timing may be in the early morning, I think. So there are 4.5 hours lag from here. Then it may be just you can see what the that means effort and what the commitment he has shown towards our faculty development program. And once I invited him, he, without any hesitation, Dr. Parikh has accepted our invitation, and immediately he became available to us for his expert discussion. Thank you, Dr. Parikh. Thank you very much. And now,
am I audible, sir?
The floor is yours.
Am I audible?
Yeah, you are audible, sir. You are audible.
My screen is visible.
Yeah, your screen is also visible.
So thank you, Giri sir, to invite me. It's like coming home. I worked as a lecturer in SVMIT Bharuch itself, and Professor Doshi and Komal Doshi, Vishal Doshi, Komal Doshi are my family friends. His brother, Komal ma'am's brother, is my classmate, and I hope there are some colleagues from various universities from Gujarat who knows me personally also. So thanks to invite me. This is also something which I like a lot since years, being professor for 8 years in a college. And my topic is always the same. I work on control switching devices since years now, and I have added some parts in the presentation which are related to our very innovative solutions on transmission line control switching. We have lost almost 18 minutes, so we will extend the second session almost 15-20 minutes, because I always finish my session with sincereness, and that is the reason, Giri sir, I requested for 2 sessions. You have given 1, but I requested 2, so that we all are academicians. Even I believe myself as academician. So
we have already planned your 2 sessions, sir. Next session will start at 5 p.m.
I know. So being academician also, I feel that I should justify to the topic, and we should have enough time to also have some question answers and all. But let us start quickly to the subject now. So, okay, I hope everything goes fine now. Okay, introduction is done. Now let us go to the direct topic. So many of you might not have heard about control switching. Before I start, Giri sir, for everyone who want to have any questions, please put in the chat window. Probably that will be easy to manage. One thing. Second thing, if you feel me, you are not able to hear me, or my screen is not visible, or there is a problem in the connection, Giri sir, you unmute yourself and just you can interrupt me, and I can repeat some part as required.
Yeah, sure. Thank you.
No problem, sir. So what is the control switching? Now, imagine that, see, let me talk as a teacher, because I had been a teacher. So suppose you carry your students to a substation and you are standing below a bus bar. Bus bar is nothing but from where you connect all the feeders, transmission line, transformer, reactor, capacitor bank. You are standing below the bus bar. Bus bar is nothing but an infinite bus. In our academic language, it's an infinite bus which pumps the energy where the frequency and voltage variations are minimum. And if you stand there and you look at three voltage waveforms, they look like this: red, yellow, blue phases. I think my cursor also should be visible. Let me put my pointer. So, oh, come on. Yeah. So, imagine that these are three phases: red, yellow, blue. In India, we use terminology red, yellow, blue for the phases. You are able to see the cursor on the waveform, correct? Which I am moving now.
Yes,
Is
yes,
it
sir.
visible? My
Yeah,
mouse?
yeah.
Okay, perfect. Perfect. So there are three phases here. Now imagine that someone is sitting in a control room on a reactor. Reactor is nothing but an inductor. In power system, we can represent any power equipment with inductance, that is a transformer, and reactors, capacitor, which is a capacitor bank, cable, transmission line, and also we have mixed components like a compensated line. When you have a transmission line connected with a shunt reactor, a cable connected with a shunt reactor, we will talk about it today also in the session. Because of a renewable penetration, so many grids of different countries are interconnecting. For example, in Europe, where I'm sitting now, there are so many interconnections through HVDC or HVAC between countries. Like I was in Germany recently with a TANET, one of the grid utility. We had talking about interconnection between Netherlands and Germany. So there are so many interconnected systems. So we have reactive power compensating devices, variable type of reactors, TCR, TCSC, SVCs, etc. So imagine we have a pure reactor. You are standing in a substation. You have a shunt reactor or inductor standing in the substation. One side you have a bus bar, another side you have a reactor. What is you have in between to connect is a switch. Like what you switch have you have in a home, similar switch. But when we talk about 400 kV system, 500 kV system, 765 kV system, this switch is nothing but a circuit breaker, which we used to study in switchgear subject or we teach in switchgear subject. I am into research and development of circuit breakers, and more importantly, now I work on control switching devices development. I hold almost more than 20 patents. Every year I have 2-3 patents since now 7-8 years. And we work and that relay development, but circuit breaker is also a very integral part of it. So I work on circuit breakers starting from as low as 66 kV to we have worked till 1100 kV. Now India is also bringing grid at 1200 kV. Recently, I was in Power Grid India last year in September for one presentation, PGCIL Delhi, and where we were talking about a grid of 1200 kV coming in India, and they are planning it also. So 66 kV to 1200 kV, you have reactors, transformers, capacitor banks, and we are talking about switching them in normal condition. We are not talking at all switching on or off, or rather off in a fault condition. No, we are talking about normal condition when there is no abnormality. Yeah? Now, if you remember, you are teaching machine subject, a transformer subject. When we energize the transformer, when we magnetize transformer, let me be very precise here. Magnetize means you have two winding transformer. One side of the transformer is open. The another winding, another breaker, when you are closing, you will magnetize the core. I am talking about no load energization, magnetization, and it pulls very heavy inrush current, magnetic inrush current, second harmonic current. And this current doesn't come from God. हाँ, भगवान से तो आता नहीं है करंट. ये करंट कहाँ से आएगा? Grid will give it, system will give it, generators will give it, and every system has a capability. I mean, if you talk about a short circuit level, what is a short circuit level? If you have a fault or abnormal condition, or if you want to have a heavy pool of energy, the capability is constant. Energy conservation law: the energy cannot be generated, cannot be destroyed. So if energy is constant, if you remove the time axis, then it's a voltage into current. So if you pull a heavy current, especially reactive current, because it's a second harmonic current, useless current, it's not something which you don't want to have in the system. Reactive, who want a reactive power? So if you pull heavy reactive currents, second harmonic current, the energy or power is constant, so voltage is naturally going to drop, and this is a problem. I was in Canada where we were charging a aluminum smelter with a rectifier transformer. The grid was so weak, I mean, it was not able to pump 1 per unit. We know per unit system. So if you talk about a nominal current of a transformer 1000 ampere, then it was not even able to give 1000 ampere current. The grid was so weak, and with 1000 ampere the voltage was dropping 15 to 20%. Imagine you have a 400 kV grid. the voltage drops 400 kV line to 20% down, 360 kV. In Tanzania, when we were charging a reactor, I went to Tanzania where they were charging first reactor in 7 countries of Africa, first reactor at 400 kV, and there was no capacitive element. It was purely inductive element. A reactor connected at 400 kV, nothing else. There is a step-up transformer which was giving 400 kV to the reactor. Another side was 220 kV connected to a transmission line 300 kilometer, and this was creating again 20% voltage dip. So these are the problems which a grid faces. I mean, when you charge a reactor, a reactive power current, when you charge a transformer, when you charge a transmission line or a cable, what is a cable? A capacitance. When you energize a cable, it pulls capacitive inrush current. You remember in network analysis, we say when you close a switch at T equal to 0, it works as a short circuit. Means it gives you minimum opposition to the energy flow or current flow. So naturally, if you have a sine wave, which you see on your screen, suppose your voltage is sinusoidal. When you're closing, it gives minimum opposition to current. So if you close at voltage peak, you have a highest energy pumping at voltage peak, highest inrush current, capacitive current. And that capacitive current comes from grid. So heavy reactive power pull from the grid, which is not good. Also, it will throw harmonics in the grid, power quality issue. So this type of issues are seen by people, utilities, I mean, also the private players like smelters or oil platforms. Very commonly, we see offshore oil platforms in Gulf where we have 60-70 kilometer cable. I'm talking about 70-80, 100 kilometer cable, 220 kV cable. I've heard about 132 kV. Even we have charged such cables. I was the first one in world to charge undersea cable connected to a wind farm, biggest in the world, in 2015 in UK. It was pulling a 250 ampere 220 kV charging current when we were charging that cable, and this creates problems. And on top of it, when you talk about a wind farm or solar park, which are private players, deregulation of power system. When we talk about generation, deregulation of generation, so private players are selling the energy in the system, and grid regulator, especially in Europe and America, if you go, or Latin America, they have very strict norms on power quality. Means if you pull a heavy reactive power, you have a very heavy penalties imposed. So they cannot afford this heavy capacitive current. So this type of problems are seen in normal conditions. I'm not talking again on a fault condition. So before 35-40 years, people thought, let us do a simple thing, what we used to do in network analysis. What we used to do, teach in network analysis, RL series circuit solving, RC series circuit solving, RLC series circuit solving through Laplace transform, partial differential equations, if you remember. And in exams or in the books of Van Valkenburg or V.N. Mittal, what we saw, switch closes at T equal to 0. To be honest with you, I taught network for 6-7 times when I was a college teacher. I never understand what the hell this switch closes at T equal to 0 means. I never understood. But when I came in the company, I was giving a session like this to GEB, Gujarat Electricity Board, headquarter in this training center in Vadodara. Suddenly my eye blinked in the training session. It said, what this means. And that is control switching. Switch closes at T equal to 0. You are controlling the closing of a switch on a sine wave, which is control switching. What you do in control switching, you try to switch on or switch off any power equipment, shunt reactor, capacitor bank, transformer, cable, any of the power equipment on a precise point on a sine wave to mitigate some transient. And the concept lies in academics. Thanks to I was a teacher and I had a good blessing from the students from that 8 years teaching. This academic background made me to work in this area. Still today I use the textbooks to solve the problem. Still today, I never failed. I went to almost every country in the world to solve the problem at sites also. I developed the algorithm with IIT Bombay, IIT Roorkee, and then we implemented that in our laboratory with an intern student, and then we developed that in a numerical ID with our one of the business unit, and then we implemented sites. I support sites also, various sites in world, and I also contribute to the standardization of this. I am part of the standard committee, which Giri sir was talking about, breakers intended for control switching. So I have a full 360-degree feedback system, academics, R&D development with collaboration to university, then we implement in our own business, and then we implemented sites for customers. Even I went almost 9 to 10 customers of transmission lines. We recently launched a product which can be used on transmission lines. We will talk about it today also. If we have time, let us see how much time it permits. So transmission lines, and I went to every utility who is using lines which are long and high voltage lines, 400 kV, 362 kV onward lines. China, Australia, India, Canada, where else? Germany, they have undersea cables. So wherever we have long lines involved, I traveled there. China also I traveled to talk about this new technology, because we have pre-insertion resistors. When we have a over voltage on a line, we use pre-insertion resistors. So if we want to offer a control switching device or control switching technology as an option to it, how it is perceived to the market. So technical promotion or technical, we try to offer a new solution. That is also part of our job. I mean, we go to utilities and we talk about new technologies, and then we try to get it in the specification of the utility or regulator, and then we try to offer a pilot. We are going to do first pilot in BC Hydro Canada recently. In 2 months we will be doing it, the first pilot. Now let us talk about how control switching works. As I told, we are going to switch our equipment on a precise point on a sine wave. From where this particular analysis comes, that also I will explain you with very simple mathematics. Now imagine you are standing in a substation below a bus bar or infinite bus. You see 3 voltages, red, yellow, blue, and suddenly someone closes a breaker by a TNC switch or SCADA, or is giving a command, and that command comes randomly on this black point, black vertical line. What do you see in your screen? Now, what is this point? This is the reference voltage, bus bar voltage. So if I take positive going 0 reference of the voltage, it's easy to detect a zero crossing detector in old electrostatic relays. Now we have digital relays where we can easily sense the zero crossings. I'm part of the relay development, numerical algorithms development. We also support on the coding of the algorithms. So this is the direction of the voltage, a positive going, and this is the reference voltage. So if I talk about positive going red phase, this is the zero crossing, very small angle. If I see this switching point random, this is the angle. But if we talk about another phase, yellow phase. For yellow phase, previous positive going, see this is negative going 0. This direction is negative going. But positive going is this arrowhead. So this is the angle reference. Blue phase, this is the one. What I'm trying to say is you have a balanced system, 120 degree phase different. 400, let us take a 400 kV system in India. Let us take a substation, Jambua substation near Vadodara. Okay, 400 kV is line to line per phase will be 400 by square root 3. That is 230.94 kV. Line to ground RMS voltage is this. Peak is 341 kV. This peak of the sine wave. 3 phases are there. Now you see the switching angles are different. The yellow horizontal line, the blue horizontal line, the red I have not shown because it's very, very small angle. These 3 angles are known as switching angles. And when we talk about switch closing at t equal to 0 in the network analysis book, what this means I can explain you. Everyone of you have a watch, like on a round watch on your hand. When you have a needle which is crossing 0, you start the stopwatch. When you cross 3 o'clock, it is 90 degree. When you cross 6 o'clock, it is 180 degree. When you cross 9 o'clock, it is 270 degree. Again, when you come to 0 or 12 o'clock, it is 360 degree. So you start the stopwatch. You can see also my video. I have done my video on your vertical line needle. Now, tuck, 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 90 degree. You close the switch. And that is the switching angle at t equal to 0. And this is control switching. But how we know whether we have to close 90 degree, 180 degree, or it is 45 degree? Because this angle in a mixed loads, like a compensated cable, you have a reactor and a cable connected on a common circuit breaker. It's LC circuit. We create artificial resonance by creating a typical angle which can be anywhere between 0 to peak on a sine wave. So what we typically do is uncontrolled switching means this is random. All 3 phases closes simultaneously. What happens because of that? This is a real waveform of Navsari substation, 400 kV GIS 63 megawatt reactor. I remember before 10 years I have done it in India. When you do yourself the work, you always remember the numbers in your mind. It's 90.909 ampere RMS current. You see, this is the real current of the waveform. This is a real waveform, not simulation. This is a red, yellow, blue phase currents of a reactor when you are charging inductive current randomly. And this is a zero sequence current, black current. Now let us link what can happen with this. Every one of us know power system protection. I was teaching protection 8 years. The beautiful subject, amazing subject. If you know protection, you can do anything, because you need to know power system, you need to know switch gear, you need to know network analysis, you need to know machines, everything to teach protection. And in protection, 1+1 is not 2. It's an art. Control switching is almost like a protection system. Suppose you are charging a reactor and you have a differential or REF. Let us take REF protection, restricted earth fault protection. What a numerical relay do? First thing, what it does, it determines fundamental frequency component. This is having asymmetric DC component superimposed on a sine wave. So when you close it, this current is seen. Urmil is a relay. Imagine Urmil is a relay. What Urmil gets? Sample of it. 80 samples per cycle it gets. It determines the fundamental frequency by decaying DC removal algorithm, Taylor series. We used to teach in first year mathematics, Taylor series, where we put a sine wave with a DC component, where DC component is represented by third 3 or 4 first terms of a Taylor series expansion. And then we put a Fourier transform omega t 2, omega t plus theta 1 plus theta 2, etc. And we decompose it and we determine fundamental frequency component. This precisely numerical relay will do. But when we go higher and higher voltage, 400 kV, 765 kV, 1200 kV voltage systems, your X by R ratio is higher, means inductance is higher. Of course, resistance will increase, but not to that level. When you go higher voltage, higher and higher voltage, your X will increase, inductive effect will increase, but resistance will slowly increase. So X by R ratio is higher. What is X by R ratio? Time constant, decaying DC component. And this will be very, very slowly decaying because of high X by R. This can create error in fundamental frequency component computation in a numerical relay. And if your operating quantity setting, your operating setting of a REF protection is very sensitive, on charging, the relay will maloperate because the fundamental frequency component is wrong. Because of the decaying DC removal is inaccurate. So the summation should be 0. If there is no fault, then neutral current plus the 3-phase current should sum up to 0. Basics. And here, because of a wrong fundamental frequency computation, it will sense the fault, which is there is no fault, but it is maloperate. And it will trip onto the charging of the reactor. I have seen this also 2-3 times. For transformer also I have seen, but there the problem is second harmonic. I will come to it. So while charging the reactor, you can have a problem like this. I have seen 2-3 times in my life, but this can happen. Then what is the solution? Instead of doing that way, you close the reactor on voltage peak. Red peak, yellow peak, blue peak. One method. Another method is red positive peak, followed by which is the next peak. See, if I see red positive peak, which is the next peak coming in? If I don't care polarity, after 60 degree, you will get a blue phase peak. And then you get a full yellow phase peak. Even I did my PhD on control switching patterns. I always tell one thing, people talk hi-fi things. Things are very simple. I never worked outside first year electrical basics. So toughest subject to teach is first year electrical engineering. Toughest. The best teacher should always go to first year teaching. What I always believe. It's like a blank paper. Student is a blank paper. We have to write what we want to write and we have to clear the basics. When I go in recruitment, I always ask, what is Faraday's law of electromagnetic induction? Lenz's law. Can you explain me the mutual effect of a transformer? Using a Faraday's law and Lenz's law, and I will select you. This is the way we treat the people in R&D. I am in R&D. So we want basics to be clear. And these are basic things. See, if you have a peak voltage, this is basically red, blue, yellow. And see, what I explained is phase angle. This is the first year. What is the phase angle? People were not able to answer this. That what is the phase angle? First chapter of Theraja, part 2. Part 1. Second part, AC circuits. If I remember 98 when I graduated. 95 was my first year. I still remember first chapter of AC systems. What is a phase angle? It's a phase angle, nothing else. And we close this way. Now, if we close positive red, yellow positive, B positive. Or if we close red positive, blue negative, yellow positive, this way. What is advantage? Let us see. And if we close like this, instead of we close randomly at 3 point sine wave like this randomly, it can be here, it can be here, it can be here, anywhere randomly. But if we, instead of doing that, if you do like this, you end up in a problem. But if you do controlled way, precisely on a sine wave, what happens? This is a real waveform of the same substation. There is no asymmetric DC. See, the currents are fully symmetric, and see this zero sequence current is reduced. And this is a real advantage of control switching. And this we have done 765 kV, hundreds of reactors, Wardha, Nagpur, Indore, Gwalior. I have visited to these sites, what I'm speaking about, Karnool. In Gujarat also, so many sites. So one thing is what we teach or what we do, we have to go to see how it works in the field. So it's very important that we bring our students to the different fields. I mean, different places, plants or substations. I used to go with students to the thermal power plant, even to the boiler drum, to show how the thermal cycle, air cycle, flue gas cycle, steam cycle works. Till today, I remember after 20 years, because we do ourselves, then we remember. These things we should show to the students that how they really work. One thing I want to add, even if it's academic session, but I tell you what difference I have seen in Sweden and India. We are very good mathematicians, academicians, but these people are quite good practical people. I can tell you they don't have even 12th pass level. I mean, they are not even ITI. But you see the way they work, the way they think, the way they develop the product. It's amazing. And that we are missing. Another thing is we are not good finishers. We are good mathematicians. We do amazing algorithm development. We don't document properly. We don't close the thing properly, which we have to learn. And that is we have to put in our students. 4 years, if you don't teach book, fine. Try to show them how to approach the things, what industry needs. Ethics, very, very important. Second thing, basics. And third thing, practical approach to the problems. Let's see. I remember Bhunesh Ojas I admire a lot, who is in BVM, used to be in BVM. Rashesh Mehta sir is taking protection. He was his superior. He used to dismantle the protection lab and tell the students to wire it. Amazing. Tell them to machine lab you have. Let them remove the wire, transformer test bench, remove it and wire it again. Tell them to do this. And they have a learning experience. Here, who is paid maximum? Plumbers, electricians, who can do the work by themselves. So we have to teach our students to do a practical work. Very important. Simple compared to what we teach is very simple. And also simple curriculum. Very important. We don't teach basics to the students, which doesn't survive in market. Basics are important. Anyhow, let me go out. I used to tell this in sessions because at least I can give a feedback from industrial perspective because I come from industry. So with this type of method, what you can do is you reduce the protection mal-operation. Important one thing, see, in some of the countries, downtime. What is a downtime? When you are trying to charge something and suppose something trips, there is a problem, then that line or that equipment is out of service for some time. And because of a deregulation of the power system, there are heavy penalties imposed. Example, Brazil. When I went to Brazil, if a transmission line 400 kV trips, the downtime is converted to a penalty, very heavy penalty to the utilities. Grid regulator is the authority like Power Grid India or POSOCO. In India, it's POSOCO, old name, who governs the grid. And there are different utilities like UPTCL, GETCO, Rajasthan State Electricity, RVPNL. Then now Adani also, for example, is doing power. So what I'm trying to say, these people will be imposed with penalties if there is a downtime. So downtime is very, very important. Asset optimization is known as asset optimization. We talk about asset management. Asset optimization is very important. And power quality, there are very, very heavy penalties. Voltage drop of plus or minus 5%. THD, total harmonic distortion, very, very important terms. And these all are very critical. So with control switching, we can do this. But why we put these targets, let us understand. And before that, how this happens in a system, let us understand. Imagine you are standing in a substation. Let us go to the next slide to make it easy. Suppose this is a bus bar in a substation. You have a circuit breaker, 66 kV, and you have a reactor. Now what happens? You have a reference voltage. Remember, I was showing 3 reference voltages, red, yellow, blue. This reference voltage is given to control switching relay. Imagine Urmil is control switching relay. He gets this reference voltage. Now, Ashutosh Giri sir is a control room person. Giri sir closes the breaker, gives the command, and it comes to me. Urmil checks as a relay, is it a noise or a real signal? How? It should be DC pulse of 110 volt DC battery supply, plus or minus tolerance of 10 to 20%, whatever is permissible as per the grid code. DC, and that 100 millisecond or 200 millisecond DC pulse says that it's a command, not a noise. It comes to me. Urbil determines the zero crossings on the sine wave from the reference voltage, which is sand from the CVT, capacity voltage transformer. And Urmil determines the zero crossings. As soon as Urmil determines the zero crossing, he puts with a universal clock of the numerical ID. That's a clock, synchronized clock, which connects everything in the grid, not only local substation, across the nation. There is a common clock, or also not nation. Now we have a grid connected with different countries. A common clock synchronization. You know, phasor measurement units, wide area measurement. This everything is time synchronized. So time synchronized timestamp comes to my mind when I am ready with the zero crossings. Now Ashutosh Giri sir says, Urmil, the closing time of the breaker is 50 milliseconds, 58.2 milliseconds. Urmil goes in future as an astronomer और एस्ट्रोलॉजर, ज्योतिष बोलते हैं ना, मैं हमेशा अंग्रेजी में कंफ्यूज होता हूँ. ज्योतिष की तरह सोचेगा भाई 50.2 मिलीसेकंड के बाद अगर ब्रेकर क्लोज होगा मेरा, अगर मैं वोल्टेज पीक पे हूं, जो मेरा टारगेट है, टारगेट कैसे मालूम पड़ेगा? आशीष गिरी सर टोल्ड इट्स अ रिएक्टर, grounded reactor. I am using word very carefully. Grounded. If grounding is ungrounded, then you have floating potential and neutral. And we teach one subject in switchgear, one term, first pole to clear factor. Across each pole of the breaker, if you have ungrounded system, the voltage across red phase, yellow phase, B phase is different. Third pole to close, we'll see 1.5 per unit, for example. So this Urmil knows, okay, Ashutosh sir told it's a grounded reactor, ungrounded reactor, delta connected reactor. Urmil says, okay, it's a grounded reactor. All three poles will see 1 per unit at 120-degree phase shift. But now it's ungrounded example. It means when a Urmil closes first pole, there is no return path. See, if you're ungrounded, isolated neutral system, current cannot flow through the earth. You need to have a return path, which is not there. Even if your source is grounded, your load has to be grounded. If it is not there, you cannot have a current flowing. So when Urmil closes one pole, you can see my hand on a video. If I close only one pole, current will not flow. So when you have closed one pole, the second and third pole we see √3 times voltage, line to line. So second closing should happen at line to line voltage, √3 times voltage. That Urmil will calculate himself and gives the peak target for a reactor. Whenever third phase closes, sorry, whenever second phase closes at √3 voltage, third phase will jump to 1.5 per unit across the gap. This Urmil knows because Giri sir told it's an ungrounded reactor. 50 millisecond closing time to Urmil go 50 in future and see that am I on the voltage 1.5 times for third pole to close at 1.5 pu peak? No. So when is the next peak coming in? After that, Urmil sees 2.05 millisecond. So if Urmil might have closed after 2.5 millisecond, 2.05 millisecond, then he might have reached peak. I will repeat again. Command comes in, Urmil determines zero crossings. Ashutosh sir told it's ungrounded reactor. 1.5 pu voltage Urmil calculates in the mind for third phase. He goes in future for the closing time, which Giri sir has programmed 50.5 millisecond. He checks, Urmil checks, is it peak? No. Where is the next peak? It is coming after 2.05. So Urmil will hold the command for 2.05 now and release. Assuming it's an ungrounded reactor, assuming it is 50.05 millisecond closing time, and closes the breaker. And it will go for voltage peak. And this is the way control switching works. So assume. I have not talked about relay. What I talked for almost half an hour. I think we have done half an hour session now. I mean, what we talked more and more. Power system, type of grounding, network analysis, power system short circuit level. Have I talked about relay? No. So the least important part is relay, which I am developing. Because if my algorithm is foolproof, my mathematics is foolproof, the first technology is going to work. But there are so many uncertainties. For example, you have a circuit breaker who operates with a mechanism. See, the breaker cannot operate by hand. It has a mechanism which is, for example, hydraulic oil. And if you go in China where temperature is -30 degree in one season, going to plus 10 degree another season, viscosity of the oil governing system will change. Operating time of the breaker will change. Circuit breaker is a mechanical device. Today I close the breaker. First operation, my closing time can be 50.5. If I operate second time, 50.55, third time 50.4, fourth time 49.8, next time 50.3, next time 49.7, it will change. Statistical, we teach probability. One of the amazing subject which I studied in IIT Roorkee in my masters is reliability. And our teacher, Professor Pant, Vinay Pant was the best teacher I've seen in my life. He taught reliability subject to me. Till today, I'm using in standard development. I write the clause for statistical analysis of a breaker in this control switching standard. How to determine statistical scatter? Mechanical device. When you operate 100 times in a controlled environment, even if temperature is constant, even gas pressure of the SF6 gas inside is also can vary also. DC voltage. How a breaker operates with a coil? With a spring drive, for example. How the spring drive operates with a plunger, electromagnetic plunger. Who operates the plunger? DC voltage. If the DC voltage itself varies, your operating time varies. These are known as systematic variations. If I know that my DC voltage in substation goes by 10% lower, I can determine the characteristics of the breaker that it will have a variation of 0.5 millisecond. I can do this testing in the lab. I test it at 100% DC, 80% DC, 70% DC, 85% DC, 110% DC, and I can create a curve. Variation of DC versus operating time variation, and I can feed in the relay. Systematic variation, I can compensate for it by analysis. Temperature. If my temperature goes minus 35, minus 25, minus 10, ambient temperature, 50 degree in India, we have some places where we have 55 degree nowadays. What is the impact of temperature on operating time? I can systematically compensate it, systematic variation. But what about everything controlled? DC voltage, temperature, a controlled room. Everything is controlled. I operate one time, two time, three time, 50.5, 50, 49.8, statistical variation. 3 sigma, standard deviation. This we have to also evaluate, and that is known as a parameter definition of a breaker. I started to talk about breaker. I talked about grounding system. I can talk about 3-limb reactor, 3-limb transformer, star delta transformer with one tertiary delta connected, charging from star side, charging from delta side, YND11, YND0, YND7, YND5, different type of vector groups. Everything impacts. So more and more, I talk about system as a whole. Okay, one more thing. I talked about the current, correct? Who measures the current? CT, current transformer. We used to teach instrument transformers in power systems. Semester 5 in Gujarat University, LD Engineering is my graduation. And there we used to teach instrument transformers. CT, if you give a DC to a metering core, what happens? It saturates. If an exponential decaying DC component in current, it will saturate the CT. So you cannot connect on a reactor a metering core because it will not replicate the current properly to the secondary of the city. You have to use the protection class 5P10, TPX, PS class. Good developments thanks to the digitization. We have merging units, we have numerical IDs where we have samples. Give me 1 second, I'm coming. Give me 1 second, sorry. Sorry for interruption, I am back. I am going at a bullet train speed, but this is my style. If you feel quite fast, because we have a very limited time, so I'm trying to just create background of the subject, best I can do. So what I'm trying to say till now is power system, type of the grounding, type of the construction of the core, short circuit level, measurement device accuracy, circuit breaker statistics, systematic variations, sampling rate of the relay. If I have a small cable, 50-100 meter cable connected on a big inductive transformer, you might see a very spiky inrush current because of the cable interaction, which you cannot capture with slow sampling rate device. So the sampling rate of the relay is also very, very critical. So at the end of the day, control switching is a system and everything is important. So people, I mean, as whatever I told you, that metering core will saturate protection core. To be honest with you, even we have very good engineers, experienced engineers in engineering of the substation, they don't know all this. These are very basic things. We never expect any equations for the people to solve. We never expect people to do mathematics, to remember the things. No, basic concepts are important. And these are the things which makes things working. And I tell you, we are really scarcity of good people. My colleague Krunal Kansara, who is also from LD Engineering College, he is now in SSE, our utility in Scotland. So we both used to go to a university to determine one student. In LD Engineering. We took intern students for 3-4 years. To get one student with good basics is difficult. We selected one student with 11 subjects backlog because his basics were good. We don't want toppers. I am a topper. I have 6 gold medals in graduation. But to be honest, I didn't got a single job in any campus interview. Even I was a topper. Huh? I got only 48 marks in switchgear subject. I'm not feeling shame to tell you. Professor J.N. Shah, my mentor, who is no more involved now, but he asked me one question: what is the protection of a pole mounted transformer? I told differential protection, REF protection. Imagine what is my level. The teacher was very good, Babaria sir, BB Kadam sir, very good teachers, but we were not serious about our. I mean, imagine a topper has this type of level. What will happen? So the topic is very important. Percentage is not important. Basic concept is very, very important. That we should stress in our exams, practicals, and curriculum. Hi-fi things people don't need. I am R&D head for this technology. I'm a global head for the control switching devices. Every customer know me by name. I am a prelim failure, 12th class mathematics failure. I am in mathematics, Gujarati medium student. But we learned from basic concepts. My basics were good thanks to my professors in LD. At least my basics were good. Okay, I was a topper, but then also, in a sense, I was not able to secure a job. That was not sufficient to secure a job. So we have, as a teacher, it's our moral responsibility to give good human values, basics to the students. We are really feeling scarcity of good, and no student want to go in core industry first of all. Everyone want to use artificial intelligence and IoT blah blah, which are just balloons which will blow. We need to have core engineers, mechanical, electrical, computer, civil engineers, very, very important. So these are the important things which we have to put the students first year subject. I cannot say I'm electrical engineer. I have to say I am a design engineer. Drawings, materials, material or porosity of a casting is very important. When I was part of the GIS development some time back. So the topic is anyhow apart from the subject, but these are very, very important things which we should also explain our students that subjects are very important. Whatever you study in first year, all subjects are important. Okay, so control switching is a system where relay has a minimum role to play. Now, how we determine the angles? I only do AC RL series circuit analysis. Laplace partial differential. I don't want to solve the equation. Even if I don't know it now, fine. What is the outcome of this equation? This is the equation of the source, Em sin omega t plus phi. Why the phi is the switching angle, 90 degree or 0 degree, whatever. It has two components, aperiodic DC component and a sinusoidal component. And this has a e raised to minus t by tau. That is the DC component. What is omega t L by R? This is a power factor, inductance and resistance of the reactor. In power system, all components are inductive or capacitive. The resistive component is very less. So almost the angles are 90. Tan inverse infinity. Resistance is almost 0, so pi by 2 angle. So if I put phi equal to 90 degree here, 90 minus 90 is 0. So means the asymmetric DC will totally vanish. If you close on 90 degree inductive circuit, which I did with mathematics, I will totally remove the decaying DC component. This is basics of network analysis, which is the base of control switching. Capacitive element. What I told, if you close a capacitor bank, it works as a short circuit at when you close the switch at that moment. So if you close on peak, you have a highest inrush current because the voltage is highest. But if you close on voltage zero, the voltage is minimum. You will have minimum inrush current. And Beverly lattice diagram. If you remember Beverly lattice diagram on a line, what we were teaching, a line is open. What we are teaching, not we are teaching. Line is open on remote end. When I close the traveling, we will go to opposite end and it will have a doubling effect and come back because the opposite impedance is infinity. So the reflection is 1 pu. So whenever you close a capacitive load like a cable or a line, you have an over voltage effect because of a high traveling wave current, charging current. And that we can mitigate while closing at voltage zero. Capacitive element. If I close at zero, your opposition to the current is minimum when you switch a capacitive element. If you close on minimum voltage, minimum electromotive force, inrush current is minimum. But now, if you have compensated cable, a cable which is pulling a 250 300 ampere no load current, I'm not talking about load current. I have seen 800 ampere no load current of a cable which was going in Gulf from Abu Dhabi to one island in Gulf. 800 ampere charging current means the opposite end of the cable was open. I was supporting this job. We were closing the cable. We were getting 800 ampere charging current. Imagine how much big is a reactive current pull. How this 800 ampere current is fed capacitive from the grid, and the substation from where the cable was going was connected to oil industry. And this current pool of capacity will create a voltage disturbance on the grid. And if the oil industry trips, it's a disaster. So they cannot afford this heavy capacitive current. So how you compensate for a capacitive current? It's a leading current. To compensate what you output, exactly opposite lagging current, inductance. So on the cable, imagine my hand is a cable and this is a breaker here. And then in parallel, you put a cable in a reactor. You put a reactor in parallel. So the circuit breaker, when you close, the cable charging current is compensated by shunt reactor inductor. If your cable current 800 and if your reactor current is also 800, it's known as 100% compensated cable. 50% and above is known as a high compensated cable where inductive component has a predominant effect. Compared to capacitance effect, it's a considerable effect. High compensated line, high compensated cable, more than 50% compensation. Low compensation is less than 50% and it's a mixed load. You connect a cable and a reactor in parallel with a common breaker. Imagine a breaker which has to switch a cable and a reactor. If I put a target of reactor voltage peak, if I want to put a target of cable voltage zero, breaker is a poor guy. If we close at peak, the highest cable capacitive current over voltage and capacitive current will come. If you close at voltage zero, highest decaying DC component and the summation current will come means a cable current superimposed on a decaying DC component. And this creates a missing zero phenomena, delayed current zero phenomena. If someone of you in masters have heard about it or PhD, it can blow the breaker, blast the breaker. And on this, we have developed a product now. How to mitigate delayed current zero. Very simple method, artificial resonance. I don't close on voltage zero. I don't close on voltage peak. I close at 45 degree for 100% compensation. And this I did first in the world. When I went to the site in UK, I came to know there is a compensation. When I reached site, I never had thought about this problem. Then I opened pen paper and use first year what I should do. Now think about this, the shutdown is there, the plant is, it's a wind farm to be charged and there is a media standing there. It was world's biggest wind farm, they had to charge this cable. I talked to my Swiss colleague and we were in SIGRE committee, which we are showing in my imposes the force on the outer orbit atoms of that gas And at one point where the stress is very high, the force is very, it puts the electrons out from the outer orbits and becomes ionized gas, which is known as arcing. And this happens before the contact touch. So before you touch the contacts, you start the current to flow through arcing, and that has to be voltage peak. Now, this is not a joke. I want to start the arcing across the breaker context, which is closing at a velocity of 4 meter per second, which has uncertainty in closing speed of plus or minus 0.5 meter per second. The voltage is varying 400 kV plus or minus some percentage. The frequency 50 Hz also varying in plus or minus percentage. Breaker's operating time is also uncertain, and when I'm closing, it is a statistical dielectric behavior of the breaker. Everything is uncertain, and I want to make sure that I'm closing on the actual voltage at that time. 400 kV is a grid voltage rating, can be 400.5 kV, 395 kV, 405.2 kV actual voltage. Frequency can be 50.05, 49.95, 49.9. It can be any frequency. So I have to close across the gap on that voltage. When it starts pre-arcing, not mechanical touch, before the contact touch, because of the stress, it closes through arc electrically, which is not the making. And this I have to control with control switching, which is not a joke. I need to know mechanical characteristics, dielectric characteristics of the breaker. And this is difficult. And by my words, this is difficult. So it's a breaker which you should know a lot. We have live tank breaker, dead tank breakers, GIS, we have mixed technology switch gear, spring drives, hydro spring drives, motor drives, interrupters, different designs. Double motion means two sides of the breaker are moving, one side is moving, puffer breaker, self blast breaker, which we used to teach everything. We have at least in live tank breakers 80-90 breaker models, whose characteristics I support to do the control switching suitability analysis for every breaker in our portfolio. That is also one of my job. That when we are having a new R&D project of circuit breaker development, I frame the requirement specification of the breakers intended for control switching. That what we should meet. And there I have to be very careful, because we are developing something which has 50% chance. In R&D, you have a failure chance of 50%. We should not put over specifications, or rather something which can be managed to develop. And how you know that when you are part of the R&D? So I used to work on R&D of breakers, basic level, not too much detailed, but some part I used to do. Dielectric simulations I was doing with some tools which determines the field, electrical field analysis. Like if you remember 5th chapter, electrical boundary conditions, dielectric and capacitance chapter, 5th one. 8th or 7th chapter, magnetic properties, diamagnetic, ferromagnetic, paramagnetic. Actual usage of electromagnetic subject starts in chapter 5 and chapter 8, which we do not teach because the syllabus of magnetic subject is so difficult to teach. We are never able to reach 8th or 9th chapter, and from where our work starts. And this all we do in with sophisticated softwares. Pro engineering. I can give one more example. Sorry to go out from the subject. My son is studying in class 10th now, school. अपने जैसा बोर्ड है ऐसा. वो क्या सीखता है मैं आपको बताता हूँ. मैथमेटिक्स नहीं सीखता, वो ड्राइंग सीखता है. उसको सिखाते कि प्रोसेस को ये ट्रैक करना है एक पूरी प्लांट का, तो उसका एक सॉफ्टवेयर के थ्रू बनाओ प्रोसेस, एंड विच इज द वीकेस्ट पार्ट विच कैन क्रिएट अ प्रॉब्लम इन द फ्लो टू मीट द टाइमलाइंस. ड्राइंग बनाता है वो गियर्स का, ये उसको पढ़ाते हैं. और उसको पढ़ना इतना टफ है कि उसके एक सब्जेक्ट है कुकिंग, वो फेल हुआ 3 साल. 4th ईयर उसको ग्रेड मिला है. इट्स नॉट लाइक दैट यू गिव द ग्रेड एवरी सेमेस्टर. ग्रेड बढ़ता है टिल 9th स्टैंडर्ड. मैं ये क्यों बताया कि उसको ये सब्जेक्ट पढ़ाते हैं स्कूल के अंदर. अब सोचो हम कैसे बीट करेंगे ऐसे बच्चों को जो 10th में ड्राइंग सीखते हैं. अब इससे ज्यादा हम क्या बोलेंगे. और ये है यहाँ का स्कूल जिम्नासिएट. एंड दैट्स व्हाई फ्रॉम यूरोप पीपल कम फ्रॉम टू स्वीडन टू स्टडी. दिस इज वन ऑफ द रीजन. इट्स वन ऑफ द बेस्ट एजुकेशन इन वर्ल्ड for industrial people, best education anyhow. So this is a slide on which a Excel sheet I have shown. If you close on 0 target, let us see what happens. And if you close on a peak target, what happens? Let us see by Excel sheet. Edit worksheet. I want to edit existing. Yes. And And see, even my PhD was on Excel mostly. I did some PSCAD simulations, to be honest, as a formality, but I used to work only on Excel. I coded all the macros, what you write in iterative procedure in Excel. And this is the best tool to do. I mean, if you code yourself the simulation model, even one, if you want to give a student a 6-month project, tell him to only model PSCAD with only magnetizing characteristics of transformer. Only give this job. By my words, he will learn amazing things. We used to take one student from masters for 1 year. The project is to model a synthetic test circuit of a circuit breaker testing. I had taken a student to do modeling of a transformer for control switching, full 1 year, and I recruited him. And this level of work, only very basic one model development. So here, if I put time constant, I want to increase. 1 second. I forgotten what value I had put up. Just a minute. Where is the equation here? Just a second. Okay, this value, it is not constant. This value is constant. Okay, let me increase the value of inductance. X by R ratio I'm increasing. See this now. See this. If I'm closing at voltage 0, the target is 0, I have a highest asymmetric DC and the resultant current is sinusoidal. It's having a DC component. But if I put 90-degree target pi by 2, pi not pu. Gone. So this is the basics of control switching, what we do. Still we have 9 minutes. I will finish the opening of a reactor. And then probably we will have break for 1.5 hours for the second session. Now here, let us talk about a very important thing. You have a circuit breaker. You remember first year electrical engineering. Let me take a pen paper to explain you this, so that you can imagine what I'm explaining. Just a second. So this is a cylinder, and there is a pan. And if I cut this from the center, Ashutosh sir, is it visible? There is something strange happened on my laptop. Can you see this video? What I'm showing my face? Okay.
It's visible.
So when I cut it, sorry, when I cut it from the center, and if I horizontally rotate it, it's a cross section of a breaker, what you see on the screen. Now, in universe, any circuit breaker cannot interrupt a current which is non-zero. SF6 breaker or any eco breaker always have a tendency to interrupt the current at current 0, because the opposing force, how SF6 breaker interrupts the current, it pulls the electrons from the arc and becomes electronegative. If you have a high current, then your electrons are higher, so you pull more electrons. If the current is less, you pull less electrons. If you pull electrons, that is deionization of the energy balance theory of switchgear. You pull the electrons from the arc to deionize the arc or cool the arc. And at rate which you pull the electrons should be faster than supply by system, energy balance theory. So what you do is, I am breathing 72 times in a minute. If you remove the oxygen from my body more than 72 times, I will die. So if I pull the electrons from the arc faster than the supply by system, the arc will demolish. So if the current is less, I have to pull with loss force. Even SF6 pulls the electrons proportional to current. So opposing force is proportional to current. So at current 0, the energy of the arc is minimum, which is the easiest point for this breaker to interrupt. In universe, any SF6 breaker, eco breaker, AC breaker, or even DC breaker cannot interrupt the arc without a 0. If you don't have a 0 crossing on a sine wave, if you open the contacts, there is arcing between the contacts. Even when you open the contact, suddenly when you open with a very small gap, the voltage is 400 by root 3, but the gap is very small. Again, you have a very high field intensity, and there is arcing, because you will again to remove the electrons from the SF6 gas and becomes ionized in opening. And that is arcing. And the arcing continues till the current is zero, where the arc is weakest. And that is shown on the left hand side. When you see on a sine wave of the current, when you are opening the breaker contact here, suppose, do you see my cursor, sir? Cursor visible?
Yes, yes, sir. Yeah.
So when you open the contacts here, the arc will be there, arcing. Here it can interrupt. But now we talked about energy balance theory. We pull the electrons till the current is zero. See where we can put the electrons when there is arcing. So between the contact separation point to the current is zero, where the arc has a chance to quench is known as the arcing time. And their energy balance theory is applied. As soon as the arc is quenched at natural current is zero, the what is there on a reactor on another side? A very high inductance. And what is there? The bushing of the reactor is a capacitance. So there is energy 1/2 CV square in parallel to 1/2 Li square will oscillate. So as soon as your current is interrupting, you see there is a 1/2 Li square CV square oscillation. This is the over voltage. If this over voltage crosses the dielectric strength, see when you open the contacts, you start the pulling the electrons. So dielectric buildup will start at this point. And when you reach at the current zero, this is the dielectric strength. If the voltage will cross this, it will break down. Rate of rise of dielectric strength, this black line where my cursor is there, should be higher than the TRV or triple RV. It should be higher than the Slappian theory. So Slappian theory is applied after the current interruption. Energy balance is before. This I learned after 6 years of my job. I still remember when I was giving a session to my company people. That why we have two theories. I used to teach switchgear for 8 years. Every year I was teaching the sub part. I always confused why we have two theories. I came to know when I was doing this job in the development. Energy balance theory is in arcing before current zero and Slappian is after arcing when over voltage. So one thing, if your dielectric strength is losing, you have again a current start. Now let us see this video and we will end. First of all, when you separate the contact, this main contact, you see cursor on right hand, these main contacts have separated. Let me show you here. Here you see this is main contact of the breaker which are separated. And the current goes to arcing contacts. I am not spending more time on this because this we are teaching. These are arcing contact, hollow type. You can see my hand, hollow contacts. So the current will interrupt after when the arcing contact separates. And this is arcing. And this is this point when the contact separated. And then there is arcing, and you are moving on the sine wave, current is zero. When current zero comes, arc interrupts. See here, at this point, the over voltage will come. This gap should be enough so that you do not end up into a breakdown. If the over voltage is higher, you will have again current start. If it is between the contacts, no problem. But if the current jumps from here to the outer main contacts, this is a nozzle. This nozzle guides the gases. It punctures the nozzle, damages it permanently. But it's like a cancer. Slowly damage will increase. And after 100 operations, the breaker will explode because of dielectric capability lost. So we do controlled opening to ensure that this gap is enough whenever the over voltage will appear. When over voltage appears at current zero. So we make sure that at current zero, where arc is expected to quench, it should able to withstand the over voltage. And that over voltage is governed by your grounding. The first pole to open will see highest over voltage, 1.5 pu in isolated neutral ungrounded system. What is another extreme? Grounded system, solidly grounded. Impedance to ground is zero. Isolated neutral, impedance to ground is infinity. And we have impedance grounded reactors for high voltage, effectively grounded impedance in the ground, which is in between 1.5 pu to 1 pu voltage. Little bit in between, it sets. And this also we have to consider. So what we do in controlled opening, we open the breaker such that we know that it's a grounded reactor. We know the opening time of the breaker. We know the type of the grounding. We can anticipate for this voltage reference current lags by 90-degree inductance. So when the current zero will appear, we make sure that the contacts are opened well before current zero. So the gap is enough when the current zero comes. We start opening the contacts well before. So it moves more time during arcing away. and gap is more which the breaker can withstand. And this is controlled opening. And this is the reason why control switching started before 30 years. The breakers were exploding, the reactor insulation were damaging. And this was the birth of control switching at that time. And now last sentence, we have 1 minute left because Asutosh sir, I think there is another lecture of some other expert. Only one last sentence. We are seeing at 400 kV 39 ampere reactor. Yesterday I was hearing 10 ampere reactor. I don't understand, if you have a 400 kV grid, if you cannot manage 39 ampere only, 39 ampere reactor current, how will run the grid? So the consultants are shops which are opened in the world, power system consultants who don't understand practical stuff, and they give totally wrong advice to the EPCs and utilities and create disasters. So we start in 1.5 hours from now. Okay, Asutosh sir, exactly.
Exactly at 5 p.m. As per Indian time, 5 p.m. we will meet again, sir.
And one thing, we will talk about real field studies. I will have field experience of amazing cases, so don't miss this session. What I have, our competitors doesn't have. I have this rich experience. I will share that in the second session.
Yeah, participants, see the commitment of sir, how much he is interested to give some insights to all of us. So please be there at 5 p.m. Sir will meet us again. And just you can see there are 3 hours in 2 sessions. Sir is given today, even at the day of holiday in his company today. I think so, 5 days working. So Saturday may be holiday in his sir company, but sir is giving his valuable 3 hours to all of us. So it's our moral responsibility to take the maximum advantage from the session of Dr.
And if people are interested, we will continue half an hour more also. If people are interested, there is no time bar. Don't worry about it.
No worries, sir. Actually, after that session at 6:45, we have planned one quiz today because this is the last day of this FDP.
तो बाद में कर लेना quiz, sir. मेरे session के बाद 15 मिनट लेट कर लेना, क्या फर्क पड़ता है?
हाँ, no worries, sir. We will adjust it. If you are so much interested, sir. Then there is no.
लोगों को इंटरेस्ट था तो करेंगे. देखो लोगों की मेरे को तो मैं तो 24 आवर काम करता हूँ. आधी रात को मैं तो शट डाउन होता है क्योंकि मैं वर्ल्ड में सपोर्ट करता हूँ. 12 घंटे का टाइम गैप रहता है.
एनर्जी, your energy is unparalleled. It is it seems very visible from here. Your energy really unparalleled, and we are learning a lot from the, apart from the technical knowledge, we have learned a lot of things from your commitment and your style of teaching, you can say, and the way you are sharing your expertise. It was wonderful, sir. Thank you very much for this session. And once again we will meet at 5 p.m.
एक्सपर्ट वेट कर रहे होंगे सर. मैं निकलता हूँ.
जी
एक्सपर्ट वेट कर रहे होंगे सर आउटसाइड.
Yeah,
have a nice day. Let us meet exactly in 1.5 hours.
Thank you, sir.
Bye.
Bye. I think so Dr. Sanjeev Dwivedi has joined us.
No, sir, he has not joined. No, sir, he has not joined.
Okay. I am login. He has sent one message. I am login. Yeah. He is joining very soon. Devesh, just you keep track on attendance of the participants. Today it is seen that many participants have not joined. Only 86, 87 participants are seen here. So please keep track record on the attendance of the participants. And the participants who have not attended, that means as per the criteria of AICT ATAL, the participants who have not attended more than 80% of the sessions, no need to appear in the quiz. There will be no meaning because once attendance is falling below 80%, quiz marks, though you have attended 30 out of 30, there is no meaning at all.
Okay, sir.
That's why I requested repeatedly to all the participants. There are 117 participants, and out of 117, only 95 participants are continuously joining. Otherwise, all are absent. This is alarming situation for the remaining participants who have not attended the sessions. Yeah, Mr. Sahu, you want to say something? Chandrahas Sahu, can you write in chat box? Any query? Hello, Mr. Chandrahas. You have raised your hand. Do you have any query? Professor Devesh, you look into the list of attendees. Dr. Sanjeet sir may be there.
Okay, sir. 1 minute.
Yeah, he is there already. Now.
Sir, I have made them presenter.
Okay, fine. Yeah.
Very nice.
Yeah.
I can hear you
Yeah.
guys, and you can hear me now. Thank you so much.
Yes, sir. How are you, sir?
I'm absolutely good, Professor Giri, and I see your constant commitment towards technical development of India and contributing through your academic excellence. It's very nice, and I appreciate that.
Thank you, sir. It's our pleasure to have with you.
No, but the people like you, who are filled with energy and having without any motivation, they are continuously working towards the excellence of technical education. They are. It's.
Thank you, sir. Thank you very much. Yeah. Now, dear participants, our this session eminent expert Dr. Sanjeet Dwivedi sir has joined us. Really, it's our pleasure to have in this session. And now, just I would like to introduce all the participants about Sanjeet Dwivedi sir. Sanjeet Dwivedi sir has that means he is delivering the session in our second FDP. Whenever I requested to deliver the session from Sanjeet sir, Dr. Sanjeet sir has without any hesitation given his valuable time to us. It's our pleasure, sir, and entire Government Engineering College Bharuch is very much thankful. Entire committee of this FDP is thankful to you for your efforts and time. Now, dear participants, today our expert is Dr. Sanjeet Kumar Dwivedi sir. He is fellow of IET UK, IET India, and he is a senior member of IEEE as well. Senior consultant of Siemens Gamesa and Offshore Wind and R&D Center in Denmark. Today, in fact, he has joined us from Denmark and advising to R&D team for design and development of world's largest offshore wind plant converter unit. And he is also an adjunct professor at Department of Electrical Engineering, ABV, Indian Institute of Information Technology, India since January 2024. Earlier to it, he was a technology manager at Everfuel AS Denmark, a green hydrogen multinational company from 2022 to 23, almost 1 year, and technology leader at Danfoss Power Electronics AS Global R&D Græsten, Denmark from 2008 to 2021. He received his 2 master's degrees, first one in drives from IIT Roorkee in 1999, and the second master as MSc Engineering in Innovation and Business from Southern Denmark University, and was awarded gold medal from IIT Roorkee. He received his PhD degree in Power Electronics and Drives from IIT Delhi. Dr. Sanjeet also completed his executive leadership education from MIT Boston. He was honored with adjunct professor position at Curtin University, Perth, Australia. Dr. Sanjeet sir is member of faculty board of South Denmark University in Department of Innovation and Business since 2021. Dr. Sanjeet has authored more than 40 plus technical papers and holds 18 plus international patents, 3 business, trade, and 3 engineering research books published from Academic Press UK and IET Press UK. He is currently an advisory board member of International Journal of Power Electronics, associate editor of IEEE Transactions on Industrial Electronics, and he has given many more invited presentations, organized and chaired special sessions in various IEEE and European Power Electronics conferences around the globe, and delivered a keynote speeches at tutorials on power electronics and green energy. Previously, he worked as technical editor of IEEE ASME Transactions on Mechatronics from 14 to 20. He is a recipient of Merit Award from Institution of Engineers in 2006 for his research publications on permanent magnet machines. He was also awarded the 9th Man on the Moon Global Innovation Award from CEO and President of Danfoss in 2015. And another prestigious recognition as a winner of IETE Vimal Bose Award in 2017 for outstanding contribution in power electronics and drives. He is currently serving as an industry relation officer of IEEE Denmark section. So this is the inspirational work and inspirational achievements what sir has achieved during his professional career. His entire career is giving so much impact to the technical community, and it is totally inspiration to the that means beginners like us in the field of electrical engineering, and entire journey, I can say, from India to Denmark, and from Denmark to different countries, giving it advising and doing consultancy work. It is really it's not the it is not the work of day and night. It requires a lot of commitment, a lot of hard work, and a lot of motivation. Sir, thank you very much. It's our pleasure, and you can say fortune of this FDP to have the expert like that means the expert of your caliber. Thank you very much, sir, for joining us today. And really, it is going to helpful to all the participants to learn something from your insightful session. Thank you very much, sir. Participants, if you have any query, you can write in chat box. I'll put forward your questions to the Dr. Sanjeev sir. Now it is yours, sir. Sanjeev sir, thank you.
Dr. Giri, first of all, so kind of you for this kind introduction of mine. And I think that I have not contributed or not did a lot. It was a tiny, contribution of mine. But the way you are arranging this type of FDP, and you are inviting faculties of technical education around India and bringing in a forum and giving us opportunity to share our little knowledge, which can be directly boosted their confidence level and giving them opportunity to do the wonderful things. So in today's presentation, I will bring you
sir, sorry to interrupt you. My father, मेरे पिताजी भी आज आपको just ये हमारे साथ ही बैठे हैं. Just I would like to introduce my father as well.
Thank you, sir.
ये मेरे पिताजी हैं, गांव से आए हुए हैं, तो मैंने कहा हमारे साथ बैठे हैं तो आपके साथ इनको भी इंट्रोड्यूस करा दूं.
सर बिल्कुल सर, नमस्ते.
Now you can continue, sir. Thank you.
Yes. So in today's presentation, I will give you 360-degree views where you can see that decarbonization of world that is related with, power electronics, that is related with our renewable energy, that is related with a new type of, power electronics control method, which can strengthen our conventional way of working of grid. So this is my today's topic: unlocking grid resilience through green energy and e-fuel. And this will make a holistic view. This presentation will give you a holistic view, and you will be, takeaway will be that if we want to decarbonize the world, then this is the only way. And I will be very happy for your questions. Any questions come in your mind, please type in or keep it for at the end of presentation, and I will be very happy to give all the clarification and all the doubt. And everybody is welcome for their queries and questions. So going forward, I will not waste your time. And lastly, this my email: first name dot second name surname, and at that rate of IEEE.org. That is my email, and you can reach to me anytime. I will try to give you response in possible time. So this is the place. It is known as Kolding, where I'm living. It is in middle. If you see the map of Denmark, so it is in middle, and it is known as Three Kent area. And this Three Kent area is very famous for this renewable energy, green hydrogen, electrolyzers, and offshore wind. So there are a lot of activities, and there is a port, Esbjerg, very close to this place, where world largest offshore wind plants, part of plant, they get shipped to US, to other part of world. And then you see this assembly line of our Siemens, where you can see a permanent magnet synchronous generator, which is an essential part. If you know the wind turbine, then you know the type 4 turbine. So this is the essential part. And the unique thing is this outer rotor. Magnet is in rotor, and construction of this generator is outer rotor type. So it simplified many mechanical problem in the wind turbine. And this is the picture, and you can relate it to the offshore or onshore, and you can guess which one is. So, and then this is the new era of wind energy harnessing, where we are talking about offshore wind, because they are the appropriate candidate. Assume when we are talking about our indigenous Indian wind turbine, Suzlon, they are making until up to 5 megawatt turbine, and their blade and their assembly line, how difficult to transport through countryside. And if we want to build a plant in maybe in the coming year, maybe next decade, 50 megawatt or 100 megawatt, then imagine they were not possible to transport through the road. And that's the only way we can transport through the ship. And then this offshore wind plant, there are many other advantages, but this will be the most advantageous, that their installation and their supply chain and their maintenance through water, that will be cheaper and efficient. So this is the presentation outline. We will see why we need decarbonization, and what is done until now, and how world is looking for this decarbonization, whether this is still a talk or there is a commitment. And of course, day before yesterday, US President says that he is out of Paris Agreement, but this Paris Agreement is so strong that is binding, cannot be loose, even though US is out of it. We'll see that why. Then we will talk about this green energy focus that comes out of decarbonization challenges. Then we will also look into hard to abate sector. There is a myth when always we say that green energy, renewable energy, intermittent nature of renewable energy, then we say that efficiency of hydrogen, when we are producing hydrogen, then what is the, what is the efficiency of it compared to the battery? And these are the, myth. There is no clarity on these questions. And I will try to convince you that when we talk about green hydrogen, then that is the only way to move the world, or this is the green energy in terms of hydrogen or its derivative or e-fuel. That is the way forward to decarbonize the world. And then the reason is, one of the major reason is hard to abate sector. And we will deep dive through these hard to abate sector, and we'll see that why this only the hydrogen derivative can solve the purpose here. Then we'll talk about this P2X, power to X technology, and the major constituent of it is again green hydrogen, and I will explain through. There are a specific slide on that, and we relate this technology with for decarbonization and through again green hydrogen way. Then there is a very good candidate for making it possible. That is offshore wind power plant. And offshore wind power plant, they are the best candidate. I will advocate for it, and I will give you some reason to convince. And of course, your question will be very welcome in the end on this part also. Why offshore wind power plant are best for power to X. Then we'll see the operational and technical challenges. Then grid resilience through grid forming and grid following inverter. And what are they? And how so far we are looking and using these inverters in which mode, and why the other mode is required for future. And in the end, conclusion questions. So this is the everyday behavior of nature in the winter time in Delhi. Do we want this future for our kids? This is the extreme air pollution, and this metro, our metro is, it is having all the pollutant, and air quality index is poorest of poorest in the world, and we are modernizing, we are going for becoming superpower, and we are keeping this heritage for our grandkids. This is the way we are our national power grid. When we say that EV, electrical vehicle, and we say that EV, we bring the EV, and our all problem will be solved. Delhi and other part of country which are having these carbon dioxide challenges, pollution challenges, all problem will be solved. But do you know that all the EV, the driver for all the EV, the electricity that is coming through this way, still India is producing around 50 to 60% its electrical power through gas or coal plant, and majority is the coal plant. And these coal plants are responsible for making, this global greenhouse gas emission and making the environment poor. This is another way. How can we reverse pollution in hard to abate sector? We'll come to this in next slides. So these are the example hard to abate sector. One is this aviation sector, aerospace, and another one is this our marine sector. All the world global supply chain that is going through sea and these big ships, and these big ships, they are using the crude oil, and then they are using, of course, generator and synchronous big megawatt synchronous motors to control to drive them. But this energy source is crude oil, which is creating pollution. And it's here battery cannot do anything. They can maybe use in small boats or ferries, but for these logistic ships, there is no space for them. Similarly, in aviation sector, if we want long haul intercontinental flights, their batteries, EVs, they cannot do anything. So please keep in mind that when we're talking about EVs and decarbonize the world through EVs, then this is the only tiny part. This is a light vehicle, passenger light vehicle cars, and they are only 5 to 7% if you combine all the carbon dioxide emission by all the sectors. And it's very tiny number. And on top of that, the electricity used in it that is coming from the pollutant sources. So this is not the way. Of course, it's helping. It is also distributing the carbon dioxide percentage from one place to another, and it's smoothing out the pollution, but it's not eliminating it. So we are paying this cost, and we are creating this type of world. We see this recent last week big fire in US, Los Angeles, and we see that this North Pole and Atlantica, they are facing the severe challenges, and then we see that overall air quality index is poor everywhere. So how can we do this? How can we reverse it? And why this green energy focus required? Because this is the way. If we are using the green energy, then only we can reverse it. And why? Because in 2015 Paris Agreement, nations around the world, they agreed that rapid decarbonization is needed in 2015, around 10 years ago, to prevent the dangerous impact of climate change. The whole world was agree on this topic. There were no further talk, but they were agreed with unanimously. And then after 3 years, this Intergovernmental Panel on Climate Change (IPCC), their report pointed out that what earlier thought until then, that if we can reduce this global temperature rise 1.5 degrees centigrade, and we reduce it to 1.5 degree, then our planet is safe. But in 2008, this report says that 1.5 degree is not safer. We need to reduce it further. So more than that, we need to reduce the average temperature, and then action. So we don't have bigger time window for maybe 20 or 30 years. We need to take action now, and drastic action. And it concluded there that the window of opportunity is closing fast for meaningful action to limit the planet increase in temperature and to counter the global climate crisis. So they say that time is gone, and we need to take action now, and we cannot postpone it, and we need to take a full-blown action. So after that, policymaker, they increased their effort, and you have seen it maybe from 2018 onward. There were a lot of debates, there were a lot of webinars, there were different governments agreements, their initiative, and Government of India also raised our Prime Minister in 2019, way before Corona. Our hydrogen policy was launched, and how many 20,000 crore rupees they were earmarked. And also this offshore wind strategy, that is also few years ago already rolled out, and Indian Gazette that notification is also done. So Government of India is also taking a lot of effort to make it possible, because Government of India is also part of Paris Agreement. And last year, Public-Private Action Committee, that was in COP28 gathering, their whole world says that we will foster the technological and infrastructural solution necessary to supply the world with sustainable, safe, stable, affordable green hydrogen. So there were consensus among the world, and it is unanimous. So when we say that this COP20 statement, it is straightforwardly say that if we want to do the decarbonization of world, then we need to use the hydrogen. And why? This is just to emphasize that we need to take action now to make this planet safe for our grandkids. So there are, why hydrogen for decarbonization? So to solve this puzzle, we need to go a little back, and we need to talk about hard to abate sector. So these sectors, they are the industries that are particularly challenging to decarbonize due to their dependence on high temperature processes, complex chemical reaction, or substantial energy demand that are difficult to fulfill with current renewable technology alone. Example for these sectors contribute significantly to global greenhouse gas emission, making decarbonization essential for achieving climate target. The main hard to abate sector include. So when we're talking about EV, when we're talking about heavy duty vehicles, then that is only a small part of total, greenhouse gas emission culprit who are emitting these greenhouse gas. It's transport sector, including, aviation and marine. That is only 20% of it. So remaining 80% coming from hard to abate sector. And out of this 20% of transport sector, where marine and aviation is also an heavy duty vehicles. So around 7 to 8% is light duty vehicle, and remaining part is comes under the hard to abate sector. When we talk about aviation, or we talk about marine, or we talk about heavy duty vehicles. So you say that 93% is hard to abate sector. So only 7% comes with the light passenger vehicle. So, and these sectors is steel and iron production. So when we are having our economical growth, and around the world, every country want to grow further and do the best of their infrastructure, and this steel and iron production is one of the thing. So here steel making, it's around 80 to 20%. That is carbon dioxide emission and greenhouse gas emission is coming from here. However, there is opportunity if we use dry method, direct reduction process, where we are not burning iron ore and producing carbon dioxide. Instead, we are treating it with the hydrogen and removing the oxygen directly from there without carbon dioxide, without converting them to carbon dioxide. So this is a chemical process, and there is a companies which are there are companies who already started green steel making in Iceland and in Sweden, and they develop the formula, and they are scaling up their effort. So, and then government of India is also keen. So our steel plants are also looking into these technologies, and they are also finding the way to decarbonize the steel sector. Then we come to the cement production, and here it is also very carbon dioxide intensive, and it is a industry which is also contributing a lot when it comes to the carbon dioxide emission. Then comes the chemical industry. This chemical industry, they're producing ammonia, methanol, and various petrochemicals. They rely heavily on fossil fuel as both a feedstock and energy sources. And you will be surprised when we talk about the raw material used in chemical industry to clean the crude oil. That is the hydrogen. So there is a direct benefit in chemical industry, particularly petrochemical industry, where we can this hydrogen till now that is produced from fossil fuel, from gas, and from this chemical process, from coal or gas. So if we can substitute this fossil fuel based hydrogen through green hydrogen, then this is also a game changer. So what we say these hydrogen to gray hydrogen because they are produced from natural gas. So this will substantially reducing the CO2 emission. And this ammonia production, we come to this ammonia production, which is essential for fertilizer sector. And this, you know that with this green hydrogen, we can capture the atmospheric nitrogen and we can convert it to the green ammonia. And that green ammonia, this comes in the classification of e-fuel. We say that green ammonia is because it is a derivative of green hydrogen. And similarly, methanol, which is made from green hydrogen with carbon and capturing the atmospheric carbon and through a chemical process, that is again a different e-fuel. So in fertilizer sector, which is again around 1/5 of responsible for 1/5 of total this bad emission, carbon dioxide emission, there also we can transform it. And then comes the heavy transport. I told you aviation, shipping, long haul trucking. This is also a sector. There we can make a game change with the green hydrogen. How? If you look on the characteristics, I'm not going to those details. This because as you know that hydrogen is very good in gravimetric energy density, but poor in volumetric energy density. So because of it is poor in volumetric energy density, we cannot use it for aviation sector and shipping sector, where volume is very precious. As you know that if in airplane we are having more volume, we can carry more passenger or we can carry more goods. Similarly in ships, so if we are having more volume, we can carry more goods. And this business case or success rate, success profit of these industries comes from the space. So because of the poor volumetric energy density, we cannot use them. But if we convert this green hydrogen to e-ammonia or e-methanol, so when we are converting to the e-ammonia, then directly we can use them in fuel cell. And then we can use our own electrical drivetrain to run it. So pollution will largely reduce. Similarly, we can use the e-methanol to drive the engine, and there also we can control the carbon dioxide emission. So this aviation and shipping industry, they can also be decarbonized by green hydrogen, but the only thing is you need to convert this green hydrogen to e-fuel. Then oil and gas production. So while overlooked, the oil and gas sector itself is significant emitter due to flaring, venting, and methane leak. So transitioning to low emission extraction method and capturing carbon during production are current focus. And this way we can decarbonize this sector entirely. And petrochemical refineries, they are demanding gray or black hydrogen for their crude oil refinery process, as I introduced in the beginning of this topic. So petrochemical refineries and oil and gas production, they both be, their contribution, bad contribution can be limited. So what are the challenges in hard to abate sector? The difficulty in reducing emission from this sector underscore the importance of continuous research, investment, and policy support for sustainable technologies. That is the difficulty. And then we need sustainable continuous research on this topic. So how to reducing emission. I remember in IT Delhi, so we were having a dedicated lab in renewable energy. This our energy department, where there were research on green hydrogen, this hydrogen-based IC, internal combustion engine. There were few colleagues were doing research in liquid hydrogen in Canada and then other part of the world just two decades ago. But there were only limited places where this research was going on. And similarly in India, there were only limited places. But now, if we want to make it possible, and that's why this cost parity of $1 per kg of green hydrogen, that is far away from reality. But this is not beyond our, beyond our control. If we can do consistent effort, we can work together, like our chemical engineer, chemist, electrical engineer, mechanical engineer, and civil engineer. They all together work together and finding the sustainable technologies. Then it is possible. Because when you talk about producing hydrogen, then it is not only power electronics. Of course, it is the major constituent, but then this electrolyzer technologies and membrane and catalyst and various other part of mechanical design and storage of it with the special type of cylinders, that is coming through mechanical engineering, and it coming through material engineering, it coming through chemical engineering. So these sector can be major contributor for decarbonization through innovative technologies like carbon capture and storage. And there is a promising common solution for these hard to abate sector: hydrogen produced with green sources. And green hydrogen can be used as a feedstock for the production of chemical and e-fuel or directly as a fuel. So far we agreed that hard to abate sector, if we want to eliminate carbon dioxide emission from there, or you reduce considerably this this emission, then the only way is through we need to produce more and more green hydrogen and its derivative e-fuel, and we need to using the method which can capture and store the carbon from the atmosphere. Here you see that energy related CO2 emission from sector wise emissions. So this is the gigaton per year. So how much industry sector is doing? It's around 6 gigaton per year. Then power sector, then you see that power sector comes from 6 to around 18. So 12 gigaton per year. Then you see the tiny number for district heating. So it is again 2-3 gigaton per year. Then comes the transport sector. Then it's around 18 to 26 or 27, 10 gigaton per sector per year. And then comes the building sector. So building heating, how the building sector is emitting this carbon dioxide emission. And if we say that what is the renewable energy percentage, that is 41%, electrification with renewable energy 13%, and energy efficiency we are counting 40%. So 94% of carbon dioxide emission reduction from renewable and energy efficiency. We can replace these conventional energy sources with our renewable energy, and then we can contribute with the energy efficiency also. So we can do this case, renewable energy map case, 9.7 gigaton of per year in 2050. That is prediction. And why green hydrogen? So we say that this is the way to do it, but why we need to act now? Because there are many, it reaches to many points which can be considered to roll it out further. First thing is sustainability. No doubt, this is the sustainable solution. We can capture the electron, convert it to molecule, store it, convert it to derivatives, and we can use across the sector. And then end use is sustainable, we convert it to water. So that is the complete cycle. Then energy efficiency. World is paving a lot of effort and creating this whole energy sector energy efficient, whether it is production of energy, utilization of energy, or storage of energy. And of course, we know from our power electronics domain that we are having there is a considerable research on not only on the component, on there is a research on sector coupling, there is a research on efficient thermal management, there is a research on optimized control, and there is a research on methods, how can we optimize no load losses of machines and equipment, and continuous work is going on. And as example, when we are using direct online motor for HVAC sector, or we are using variable speed drive, then in second case we can reduce 40% losses. So, and particularly at no load or light load condition. So this is also making hydrogen production efficient by using efficient converter, using the latest technologies in these power devices, silicon carbide and gallium nitride devices, which are up to 1% more efficient. And then if you continuously just imagine for a 1 gigawatt of electrolyzer plant, and it is 1% efficient, then how much extra hydrogen it will produce? For your reference, I can give you an example of my previous company, which are having a 20 megawatt electrolyzer plant, and it is producing per day 8 ton of hydrogen. So if you make it 1% efficient, then you can save in 20 megawatt, 1% of 8 ton. So how much it is? 8 ton. So it is around 80 kg. How much? So 80 kg for 20 megawatt. Then multiply by again to 20, and then you see that how much that number comes in tons again. So you can save tons of hydrogen in a 1 gigawatt plant. And this is looking in 0.5% to 1% efficiency improvement, making the business case positive for these hydrogen producing companies and hydrogen plants. So and next one is the experts. We do have all kind of expertise available, although we are not hitting on the sweet spot of installation and production cost, but we do have all kind of expertise that is ready to contribute and to finding the optimal solution. So from oil and gas sector and from offshore sector and from power electronics domain, experts are available and they are working day and night for making it possible. There are a lot of startup also in India and in Europe and around the rest part of the world. They are working for optimizing it. Reliability, that is already world knows, India knows how to store, how to transport, how to use the hydrogen. So and reliably. So this is something not beyond our expertise. Then electrification, lot of things had been done in electrification sector. Power electronics is a mature subject. I can give you an example of India. When we did our master's and doctorate, there were only handfuls of institute or labs. But now you name the institute, you name the company, everywhere you are having activities related with electrification. So, and no engineering institute is not equipped with 2 or 3 departments. So they specialize EV undergraduate courses and renewable energy undergraduate courses or green energy bachelor master courses are started. Then sector coupling. This is another example where we can get excess heat of one sector to make efficient other energy sector. I can give you example of my previous company of fuel, where our electrolyzer plant, which was alkaline electrolyzer, that is having a sector coupling with the district heating of town Fredericia. So this district heating pipeline that is crossing through this electrolyzer plant, and there were interface to exchange the excess energy from the district heating to electrolyzer plant, because you know that if we increase it when we are starting the electrolyzer with certain temperature, then it needed to ramp up with certain temperature, and then its result in efficient overall turnout. And in another case, when you ramp down the production of hydrogen, then you are having excess heat in because of the losses in the electrolyzer plant, because it's continuously running for a year or 2 years and it needs maintenance. Then this excess heat, so electrical energy is converted to hydrogen and excess heat, and this excess heat can be poured to the district heating, and this way it is more efficient. And this is another example is if you are having a wind park, offshore wind park of gigawatt capacity, then every wind turbine connected to this wind park, for example, it's 10 megawatt wind turbines, and there are 100 of these turbines in a park. Then every turbine is having around 10% losses. These losses mainly in the generator and converter. And these 10% losses is around 1 megawatt of power. And this is wasted as a heat. So if all the, these offshore wind plant, they are equipped with electrolyzer plant inbuilt in these wind turbine, then we can use this excess heat to produce, and particularly for solid oxide electrolyzer, which is running in combined electrical energy and heat energy, there we can see considerable efficiency improvement, and we can back use this heat energy, and we can make our this offshore wind turbine, particularly converter and generator, more reliable, and we can capture the waste energy, and we can reduce the hydrogen price. By the way, we have filed a patent on this idea through I think NIT Meghalaya. Yeah, so this is a patentable idea we have filed. So, and then the technology available here, I think technology is available, but it is not on the cost parity where we want it. So there is we need to do the work on it. If we look on this slide, then we will see the big picture, and we capture the main findings what we talk about so far in the hard to abate sector. So how green hydrogen decarbonize hard to abate sector? We can recapture that we can produce large scale energy, renewable energy integration, hydrogen through large scale renewable energy integration. And here you see that you are having wind and your hydrogen storage, electrolyzer plant, and you are having solar plant. Then you can distribute energy across sector and region. So you can store through tankers or through ships, you can distribute this energy across sector. And this converted molecule from electron to hydrogen molecule, they act as a buffer to increase system resilience. So in the intermediate point, these store hydrogen that can be act as a system resilience or buffer through, we can feed in, we can connect the grid through the fuel cell, and instead of storing the huge lithium-ion battery in gigawatt level, we can have this our fuel cell connection, and then we can provide as and when we need to support the grid through this. Not only this, where we can support the grid and increase the system resilience, we can also decarbonize transport sector. So whether it is light vehicle, light passenger vehicle, or heavy duty vehicle, or marine sector, aviation sector, everywhere we can decarbonize it, and then we can decarbonize industry energy use, because energy use in terms of heat energy or electrical energy, there also we can use the hydrogen, and then it can serve feedstock using captured carbon. So if we want to produce ammonia, we can capture nitrogen. If we want to capture methanol, we want to make methanol, then we can capture carbon and use the green hydrogen. So this you can see that for fertilizer, for agriculture sector use, we can produce urea, and then main constituent is green hydrogen. Then also we can decarbonize the building heating, and we talk about district heating, and there is a big scope in India. It may be northern region, but most of the Europe and part of US, they are highly benefited by this building heating through green hydrogen. So being talk about it, let's see what is the P2X and how it helping decarbonization of hard to abate sector. P2X is this transform excess renewable energy into other form, such as hydrogen, power to hydrogen, synthetic fuel, power to fuel, and chemical, power to chemical. So far, what we talk about, we can summarize. If we produce from renewable energy, hydrogen or e-fuel, then this is the combined solution that is known as P2X. And this can help in transformation in joining of sectors. So you see, this is our grid. These are our renewable energy sources. Then this is our power sector. So power sector coupled with the power storage, we can do with the battery storage, and this power storage can be used for the transport sector. And transport sector also help. For example, we talk about vehicle to grid and grid to vehicle and all those scenarios. So they're also intercoupled with each other, and this is also helping to making grid stable. When we are storing the power, we are trying control power, and we are injecting control power. And the same from power sector, we can convert this power to heat, and we can have heating sector and heat storage. So all in all, we can see that through renewable energy, we can not only help power sector, we can help transport sector, and we can help heating sector. And this stored energy, that is in terms of hydrogen or derivative of hydrogen. We can further dig into it, and we can see that in power to X, you can use the renewable energy, convert it to hydrogen, green hydrogen, capture the atmospheric carbon dioxide, and then adding it with the hydrogen, and then you having storage of it, or you have a e-fuel and then convert it to e-fuel and store it. Then it comes to this, produce hydrogen that will use in, you can store it as a power feed. Means to grid resilience, you can have storage of it, or you can feed into building, or you can use it directly to the industry. And when it supported to the transport sector, then it is for aviation sector, transport sector, your rail sector and marine sector, and even in your charging infrastructure. So this way, we can see the entire landscape of, power to X. Here, left hand is power, and you see in the right hand there is a X, means where we are using this power. What is the application of it? So far we talk about that we need green hydrogen, we need power to X, and in order to particularly solve the issues with the hard to abate sector. Then I also introduced you that offshore wind, that is a good candidate of power to X. Why? Storage and flexibility. P2X addresses the intermittent nature of offshore wind by storing energy for later use. So here we are decoupling the electron flow through molecule. So we are storing this intermittent energy, and then we are making a regulated flow. Offshore wind can produce green hydrogen via electrolysis, which can fuel hydrogen-powered cargo ship and supporting a zero emission. We talk about it. And this also offshore wind electricity power electrolyzer that splits seawater into hydrogen and oxygen. This is another advantage. There are already techniques available to convert the seawater to pure water. Although those special equipment, special pump, desalination pump, they consume energy and lot of energy. So we can do more and more research on those areas, and we might develop some kind of chemical purifiers or chemistry based solutions. So to cheaply convert this water. But the biggest advantage is the raw material for producing energy that is available in abundance, and that is one of the major advantage for offshore wind based P2X.
And another advantage is cost parity potential. Offshore wind combined with large-scale electrolyzer can achieve cost parity with fossil-based hydrogen by 2030. There is a pilot plant running in Esbjerg in Denmark, where a lot of big industry groups in Denmark they joined forces and they are having experimental 10 megawatt offshore wind with electrolyzer plant. And they are working on it for successful operation of it. So learning from this plant, they can be rolled it out, and scientists are very positive about it that we can get the cost parity by 2030 in green hydrogen production if we are continuously doing our effort in this area. So integration with fuel cell vehicle. Hydrogen can be used to power fuel cell vehicles, offering long-range solution for heavy transport sector. So if we can have this offshore wind-based green hydrogen production with the cost parity, then we can integrate it to the hard-to-abate sector and particularly heavy transport sector. And please pay attention. We are talking about ships. So if we are in the ship in the sea, we are having these offshore plant. Then a lot of fueling time for ships that can be saved. They can do their operation without any major interruption. That is also saving the economy. And there are a few challenges, but I see particularly for India and for rest of the world, these challenges are different. For us, we do have a big experience or a legacy of maybe 5-decade experience of oil and gas from offshore sea. So ONGC, our one of premium body, is having a lot of experiences how to handle these offshore stations for exploring the crude oil and gas. So infrastructure wise, there are similarities when we are talking about handling of this green hydrogen from the offshore sea. Then comes question with the offshore wind installation, tower installation, foundation. If there is need, we can act on it. So it is a patented technology. 20 years back, Denmark, Stilsel, one of the scientists here, he developed this foundation method. But there are many foundation methods now. It started from jacket base, pile base, or floating structure base. There are many techniques. And we started our journey in Kandla port, where we are building these offshore wind plants. So if we pay more attention and we do the consolidated and coherent effort across the institution and industry, we can develop these techniques. And then we can, our learning from ONGC, offshore operation, and these structural design innovations that can keep this capital cost low. Technology maturity. P2X technology, especially larger scale electrolyzer, are still evolving and require further optimization. So this is a challenge. I can bring a very interesting aspect here. This Nel Hydrogen, this is the oldest producer of electrolyzers in the world. And they were working for this technology from last 120 years. Because this green hydrogen is not a new thing. There are certain industries which rely on very pure green hydrogen, and that is produced through electrolyzers. So, but their capacity was within megawatt, and they were using harvester-based power supply, the old, electronics, until just 5 years ago. But now they are doing a lot of innovations, they are putting a lot of effort, and they want to change in a night, but that is not possible. So the problem is technology optimization that has been not done, and now there are many players. You name the companies, there are maybe more than 20 companies who are having a roadmap of building 10 gigawatt more capacity in next 5 years. So world is working on it, but it's still we have not. We in the last decade, many decades, we have not spent our time on this technology. So still we need effort, and but the thing is, we will be succeeded, and we will find the efficiency improvement on it. Regulatory barrier. So we need harmonized policy across energy, transport, and environment sector. And here we are good. Government of India is taking good initiative, and we are having our framework already published, and we are having our bidding document ready. And already we bid few plant, and our by 2030 we are going more than 5 gigawatt of solar wind. Another advantage why we saying that this is cost parity is possible because of the power electronics advancement. So this flexible AC transmission system through StateCom and PVRs, especially solid state transformer, they are making localized power quality management and enhancing the grid stability. So this is something which is very positive. Then we are having high efficient AC-DC and DC-DC converters, and particularly advancement in silicon carbide power devices, which are backbone for the wind turbine. So all the power modules, they are made of silicon carbide. Similarly, railways and EV sector, they are equipped with the silicon carbide high efficient power electronics. So we see that in the high power sector, through advancement in power devices, we are gaining the efficiency, as well as we are gaining the better thermal management, and we are having optimized cost. There are new topologies of multi-level converter, module and multi-pulse converters. So particularly multi-pulse converter, this is something we have whole world, particularly, and in India also, in our lab also, we did a lot of concentrated research on it in last 2 decades, and there is a very cost-effective and simple way for converting unidirectional AC to DC with optimized performance and using less power devices and using even passive power devices. The only question is whether we are ready to pay for copper or we need to pay for the power devices of silicon, which is one way or another way. We see that power devices, they are having better performance in terms of space and availability, and then particularly control and ease in control and space required, and what way that we do the thermal measurement. Whereas in copper-based devices like these transformer, multi-pulse transformer, where we are using multi-winding connected in a different way to different phase sequence and different phasor lags, so that in the end we are getting a optimized and regulated with less de-sealing ripple supply. So whether we want to invest in copper, where these multi-pulse converters mainly constituent is transformer, windings, and diodes. But I see that this is particularly multi-pulse converter topology. This is because of the nature of electrolyzer, where we need only unidirectional power supply, and efficiency is a major factor. So whatever type of power devices you are using, whether it's silicon carbide also, there is a certain losses. So we can avoid these losses, or we can reduce these losses when we are using these copper-based solutions. That is something impacting green hydrogen production and fuel production if we are relying and we are developing some kind of solutions. So if you look on IEEE journals, you will find nowadays reuse of these multipulse converters for green hydrogen production. So this is some tip for you guys. So if you have worked on this area in the past, this is the time to to commercialize your ideas and to come up with this green hydrogen era and publish your work in light of this application. And then we talk about power management system for hydrogen storage and fuel cells. So this is also very much a bidirectional DC-DC converter for efficient charging, discharging of hydrogen fuel cells. They are available now because we already work very intensively on the charging infrastructure and charging solutions, and development of compact DC AC inverter to power hydrogen fuel cell for transport and stationary applications. And here there is a big synergy between the conventionally battery energy vehicle, battery electric vehicle, and hydrogen fuel cell vehicle. And so we can get the learning of BEV and we can implement here. So, and again, this is happening through the advancement in power electronics. So far, we talk about what is the issue with this carbon dioxide emission and why it is happening, who is the culprit, what is the way of solution, and how power electronics is helping. But on the same time, this also a challenging part, in particularly if we are integrating more and more renewable energy sources in the grid. So because these sources are equipped with inverters, and inverter-based sources don't have any inertia. So, but when we talk about this issue, solution is also lies inside these inverter-based resources. And I'm just giving you just a abstract here that a grid farming, we will deep dive into it in the next slide, but I'm giving you this hint here. Power electronics advancement in virtual synchronous generator based control and grid farming emulation, that is also creating a safe and stable future for power grid. So this is one of the research area where you will going to see in next 2-3 years a lot of work, and this is one of the prominent field where your publication will be prioritized, and to see that all the bright-minded, they will contribute here a lot, and you can also think of it. So now we are touching upon grid, and there is a big synergy between hydrogen power, hydrogen-based grid and for electrical power grid. So hydrogen pipeline grid and electrical pipeline, electrical power grid, then they can exist in parallel, and they can help each other, and they have a perfect coupling between them. You can see that the power grid that is fed in with different power plant, output of different kind of power plant, and this is also equipped with conventional storage. So you can hydel or battery or chemical, you store the energy here and feed in energy back to the power grid. But there are limitations here. You cannot make hydel power station, pump storage station everywhere. Battery is having a big issue of carbon footprint and chemical effect of lithium. It's the mining process and other things. So when it comes to the conventional storage, it is limited. When you go to the hydrogen, then you see that you can solve the purpose of many industries, so transportation industry, metal production, fertilizer industry, chemical processes, industrial processes, and distributed heat and distributed power. So everywhere hydrogen can solve it. So power industry and hydrogen, this power network and hydrogen pipeline network, they both exist in parallel and they are coupled through each other. So you see that we can, through the hydrogen, we can support the grid stability, grid resilience. So through the hydrogen, we can do the power generation, and then this power generation based on fuel cell, we can feed into the grid. And this way, there is a stability. And on the other hand, you can use this power to generate the hydrogen. So this is the complete loop. And I can give you an example. Country like India, we don't need to invest solely on our electrical power network or national grid, because all our renewable energy sources, whether it is solar or offshore wind, they are on the coastal line of India or on the desert places. So Rajasthan desert. And in these areas, we don't have availability of a strong grid. So we need to make a grid infrastructure. And that is a huge investment. Instead of that, in these regional area, we can build a hydrogen pipeline infrastructure. And we are good. We are having all the knowledge on these pipeline, gas pipeline. So, and then we can couple these hydrogen pipeline, to our national power grid in certain places. So we can make a resilient and a strong, our power grid. At the same time, we can take advantage of these coastal areas and their remote locations, and then we can use this energy in mainstream. So this is something possible, and I think India government is also thinking in the same way. So being talk about that our inverter-based resources, whether it is solar power plant or onshore or offshore wind plant, they are equipped with inverter, and through these inverter, we are connecting, we are feeding power to the grid. And if you see the whole cycle from source to energy conversion, you don't see anywhere inertia. Photovoltaic don't have any inertia. Similarly, onshore and offshore wind plant, they are also not having inertia. Even there is a maybe negligible inertia, but that inertia is also decoupled, first decoupled in terms of power electronics, and then another, they are intermittent in nature. So we cannot rely on the values. Whereas our power network, that is dictated by coal and gas plant, they are more than half of our total power production, 420 gigawatt or so, that is coming from those sources. I'm taking example of India. So the inertia of coal plant and gas plant, that help to stabilize the grid through power and frequency curve. But this is not the case for our inverter-based resources or our, this green energy or green hydrogen or power to X thing. So if we want to modernize our grid, making it smart, then we must be ready for this huge investment. Or we need to invest money for energy storage solutions. So that is again a huge investment. And we need to make this grid strong enough. And again, a considerable amount of money is needed to invest here. And on top of that, if we are relying alone on the power grid, then we must be ready to lack in inertia and its stability issue. And these renewable energy, they are resources, they are far from demand sector. So for all those problems to solve it, there is a unique solution that is grid farming. So this in grid farming, let's move this offshore wind advantages. Let's move to the one more thing before moving to the grid farming. Let's say why we are talking about why offshore wind, onshore wind, and solar. If you look in this curve, you will find that our conventional coal, nuclear, and gas plant, they are still having the same price what was just a decade ago, or even it is costlier. But if you look on wind and solar, they are reduced exponentially. So they are cheapest source of energy, and that's why whole world is going through this solution for solar and wind. So this is not only helping to decarbonize the planet Earth, but it is also helping the economy. But you know that why it is happening? Because world thought that this is the way and we need to move forward with this way, and everybody did the considerable effort, and then it result in the reduction in the price. And the same thing will happen in the green hydrogen journey. We are still in this infancy era where our cost is around $8 per kg or $6 per kg depending on the renewable energy cost. But if whole world do continuous effort, then in coming years, in coming 5 years, we can make the same history as we make for electrical vehicle. That is another example we are having in front of us. Just 3 years back, nobody was realizing that this EV will be the future for India. But now you see that this is, we are the world biggest EV user, particularly in 3-wheeler and 2-wheeler. So in green hydrogen also, this cost thing and technology cost will reduce, and then we'll see this success. This is something carbon neutrality, and we know that the best one is the wind, and even solar is not good in terms of carbon neutrality because of this material issue and recycling issue. This wind energy is gaining a momentum from last 20-30 years, where it started from kilowatt and it reaches to the megawatt and maybe 20 of megawatt and more than that. And future direction is going in this way. So necessarily. And this technology trend is having a very interesting characteristics. So most operational project, they have fixed bottom monopile substructure. And monopile are still most common substructure choice for an home project. This was invented in Denmark. And this is distributed in monopile can be attributed to their simplicity and manufacturing maturity, make them lowest cost option in most markets. Alternative substructure are also available, and the supply chain to accommodate seabed soil type unsuitable for monopile. So if there is a seabed is not suitable for monopile, then mitigate construction wise additional potential installation visual supply shortage, and so we are having alternative solutions. There is a floating offshore wind energy opportunity to tap into new market. Then we are having there is a strong competition among floating substructure design. Most announced floating projects have opted to use some variation in semi-submersible platform because it is expected to be easiest way to deploy from existing ports. So we talk about monopile and jacket, and then we are having this floating offshore wind structure, and we are moving in this direction. So the Stars and GV, one of our signal plant for standardizing around 15 megawatt for turbine capacity. But Siemens Gamesa, they are doing the world most powerful offshore wind prototype. They announced it will be coming early 25. So soon, maybe we'll see this. This is the technology trend. We see that gravity-based foundation, tripod-based truss type foundation, semi-submersible foundation, or tension leg platform foundation, or vertically structured foundation. So these are the type of foundation, and around 30% cost among any offshore wind plant that is lies in this foundation part. So, and we see that Chinese, they are going for 22 megawatt power size, and upsizing grow, this call is slow down because of the availability of port, diesel, and manufacturing infrastructure become more apparent. And just for your knowledge, whenever we are building any wind park, so this comprises of many wind turbine, and this each wind turbine part that can be carried out by a special vessel, sea vessel, and this sea vessel is designed according to the dimension of that wind turbine. So you see that when you are developing a higher size offshore wind plant or offshore wind turbine, then you need to develop, your sea vessel also, which can carry this and which can help to installation. And then, of course, this the seaports must be available to handle this, logistic of these gigawatt of kind size wind turbine. So fair competition persists among wind turbine manufacturers, and Western manufacturers face significant financial challenges, attributing billions of dollars for financial losses to supply chain constraint, geopolitical uncertainty, and warranty provision. And on top of that, day before yesterday, when Trump taken out USA from Paris Agreement, and they stopped supporting offshore wind, then the US is also having certain challenges. But please note that the way wind energy and solar energy production is cheapest, and country like India, who is having brightest mind, youngest contributor, and knowledge, and then millions of engineers force, then we can lead the world on this renewable energy journey. So I don't think our effort will be slowed down. Even we will increase our effort, and we will show the world how to handle this situation when US is making challenges. And it will be the same success story, in my view, like what we achieved during Corona time. So it is opportunity for us, and we need not to be affected by the negative thought of US politics. So this is the levelized cost of energy, this offshore wind energy cost trend, and we see that there are different agencies who predicted these costs, but in the end, they are all going down until next 3 years. They are 3 to 5 years. They say they go down, and they will be around how many US megawatt hour? So this 60 to 80 US dollar per megawatt hour. So that is something very positive outcome of these cost train of levelized cost of energy. So it will also show significant improvement in offshore wind energy cost. Dr. Giri, I have a question. How much time I am having?
Yeah, sir. Actually, time is almost up, and we should take only 2-3 minutes, sir.
Who is the second speaker after me?
Yeah, actually, Dr. Urmil Parikh is going to deliver after that means at 5 p.m.
Okay, so means he's waiting. So maybe It's an interesting talk, and I can talk and talk. So, but let's summarize it here. And this, let's go to this IBR. We will talk about these challenges with the IBR, and next 5 minutes I will try to go faster. But please keep 5 to 10 minutes for question answers, even though, and please request to the next speaker if possible. Okay. So this is the IBR inverter-based resources penetration.
म्यूट कैसे हो गया यार?
So this is IBR-based penetration in US national grid capacity forecast. We see that all the capacity comes from the solar or wind or battery storage. So all the inverter-based resources will contribute. And as you see, the conventional natural gas is only tiny number, 4%, and nuclear is only 2%. So we see that it's a prediction, it's a data from US. So we see that all the new energy sources which are integrating to the grid, they are coming from the inverters. So what is the drawback of it? So we see in the past, we are replacing these inertia-based generators by these inertia-less systems. How it affect? We see that these variable, not only they are variable in nature, but they don't have any capacity to hold the grid in case of any power failure event or cascaded power failure event. So they are not able to keep the frequency of the grid constant. And another thing is, whole national power grid, they are running on the power frequency curve. So they are defined power frequency curve, and that is no longer valid for the inverter-based resources. We can see like this in the old, the existing power, conventional power that is dominated by a synchronous generator, and it is our IBR is only tiny portion, and it cannot change the grid stability when IBR is tiny portion. But when IBR dominated power system, we remove all the synchronous generator based sources, then IBR dictate the real and reactive power. So this is good and this is bad also. Bad in terms of if you are not doing anything, then it is bad. But if we are doing good, like we do have power source, we do have fast acting power source. So we need to reinvent our power frequency curve. We need to reinvent how to use them in synchronous with the power grid. So we can change the frequency, we can change the real power, we can change the reactive power, which we are changing right now, real and reactive power. But that is dictated by the grid. But in the grid farming approach, our inverter-based resources will be intelligent enough, and they will be coordinated. They will have the coordinated effort, and they will change not only power, real and reactive power in passive mode, but in active mode, and they can take a role to dictate the grid. So frequency that can be dictated by these inverter-based resources according to power, power frequency curve. And they will help to black start also, black start facility, and they will making grid more resilience and stable. An example is, I'm giving you example. If you look on the roadmap of EU, then you will find that they already dictated that by 2050 we need to have a demonstrator for all these wind plant. They will be capable, offshore wind plant, they will capable to support the grid. And fortunately I'm working on this grid farming inverter part as a consultant. So I'm working on this. I cannot disclose more information on it. And by 2030, all the wind plant, they will be capable to inject, to control the grid, and then they work in the grid farming mode. This is the data for European Union, and this is for the US. So you see that IEEE guideline. So you see that world is ready for this journey. and maybe we can deep dive at certain point of time. So we conclude green energy sources show significant growth in last decade. Renewable energy fuel, they are fuel for decarbonize the world, and offshore wind P2X, that is a powerful combination. And power grid has its own challenges with integration of more and more renewable energy sources, particularly with IBR. However, there is a light in terms of grid farming where we need to do work. An offshore wind power system with grid farming technology offer a pathway to decarbonize planet Earth and reducing dependency on fossil fuel. These are our key takeaway. We see the green energy shift. We see the grid resilience and role of renewable energy sources. And we conclude with advances in offshore wind, green hydrogen, power electronics, and P2X that is paving the way to decarbonize the world with grid stability with IBR. So thank you so much for your patience, and I welcome your questions now. I'm sorry for taking little bit time from the next speaker.
I have a question, Ashutosh sir. I am the another speaker, sir. I was listening to your session. I am the next speaker. It was very interesting, and I am from Hitachi Energy R&D Center in Ludvika itself, Sweden, near to your place. I have one question, sir. Do you hear me?
Yes, I am. Please
sir,
go ahead.
I was in Scotland, and we were talking about black start only, and that to wind farm. They want now. We had a very simple question. Even I had one very simple question. Now they wanted, imagine that there's a black start, everything is shut down now. Now, if you want to charge a transformer with second harmonic requirement, the inrush current of transformer is a second harmonic in which you might have 2 pu, 3 pu, 4 pu inrush currents. Do we have a capability from, wind have a shaft, I understand, and it may little bit inject a reactive power, but is it possible to support energization of a transformer where you need 3 to 4 pu inrush currents, where the inverter will block the second harmonics? Or they were talking about some designs which can still support some second harmonics, but how we are onto all this type of issues where we don't have a support from conventional generation, shaft based generations, and we want to black start to support harmonic injection.
So understanding your questions, when you're talking about this ideal scenario of grid farming and supporting the black start capability, and assuming that whole world is going to the black start, everything is off, and you want to start from the scratch, then you need to think. This is a hypothetical imagination, and it is, but I appreciate your thought on it. But if you are imagining that situation, then you need to also think of it. Then in that situation, we will not having these conventional transformer. We will have a solid state transformer, and our more
conventional, sir. I was with 25 people who are decision makers and who are the grid regulator. I had a meeting 1-to-1 with them very recently, and even before 2 days we were talking about it. So is it possible to inject second harmonics? Are there some inverter designs which can still permit some second, not to very high level, but are some people working on it? Because we cannot change what they told me. I am just giving feedback from some utility. They told me that we cannot change the assets which are existing in the system. I straight away told this is challenging. As you are saying, exactly same I told. But then they are very seriously working on it.
For me, because your question is specifically to the second harmonic, I'm little conservative here to comment it, because I never thought of it. This thing, second harmonics, whether it can produce, because I'm a motor, basically power electronics motor control engineer, and then I go through now to power system. So that is not my domain, but I will look into it. And I will find the answer of this question, this second harmonic, because I'm very optimistic, man. I'm very optimistic. So far, whatever solution I have, whatever problem comes to my table, I always have a way to move forward. So let's see. And thanks for just igniting this thought. And we will be connected through mail, and I will give you the answer of it. And thank you so much for it.
I think so, sir. Just I would like to add something in it. In continuation of Dr. Sanjeev sir's answer, I think so virtual synchronous generator may be one option to inject. That means we have to.
That is the problem, Ashutosh sir. The problem is, the utilities, they have to justify the investments.
No. Suppose if we have a DG set, otherwise, if nothing we have, then small hydro is the only option.
No, they told
conventional
me one
small
thing. I
hydro.
can give input, Ashutosh sir, for benefit
Yeah.
of everyone. But I am not from that domain. But they told
Yeah.
me one thing, that whatever turbines they manufacture, they have no, they inform them to develop a turbine which can inject 1.1 per unit equivalent reactive power. But then how inverter will behave to it? I am not from power electronics background, but
No,
this
no,
type of
actually,
discussions we
see,
had a lot
No, no.
recently.
I will stop.
harmonic injection techniques are available, sir. Actually, harmonic injection techniques are available from inverter. We
Okay.
can inject any harmonic, either triplen can be injected, second harmonic, first fundamental
Provided the
can be
source is
created.
supporting it.
Yeah,
Provided
yeah,
the
No.
source
yeah. But
supports.
power electronics is
Sanjeev sir is
required
saying
to.
something.
Yeah.
Dr.
Sanjay
Ashutosh,
sir.
I was skeptical here because I've never thought of second harmonic to inject with power electronic sources, and I will not comment. But if you say that it can be possible with the power electronic sources, then I can tell you now what we are doing. So what we are doing in every power electronic sources, inverters, there is a thermal management system, and this thermal management system gives their capability to increase their current. So, and when we are talking about this grid farming, then we are talking about 20-second capability, and we are talking about general reliability basis of power
20
electronics.
second.
20-second and in only 5 to 6 times or 5 to 8 times in a year. So this is the prediction. And why I'm saying that, we are doing a project, and what we are doing, we are increasing the capability of our inverter to additional resources to increase this start time current. And in the future, all the inverters, whether the wind turbine inverter or solar inverter, they will have this capability, thermal management capability inbuilt, that they can increase the capacity to 1.1 or 1.2. Here we are talking about 10% in our grid farming project. So I'm looking on this hardware part of it. So that
Thermal
is
means, sir,
possible.
are you talking about second harmonic which creates heating effect, or some other harmonics which will further increase the heating because of the opposition to the power frequency, right? In that sense also you are thinking, right, when you are speaking this, to understand.
No. See, for me, I cannot comment specifically for effect of this second harmonic, but
Fair enough, sir. I'm also technical.
so
I can feel.
but that current is possible. You can inject the current, and this scenario of black start capability. We are talking about wind park. So you see that. You talk about rightly that there is a grid operator, and that is a big role of grid operator. So grid operator will, instead of doing the load setting, they will work coordinately, and then they will say to the big wind parks, that 3 gigawatt wind park or 10 gigawatt wind park, these wind park will work in a master controller way, and they will be controlled by these wind operators, and there will be standard practice for that, so that coordinated way of control. So if any wind park is go out of service, then they will start black start. Individually turbine will be connected, and later it will be connected to the grid. But this second harmonic, I will investigate in it, and I will share with the data.
Sure, sir. Thank you for your thoughts, sir.
Yes.
We learn from each other.
Thank you, sir. Thank you for your politeness, and thank you for your wonderful session. And actually, we are very much thankful to you, sir, for your wonderful delivery. And from this discussion also, participants, because they are directly listening to us, Dr. Urmil Parikh sir has also enlightened for the same. So participants may have got some insights from this discussion also, whatever after your session took place. So I am very much thankful from entire on behalf of GEC Bharuch to you, sir, for joining and giving your valuable support and time. And I hope so. We are looking forward for your other engagements with GEC Bharuch in future. Thank you very much, sir. Thank you very much. Namaskar.
If you want to continue, Sanjeev sir, if you want to listen me for some time, if you have time, you can listen. We are working on point. I'm global head for control switching technology. I'm standard committee member, and I'm going to share some very enriched field experience. If you have some minutes,
please.
It's very interesting.
My pleasure.
Yeah.
Thank you so much.
Now, Urmil Parikh sir, the floor is yours. Please start.
The marathon starts now.
Yeah.
But do your participant need 5 minutes bio break? Then we can have 5-minute break, because suddenly we are changing a subject. So if you want 5 minutes break, we can have no problem. Quick break, 5 minutes.
Yeah.
एक ले लेते 5 मिनट ब्रेक ले लेते सर.
हाँ. Participants, if you want to
Quickly,
take
5 minutes,
5-minute break, we are taking for tea break, virtual tea break from here. And from your end, it may be real tea break. So you can take your tea. And then we are joining at 5:20 once again.
Perfect, sir. And we'll continue maybe 10 minutes more, 10-15 minutes maximum. Huh? Don't worry. I will not extend too much. Don't worry, sir.
Yeah.
And if they are interested, we will have another session next Saturday. No problem, sir.
Sure, sir. We will organize your sessions for our students as well. Because this is the really we are looking the real situations that is happening in the industry. You are discussing on real pictures of the industry. So many things, conceptual things which is useful in industry. So that is very interesting, and I hope so all are enjoying, sir.
Yeah. We start in 5 minutes exactly, huh?
Yeah. And Dr. Sanjeev sir, it is your convenience if you wish to stay. Otherwise,
yeah, exactly.
Yeah, as per your convenience, you can, sir. You can decide whether to stay or not. It is your convenience.
It's my pleasure, and I will attend it. Thank you.
Yeah. Thank you, sir. Thank you very much.
And you can also correct me if somewhere I am wrong, because I also learn when we discuss.
We all are learning, sir. We all are
Exactly.
learning from each other. Yeah.
No worry.
And Dr. Karthik, you have a question? You can put in chat if you are on mute, maybe. And Ashutosh sir can read it. Ashutosh sir, someone is having a raised hand.
Yeah, actually, in the chat box, let me see in the chat box.
The chat is not working. I don't know why. I don't see the
No, chat is working, sir. Chat is allowed actually. Chat is available to all.
It's showing me having trouble loading the messages. I don't know. But maybe it's my problem. I don't know.
It may be some connectivity issue. Otherwise, connectivity issue is not there from your end, because audio video both are.
Can we unmute Dr. Karthik if you can unmute him? Because maybe he's not able to type because
Actually, he has written a very lengthy message. Just I am reading.
Okay.
I think so. It is somewhat. He's asking something related to his professional growth. What he is writing, what he has written. Just I am reading it. Sir, I am Dr. Karthik Reddy. More interested in joining Hitachi. In fact, I tried 2 to 3 times for the position of system.
Don't go to this topic here. No. This is not relevant. Sorry, Dr. Karthik. We cannot talk about it.
Yeah. This kind of actually things can be written to you personally, but here in public it is not advisable to discuss here in public.
Correct.
Because it will create some kind of conflict of interest. So
Yeah, conflict of interest and compliance also for me.
Yeah. Dr. Karthik may understand our limitations. I hope so. He may have understanding of all these things. Thank you, Dr. Karthik. Though you have written, but we have that means clear our limitations as well. So please understand.
Sorry for this.
No worries. Now I think so. You can start, sir. Your
you can
session.
Start, sir. Exactly.
Yeah.
So we can start now. Let me see my time now. Okay, so we have 1 hour 21, 1 hour 31, 32 minutes. Considering 10 minutes to extend. 10 to 20 minutes to extend, I think 20 minutes. So I will take around 15 to 20 minutes more, sir. I will try to finish, sir. Let us see. So we talked about, am I audible and my screen is visible quickly?
Yes. Go ahead, please.
So we talked about the control switching as a system. So let us see how the system look like. See, you have a source, which is the bus bar, which is connected to a voltage measuring device. Then you have close and open control switching commands. Then you have a control switching relay. You have circuit. This we will talk about. These connections we will talk about after 2-3 minutes. But this is overall system. The load is like a reactor, capacitor, or transformer. What we discussed before the session of on the previous session. I mean. So this is the overall system. Now the key role plays always is of a circuit breaker, because it's a mechanical device which has so many sort of uncertainties, especially statistical behavior. Like if it's IGBT, if it's a power electronics, it has a nanosecond response time. But when we talk about control switching on a circuit breaker, it's a more mechanical uncertainties. And I was part of a SIGRE committee where I wrote a chapter on suitability of circuit breakers. I was surprised. I entered this in committee as an Indian committee member. I shifted Sweden before 3 years, but I used to go to all the countries in world for my work for more than 15 years. But when I entered in this committee, no one was talking about a breaker. I told, come on, I mean, at the end of the day, the switching is done by a circuit breaker. So what about suitability of a breaker? So what I did is I just tried to write a guideline, which is part of the SIGRE 757, where I was a part of as an author also in this SIGRE committee. So if you imagine a sine wave, you can see my cursor also. So this pointer. So if you have a sine wave like this, positive to negative, both half cycles, I invert the negative half cycle. It's a break voltage across the breaker. My video should be on. Let me try to on my video if it's off. Yeah, it is on. So you can see my video as well. So what I'm saying is, imagine again you have two contacts of a breaker, and UAB, what you see on the screen, is across the breaker, where you will have the current to start or current to interrupt. So now imagine that my target is peak, which is this green line or green circle here. Now, when you close the breaker, your dielectric strength will reduce. When you are closing the breaker, your gap is reducing, the stress is increasing, your dielectric strength is become more and more weak, more and more weak. And at this point, where the crossover is there of the gap voltage, the voltage is nothing but the stress which is imposed between the contacts versus the dielectric strength. So at this point, both are equal, means the stress is exactly equal to your withstand capability, and the pre-arcing will start. So imagine you see my hands, it's moving. The dielectric strength is reducing. At this point, both are equal. The crossover point where my pointer is there. Here, your pre-arcing will start, the breakdown will happen, and current will start. And I told before the break, you have to have this point as voltage peak. But as I told, the breaker has a mechanical scatter variation. I mean, 50 can go 49.5, 49, 50, 50.5, 51. Let us assume a scatter of the breaker. So the same target which was crossover here, because of a mechanical scatter, this is a horizontal line and which you have mechanical scatter. When you project on a sine wave, which is a non-linear behavior, you will end up into a variation of target which was here from this point to this point. Now, Urmil, just now I am 48 years. If Ashutosh sir says, Urmil, you run for example, 10 kilometers. Urmil says, no, I have an age. I cannot run 10 kilometers. So I have an aging effects. If he might have told me before for say 25 years, when I was 25 years old, I might have run. Every circuit breaker has a mechanical and electrical aging. Mechanical means its drive, which is connected to the operating rod of the breaker. For example, you see on right hand side, this is a drive, a small box. Inside this insulator, your operating rod, which goes to the breaker here. So this whole is known as a kinematic chain, mechanical design, kinematic chain, which has a aging effect because of many operations. Another is the electrical aging, like it might have seen a short circuit, which has interrupted 20 kiloampere, 30 kiloampere short circuit. So it has a aging effect inside. So you might have also dielectric aging, electrical aging, also the variation of the speed. All this together will end up into variation in this decrease of dielectric strength or decay of dielectric strength. And this line is known as rate of decay of dielectric strength, rate of decrease of dielectric strength, RDDS. When you close the breaker, the dielectric strength becomes lower. The rate at which it becomes low is known as rate of decrease of dielectric strength, and that is shown here, which is further ending up into a variation from this point to this end to this end, extremes. This is the variation range. Who says the frequency or voltage is rated? The 400 kV grid can go to 410 kV, like this in actual scenario. The frequency also can vary. 50 Hertz can go to 50.5 or 49.5. So at the end of the day, this point can vary from this end to this end. But fortunately, I can measure the actual frequency. I can measure the actual voltage based on using the voltage and current measurements. Frequency I can measure from the time period of the voltage, and I can correct everything. What I cannot correct is these two things. One is a mechanical variation. Another is a dielectric RDDS scatter, electrical aging effect. And then what I did is I wrote a guideline that if I want to do suitability analysis, see, we think about any system equipment, star grounded, ungrounded, delta connected, then the voltage across the gap can go 1 pu, 1.5 pu, or isolated to highest 1.73 to root 3 times. I have two frequencies, 50 Hertz and 60 Hertz. The inductive target is voltage peak. The capacitive target is voltage zero. So because of these variations of the breaker, especially these two, what is my extreme and the two ends, and I make a cone like this. And I also put these targets on a horizontal line here, and I make another cone here for the variations. So if my ideal target is zero or peak, how much I am deviating from it based on the breaker characteristics. And I try to summarize like this. And this is a suitability method which at least we follow in our company, that we check every breaker for suitability of different gap voltages, different frequencies, feasibility of gap and zero and peak targets. See, it cannot be absolute values, but this gives you idea, because even Sanjit, the previous speaker, he told that it depends on the grid network topology. He's absolutely right. See, okay, the breaker is suitable even if everything is good, but grid is so weak that you are not able to support for a small voltage variation. The short circuit level is less. So it's a overall system, but still this can give you idea that how breaker will good fit in the system. And that suitability also we should consider for control switching, because a breaker is a very key element in this value chain. And at least we do this for all our breakers. I have seen lab tank, dead tank, pass, gas unit switch gear, all are disconnecting breakers. This is a special type of breaker which is used in at least Scandinavian market, where we don't have a disconnector. Circuit breaker itself has a disconnector function inside with a larger gap. I cannot go to more details of it, but it's also one type of circuit breaker. So control switching as a system consists of a source, infinite bus. Then you have a voltage measurement, reference voltage. Remember, I told target can be voltage peak, voltage zero with respect to a reference voltage. That is a bus bar source voltage. Circuit breaker itself, if you have to do control closing of a reactor, a transformer, capacitor bank, or a cable, then you have a closing command coming in. This one. And then you have also a controlled opening command. You remember for reactor, I told that when you interrupt the current in vicinity of current zero, you have a very high overvoltage Slappian theory. And you have to ensure that by controlled opening, that when you open the contacts, whenever current zero comes, where the arc will naturally interrupt and over voltage will appear, you have enough gap between the contacts, and that is controlled opening. And the command comes from the control room or SCADA or a TNC switch, manual switch, maintenance switch, goes to the device. It determines the target based on the type of the load, like reactor, capacitor, transformer, type of grounding condition, breaker characteristics also we feed. It gives output command, 3 output commands for closing, 3 output command for tripping to do control switching. Now I have a aging effect, as I told her. Means I am a breaker. My closing time where it goes from 50 millisecond. Today, suppose a brand new breaker has a 50 millisecond closing time. After 1 year, it shifts to 50.5, 50.7, 50.8, 51, 51.5. See, one thing more. Today, I have 50 millisecond time. I operate the breaker today for 10 times. The 50 will statistically vary. For example, 49 to 51 today. The average or median is 50. After 1 year, this median will shift to 50.5. Means 49.5 to 51.5. Something like that. You have a median shift, 49.5 to 50.5. So slowly the median will shift. And control switching device assumes, okay, my closing time is 50. And it determines the target where it has to give the command. But after 1 year, this 50 shift to 50.5. After 5 years down the line, this 50 shift to 51. So I have to track this aging effect. And that I track with either current transformer, voltage transformer. How I track, I can explain you. Imagine I am a control switching relay. Urmil is a control switching device. I know when I release the command to the breaker. I know when I expect the current to start. Voltage 0, voltage peak. I can measure the output command till the actual current start, which I can use the current feedback or the voltage feedback in the relay. Means I know when I release the command. I know when the current starts. I get the actual feedback. I am expecting that the current should start after 50 millisecond, but actually it actually started after 50.8 millisecond. Means there is an error of 0.8 millisecond because of something. And that I try to correct in the next operation. I'll repeat. I know when I have released the command from the relay. I am a relay. I know when I release the command. I have a current feedback from the CT, from the field, from the bushing CT of a reactor. I check that when actually current started. And I determine what is my actual instant versus what I am expecting from these parameters. I can determine the error and correct in next operation, which is known as adaptivity feedback. And this is very critical, which people don't understand. I go to utilities, as I told, I traveled all over the world, all utilities, all suppliers, all users of control switching. They think that control switching is just a relay and everything is done. No. If you give a metering core, you can see on the screen waveforms. If you have protection core, your current looks like this, but you can feel it. It's not symmetric. You have an asymmetric DC superimposed on this waveform. So if your metering core, it saturates. You see this waveform of the current, it's harmonics because of saturation of the CT. And many times the customer understands, reactor is saturating. Reactor cannot saturate. Its knee point is 1.2 pu typically. If your grid voltage raises to 20%, and over voltage will trip. Protection will trip before 20%. Typical range is plus or minus 10 to 15%. 20 is the highest range. So it will never go. Reactor will never go to saturation. So it's a CT saturation. You can never give a CT, metering CT. Another thing, for example, a CVT, capacitive voltage transformer. See, a capacitive voltage transformer has what? It has a coupling capacitor. It's a ferro-resonance choke inductor and small transformer. So when you open a transformer, suppose load is a transformer, when you open a transformer or close a transformer through a circuit breaker, transformer goes in saturation, as I explained you. Because of that, it is a non-linear inductance. Because its inductance varies, it goes in saturation. It's a non-linear inductance, which will interact with your capacitive voltage transformer coupling capacitor. Inside there is a ferro-resonance choke. which is tuned to power frequency, and there is a small transformer also inside, low voltage transformer. This all will create a resonance in circuit. Because of the inductance of a transformer is non-linear, it is a ferro resonance, and you end up into quite distorted voltage this way. So you cannot use this one. You need to use inductive voltage transformer, electromagnetic voltage transformer. But then you will think, oh my God, if I have a 500 kV system, how I can have an inductive voltage transformer 500 kV? Practically, it's not possible. But then what I do is I can tell you it's a smart way we handle. A transformer, imagine that you have a 2-winding transformer connected to a wind farm, which Sanjit sir was talking in last session. A wind farm transformer. You have a voltage primary 11 kV, secondary is 220 kV. Let us take an example. 220 kV side, you have a circuit breaker here, which is control switching device. I want to magnetize the transformer. The secondary of which is connected to the wind farm, it's not connected. Imagine that inverters are blocked and you have no power generation coming in from that wind farm. You are charging this transformer through a breaker, magnetizing it. And now think this way. You might have a circuit breaker on 220, you might have a circuit breaker on 11 kV side, or inverter itself is a virtual switch, IGBTs, or power electronic devices. Suppose they are in blocking mode. Let us take an example. Means when I close this breaker or open this breaker, I am magnetizing the transformer, but there is a common core of the transformer which is connected to 220 kV winding also, or which is also holding 11 kV and 220 both windings. So whatever behavior you see in terms of flux change or voltage, mutual induced EMF or self-induced EMF, is all effects you will see on the both windings, 11 kV winding also, on 220 kV winding also. So means I don't need to put the voltage measurement inductive type on high voltage system. I can also put this voltage on the 11 kV side also, because I can measure the voltage on 11 kV, and it's very easy to get an inductive voltage transformer on 11 kV side. Generally, the MV switchgear, medium voltage switchgear 11 kV, 6.6 kV, generally have inductive voltage transformer. It is easy to get it. Only what I have to take care, the vector group, Y and D1 means 220 kV to 11 kV delta is 1, means 30 degree phase shift. This I have to inform. Voltage transformation ratio, 220 to 11 kV, which I have to convert to per unit, which also I can do. So if I know the vector group, if I know the PT connection, even what happens is on delta side 11 kV, you might have star grounded PT. So you need to know the PT connection type, you need to know the vector group, phase shift, and voltage transformation ratio, turn ratio. And I can determine the impact of measuring the voltage on low voltage side, even if the switching is on high voltage side. And this is quite possible, and we have done that in our relay. It's a vector diagram which we have to draw and do it. One thing I want to tell, if any one of you are interested to learn control switching, you are welcome to use control switching user manual. What we have done, I have written chapter number 4, 5 with actual waveforms, and this is like a Bible. You can understand how this all technology works technically. There are 2 documents, control switching general technical information, and another is a reactor switching control switching information, which is publicly available openly, which also you can download and read if you are interested. Now, many times what happens, you have a transformer application, you don't have a voltage measurement device available at all, inductive voltage, no winding. Current I will think to use, but one thing, one very, very important thing, you cannot give garbage to a relay to understand. What I'm trying to say is, if Urmil is a relay who has to sense the voltage start or current start, when the current starts, no relay in world can measure 0. You need to have a threshold on which a digital relay can sense a value. But that can be a triangular wave, can be a square wave, can be a sinusoidal wave, but it cannot determine a second harmonic current of a transformer charging, because the current when starts from 0, 2, 3, 4, 5 ampere, suddenly jumps to 1000. You can see my hand. It's a sawtooth waveform like this. So I cannot determine the 0 crossing. So the suitability is also important for this feedback system. So I cannot use the current. If I don't have a voltage, then what I'm left with? I also have a mechanical feedback system which I can use, but auxiliary contact of a breaker are used for some interlocking schemes and some other purposes, annunciations and other things. So they are not fit for the feedback. I can explain you what this feedback means. Imagine my closing time goes 50 to 51. Suppose I have auxiliary contact which replicates the main contact of the breaker. Means if my main contact have 50 millisecond time, suppose I have auxiliary contact which goes again from 0 to 1, means closing means 0 to 1 at 60. Means 50 is my mechanical closing time of actual main contacts. Suppose I have 52 NO contacts which goes 60 millisecond. Means if my 50 goes to 51, my auxiliary contact should go 60 to 61. So what I will do is I am a relay. I am connected with a 52A auxiliary contact and I have programmed in the device that my closing time is 60. And it is connected to 50 millisecond actual main contact time. I inform the device by a setting. Now I check the auxiliary contact for operation 60 goes to 61. Then I will think, aha, it went 1 millisecond more. The main contact timing might have go from 50 to 51, 1 millisecond late. So I will track it. But auxiliary contact is a mechanical contact. So its accuracy or suitability we have to check. And typically the normal auxiliary contacts we don't recommend. So we have devised a contact which is known as a cam follower. You can see my hand, Ashutosh sir. Can you see my hand? Is my hand visible?
Yes, sir. Yeah.
So imagine this is a shaft of the breaker, and you see another hand which is moving the breaker contact up and down. So imagine this shaft rotates and this goes up and down. I have this shaft and I am looking at the shaft from the front view here. So it looks like a square, looks like it's a round here, and this is a lever of the movement which moves it up and down. I can do a travel rotary transducer which I mount with a switch. So whenever the breaker closes or rotates, this shaft rotates with the spring like this, it rotates. This rotation speed indirectly tells me the aging effect. If the breaker is having a mechanical aging, its closing velocity little bit changes, and this I can track with a auxiliary contact changeover to do the detection mechanical. So it's a special transducer we have to design, what I'm trying to say. And this can be used as a feedback system, for example. So one of them we use. See, very critical, you should not mix up mechanical and electrical. Mechanical is a mechanical moment, electrical is an actual current start or voltage start. Always we should use voltage or current start as a first option, because it directly replicates. Another limitation of mechanical feedback is, imagine this shaft is having a rotation. I am moving my hand again on a camera. I cannot track the internal contact aging with this type of feedback, because if the internal arcing contact of the breaker are having aging effect, because of it there is a change in the electrical current start or voltage start because of that aging effect. I cannot track that. So always I recommend to use for voltage or current. But there is another challenge which I will explain you after 2-3 minutes if I use a transformer with a voltage measurement. Now let us go for case studies and I will explain you that when I go to transformer switching. But what we have talked till now, I will try to again quickly summarize for coping up the topic. We started with introduction which sir has given. Then control switching as a system. If you do uncontrolled way, you have asymmetric components. If you do control switching on a sine waves, targets peak for inductive loads, 0 for capacitive load, gap voltage. And we have to consider the type of grounding, type of connection, type of design, three limb reactor, 5 limb reactor, 3 limb transformer, delta connected charging, star connected charging. If you do that, you can reduce this sort of asymmetry with control switching. How it works, we explained that. Then mathematically, how we derive it AC through RL series circuit for inductor, how we determine the targets. Typically, all the power system circuits are either purely inductive or purely capacitive with a negligible resistance. So this becomes tan inverse infinity because the resistance is almost 0. Pi by 2, if I close at pi by 2 inductive load, I remove the decaying DC component. That proves how we determine the targets. This is also explained in the user manual, what I was talking about. In controlled opening, what we do, if we have a contact separation here, always current tends to interrupt at natural current 0 for a AC breaker or even a DC breaker. So we have to make sure that when the current interrupts, you have over voltage, the gap between the contact or dielectric strength should be good enough. When you separate the contacts here, when the current 0 comes here, you have enough gap between the contacts which can withstand this high frequency voltage. And then we talked about, okay, I have not shown this I didn't have time, but some applications also we were talking about, which we'll talk now also. Suitability of breaker I explained recently, that the breaker mechanical characteristics, dielectric characteristics, aging effect we have to consider. Control switching as a system we talked about, that you should have to have proper feedback system. You should not use metering or you should not use CVT in some applications. If both are not available, you have to use a mechanical feedback. There you have to ensure that your mechanical contact tracks the main contact in linear way accurately. Still, I can tell you one thing. You cannot have 50 to 51 means 60 to 61. Absolute 1 millisecond you cannot match. But with minimum uncertainty, you should do it. Means 50 goes to 51, then 60 goes to maybe 60.8, 61.2. Fine. I mean, 0.2 millisecond. It's okay. I mean, mechanically, you cannot achieve very, very high accuracy. But you should try to design spatial transducers. Okay, one thing. You can also use optical transducer, which is very accurate. Optical transducers will give you very good accuracy. But this type of mechanical transducers are having good accuracy, but not dot zero. Case studies. I already talked about shunt reactor. When you open a reactor, we discussed that we have to open the contacts such that this dielectric strength you see here, this is a current interruption point when the current goes to zero. See, this is a contact separation point. You remember I told that when you open the contacts, there will be arcing between the contacts, and at natural current zero, the arc becomes minimum, arc becomes weakest, and at this point, natural current zero, the current will interrupt. It may be a little bit before current zero, but depends. I mean, how much is the peak of the current? How strong is the dielectric medium of the breaker? But typically, it goes very near to zero. And as soon as the current interrupts, the bushing capacitance will interact with the inductance of the reactor, and you have a high frequency over voltage. But you see, this over voltage is lower than your dielectric strength. This is your dielectric strength. At this point, where I'm putting the cursor, the current interrupts. Because of that, the high frequency voltage will come, but that voltage is lower than dielectric strength, so current will interrupt, and you successfully interrupt the current. I told you one more thing, which I will repeat again, which was very, very interesting, that if this breaks down again, what happens? I run the video last time, if you remember. And then the main contact has separated, if you remember. Then arcing contact will have the arcing in between. I explained this. And if imagine that the current zero comes here at this point, and there is a re-breakdown, the over voltage is higher. The over voltage is higher than the dielectric strength. The current will again continue. Means the current will start here. If the current comes between the contacts, I am happy. But if the current goes from this contact to the main contact, punctures the nozzle, if it damages some dielectric components, this is a permanent damage. But as I told that it's like a cancer, slowly the deterioration will come, which you will never able to judge from outside. So after one operation, two operation, we don't know how many operations it will survive. It's again a statistical phenomena. Maybe it will survive 100 operation, maybe it will survive 5 operation, depends. But it will damage and breaker will explode if you don't properly monitor this. So the topic is, it's a dielectric breakdown which punctures the nozzle. If it's a thermal breakdown between the contacts, again, breakdown means again the current comes because of a higher over voltage stress. If it re-breakdowns, then if it punctures the nozzle, we have a problem. If it between the contact it happens, there is no problem. This we discussed. Now let us go to the applications quickly. Let me see the time as well. Yeah, we have time, 1 hour approximately, for 55 to 1 hour, enough time. Now I'll show you some real field results, real waveforms. This was a case in India when I was traveling to Turkey and I was on a car to go to a commissioning. One of my Indian colleague, my commissioning service engineer, suddenly called me, Urmil bhai, we have seen a reignition. You see this chopping. If you remember your Sunil Asaraya book, do you remember we have seen this type of waveform and chopping? This is a real chopping waveform. If this happens, then there is a big risk to the breaker. It has to be smooth current. But you have multiple choppings like this, which is dangerous. I can show you one another beautiful waveform which I shown in a Transgrid presentation. When I was in Australia, Transgrid, I had a 1.5 hour session with the grid regulator and their whole team, 40 people. And I can show one very interesting waveform of reactor failure. I mean, which was a very small reactor, 30 ampere reactor. See, you will think that if the reactor is small, I should be happy, right? No. If reactor is small, it is more dangerous. If you remember your switchgear book, if your current is low and if your breaker is strong, it will do chopping. Chopping means before current you will interrupt. Like you are giving a very, very big force to a current to interrupt. The current is very small and it will chop. And it will chop. The di by dt, rate of change of current, is very fast. And for a small current reactor means what? What is the current? Voltage upon impedance, right? Oh, sorry. What is the impedance? Voltage upon current. I'm sorry. What is the impedance? XL. Voltage upon current. What is XL? 2 pi FL. So L is proportional to voltage upon current. If current is low, inductance is high. What is the over voltage? Root L upon C. If you remember, root L upon C. If inductance is very high, root L upon C is very high, the voltage will go very high. Small reactors, I always pray God, I always have in my wallet Lord Krishna's photo. भगवान को मैं हाथ जोड़ता हूँ. आज मैं 500 रिएक्टर कर चुका हूँ वर्ल्ड में. मैं आज भी भगवान को हाथ जोड़ता हूँ. थोड़ा सा बोल सकते हो कि टेक्निकल हूँ, लेकिन मैं फिर भी बोलता हूँ कि भगवान ये सीधा निकल जाए, क्योंकि सीधा ब्रेकर एक्सप्लोड हो सकता है, रिएक्टर को डैमेज होता है. इतना डर लगता है हम लोगों को करने में. मैं आपको वेवफॉर्म दिखाता हूँ यार, अगर है मेरे पास तो मुझे दिखाना एक वेवफॉर्म रिएक्टर का बैड केस. यस दिस वन. ये देखो चॉपिंग. यू सी दिस चॉप hard. See multiple chops on the same breaker. What I told in the meeting to the utility, do you know that what is a 39 ampere reactor? You are sitting on, okay, I'm on a recorded call, I will not use the word. You are sitting on an explosive device. I have to be compliant. You don't know what you are handling. And this is the real problem with the utility. Sanjit sir will be agreeing with it. He's a consultant. He will agree to it. Even it's not that fault. Utility is not in fault. They don't know what they're handling. And in such cases, it is a disaster if you do it wrongly. And they didn't contacted us as Hitachi Energy. They used some others relay. I mean, not our relay. And they did something by their own in the setting, and it was creating a real issue. Fortunately, breaker didn't exploded, but it was on the verge of failure. So the topic is we have to be very careful. I mean, such applications are very, very dangerous. Now we can go to another slide of a capacitor bank now. I can tell you with the sites where I was there to make it a real feeling of a practical field experience. This is a case in Indonesia where I went to do a job of a capacitor bank.
Actually, क्या है एक particular topic पे.
Sorry. Should I ignore the someone was speaking something? I ignore it. Am I this screen is visible? Am I audible? Or there is a problem?
Yes, sir, you are audible.
Okay. So this is a case which I was doing in a capacitor bank in Indonesia, and it's an ungrounded capacitor bank. You remember I told when you have ungrounded capacitor bank, there is no return path of the current. So you close first pole, it's mechanical closing, but the voltage on the second pole will be root 3 times. So I have to close in vicinity of 0. You remember capacitor load. So I should close in vicinity of 0, and which is shown here on the screen. This was a bad closing. There was a wrong parameter of the breaker given to me. You see, these two currents are starting together because it's a line to line. When you close one pole, current will not start. When you close second pole, imagine you see my hand. These are two poles. You see my hand. Both are open. When I close first pole, this second pole will see root 3 time voltage. When I close second pole, third is open. My third finger is still open. My thumb is open. When I close this two, the current will go in circulating path. So in one direction, current will be positive, another direction negative. Means equal and opposite current will flow, which you can see on the screen. When we corrected the targets, then the inrush current was reduced. This is a real waveform of a real successful commissioning. Capacitor bank. The next one was power transformer. Now this is my favorite application. I don't have time to explain you, but let me try something. Okay, which slide I will take to explain you? Give me a second. Okay, let us take this slide show of transgrid. Transformer. I have so many slides, so I always mess up. Come on. Yes. Let us build up a transformer in a slide. Come on. What's going on? Okay. I have a star delta transformer with a magnetic coupling, okay, in between. Here is a hash symbol, yes. Just a second. Now imagine, this is very, very interesting. Just try to observe what I'm speaking. This is the common core. This both is a common core. This is a single core between the windings. Suppose I'm closing a star delta transformer from star grounded side. Suppose I'm closing only one phase in controlled way. The current will pass through earth, and imaging your star is the source is grounded, it will close the path. It is a closing of a breaker, so the source voltage 400 kV by √3 will appear across this winding directly, and this voltage will create Faraday's law of electromagnetic induction, alternating flux in this core, and the core is also holding a delta winding. So there will be mutual induced EMF on the delta winding of the transformer 11 kV, for example. Kirchhoff voltage law. This voltage VA, VL2 plus VL3 should be equal to 0 delta. Summation should be 0. Now this all three cores has to be exactly same design. The winding should be same design. Reluctance should be same. Magnetic path should be same. Means because of this voltage induced here, it will create a circulating current V1 plus V2 plus V3 equal to 0. But these two windings are exactly same design. Reluctance paths are same. So V2 and V3 will be equal value. So V1 plus V2 plus V3 equal to 0, but V2 equal to V3. So even if I have closed only one phase, this will create minus V by 2 voltage because of induced voltage here. And that voltage will create minus 5 by 2 flux in other two cores. And that flux will create mutual induced voltage in 400 kV minus V by 2. So if someone will touch this breaker, even if it is open, if you touch on line side, you will die. This is not as a coupling effect. Means when you close only one phase, all three voltage will appear on the transformer. This is not the coupling effect. The same thing will happen in 3-limb transformer as well. Now, what is the disadvantage? Let us see that on the waveform on the slide here. And that exactly is shown here. Let me show you on a diagram. Sorry. You see, this is a paper which we published, I think, in India, I remember, in Grid Tech. Now you see, this is actually the same thing. You see, this voltage is starting here on waveform, you see, load voltage. And equal and opposite. See, if you see this waveform half, exactly opposite half is there in other two phases. See, this blue and yellow. Now imagine, I am a control switching. Urmil is a control switching device. I want to see the variation of 3 phases. What will happen to me? I know that the breaker has closed first phase. But what I see as a feedback, load voltage of first phase, second phase, and third phase all have started. What it means? Only one phase is closed at this red vertical line, but the voltage is there in all 3 phases. I will think, all 3 phases have closed. I will misunderstand. And this is what the limitation of this technology for almost 30 years. I can tell you the truth. I never give up in my life. Like Sanjit sir was saying, we don't give up. We are technocrats. We think almost 24 hours. That's why I do meditation, yoga. to at least relax my mind in night. I want to solve this. How? I was sitting on a dining table in dinner. I think this is minus V by 2 minus V by 2, correct? If I subtract them, then this subtraction will give to 0 value in one of the phase. I subtracted the voltage and I suddenly see a jump when I am closing the second phase to close. I applied this technology in my relay and I patented it. Based on the vector groups, we can use this methodology, differential voltages. And this problem was sorted out. Why I told this example is there can be technical limitations, but you have to be academic and think out of box. See, we R&D people always think out of box. And I tell you, हम लोग मैं हिंदी में बताता हूँ थोड़ा सा, है ना, हम ये बोलते हैं कि जो छोटा माइंड होता है, छोटा दिमाग, हम जो देसी में बोलते छोटा दिमाग, ये हमेशा पहला जो थॉट आता है ना, वाइल्ड थॉट, हमेशा सही होता है. R&D में मेरा एक्सपीरियंस है. Another thing is when I'm struggling to solve a problem, I always give up on the same day because the thought is aligned to one way unintentionally. दूसरे दिन सुबह उठोगे ना, सॉल्यूशन आ जाएगा. ये भगवान की कृपा है, आज तक मैं फेल नहीं हुआ. जितने साइट्स पे मैं गया हूँ, काफी क्रिटिकल इश्यूज सॉल्व करने गया हूँ. ग्रिड ट्रिप होते हैं. आई हैव सीन माइंड ट्रिपिंग, आई हैव सीन स्टैटकॉम ट्रिपिंग, आई हैव सीन अ रिएक्टर ट्रिपिंग, आई हैव सीन पावर प्लांट ट्रिपिंग, आई हैव सीन ट्रांसमिशन लाइन ट्रिपिंग. हाँ, काफी सारा मैंने दिखा है एक्चुअल इश्यूज, बट आई नेवर फेल्ड. द रीजन इज बेसिक्स में जाता हूं मैं, आउट ऑफ बॉक्स सिंपल सोचता हूं मैं, प्रॉब्लम सॉल्व होता ही होता है. जैसा सर ने क्या बोला कि आई विल कम बैक टू यू फॉर सेकंड हार्मोनिक्स. व्हाई ही टोल्ड व्हेन यू थिंक इट आउट ऑफ बॉक्स इन अ वेरी वेरी पेशेंट वे, आई मीन cool way, it's always a solution. Only challenge what I face, I can tell you practically. मैं जब साइट पे जाता हूँ, शटडाउन मिला होता है, 2 घंटा लगता है. मेरे पास पूरा टीम है 50 लोगों का वर्ल्ड में. मैं लेवल 5 हूँ, मेरे ऊपर कोई कंट्रोल स्विचिंग में सॉल्यूशन पे है नहीं, तो मेरे पास सब केस आते हैं बिगड़े हुए. मैं कुछ साइट पे साल में 1 या 2 बार जाता हूँ. तब होता है क्या, ये फ्लाइंग स्क्वाड आया, ये है ना, आके हमारा सब प्रॉब्लम सॉल्व करेगा. मेरे को 1 घंटे का शटडाउन होता है. मेरे पास टाइम नहीं होता है सोचने का, सबसे बड़ा लिमिटेशन. और मेरे सिर पे 5 कस्टमर खड़े होते हैं, यूजर्स. उनका फॉल्ट नहीं है, वो दे आर राइट, दे हैव टू गिव द शटडाउन बैक बिकॉज अवेलेबिलिटी, आई टोल्ड इन द मॉर्निंग, अवेलेबिलिटी इज द मोस्ट क्रिटिकल इश्यू टुडे इन द ग्रिड. यू कैन नॉट अफोर्ड लॉन्गर शटडाउन. सीधा पेनल्टी लगता है. प्रॉब्लम है ये बहुत बड़ा. मेरे पास सोचने का टाइम नहीं है, तो मैं जाता हूं उससे पहले मैं क्या करता हूं, इफ पॉसिबल आई ट्राई टू विजुअलाइज द प्रॉब्लम बिफोर आई गो टू साइट. And I try to respond because many times contractually also we have impacts. बहुत बड़े impact होते हैं. तो I should try to foresee a problem before I go. मुझे सोचना पड़ता है. मेरा काम होता है, my work is 1 minute. I tell you, when I go to site to solve the problem, I used to go from India to Canada 36 hours. शाम को 6 बजे वीजा मेरा स्टैंप होता था, 8 बजे घर पे ऑटो खड़ा होता है मेरा. मैं दोपहर को जगह मैं वेजिटेरियन, मैं अंडा भी नहीं खाता, वेजिटेरियन हूँ मैं साथ में MTR उपमा पोहा नाश्ता, फर्ज में गुजराती हूँ, फरसान लेके सलाद सब कुछ मैं पैक करके रखता हूँ. मेरे घर पे ऑटो खड़ा होता है, मेरी वाइफ ने सब पैक किया होता है. मैं शाम को जाता हूँ, 36 घंटे पे पहुंचता हूँ मैं. 13 घंटे का जेट लैग है, मैं सीधा साइड पे जाकर सॉल्व करता हूँ प्रॉब्लम. ऐसा मेरे साथ होता है काम. तो जो लोग हम फील्ड पे काम करते हैं, सर जो बोलते हैं कंसल्टेंट का काम करते हैं, हम लोग जो काम करते हैं, हमको सीधा नोस, हमको है ना सीधा हमारे टोस पे काम करना है. और मेरे पास फेल होने का चांस नहीं है. हम फेल हो सकते हैं, मैं ऐसा नहीं बोलता, फेल होते हैं हम, पर हमारे पास चांस नहीं है. हम चांस ले नहीं सकते, हम ग्रिड पे काम करते हैं सीधा. इसलिए हम बोलते हैं हम दबंग हैं, हम दादागिरी से काम करते हैं. मैं इमोशनली बोल रहा हूँ. कंपनी में मेरे को कोई नहीं पूछता उर्मिल तुम क्या करता है, क्योंकि मेरे पास इतना स्ट्रेस रहता है चीजों का, मेरे पास सोचने का टाइम नहीं रहता. तो हम लोगों का काम ऐसा है कि हमको सीधा प्रॉब्लम सॉल्व करना. आज सर ने बोला अभी रिन्यूएबल है ग्रिड, राइट? वी हैव रिन्यूएबल्स एंड इफ यू सी यूरोप, वी आर गोइंग मोर एंड मोर टुवर्ड्स रिन्यूएबल्स. इवन HVDC is coming, short circuit levels are going high, inertia is not there in the grid. We face so many problems. हार्मोनिक्स बहुत सारे हैं ग्रिड में, इनर्शिया नहीं है, हमको अनसर्टेनिटीज है ग्रिड में. मतलब N-1 टोपोलॉजी की हम बात करते हैं, वी हैव सो मेनी चैलेंजेस. तो कन्वेंशनल अगर अपने पास प्लांट्स का सपोर्ट है तो अपने पास शाफ्ट है. शाफ्ट इज द मोस्ट इंपॉर्टेंट थिंग इन ग्रिड. वो सब कुछ एब्सॉर्ब करता है. लोड फ्रीक्वेंसी कंट्रोल हम बात करते हैं, रिएक्टिव पावर कंट्रोल. शाफ्ट ऐसा चीज है कि जो आपको आपके शॉक को एब्सॉर्ब करेगा, और ये सबसे बड़ा प्रॉब्लम है डाउन द लाइन. इसलिए आज की तारीख में एनर्जी स्टोरेज पे काम होता है. सर जो इन्वर्टर के साथ रिस्पॉन्स टाइम, ये एक टॉपिक था जो सर के साथ हम बात कर रहे थे, दोनों हम जो कम्युनिकेट करते थे, सेशन चेंज हुआ तब. रिस्पॉन्स टाइम इज ऑल्सो वेरी क्रिटिकल नाउअडेज, क्योंकि DF by dt है, DV by dt, हमारे पास टाइम नहीं है. तो रिस्पॉन्स टाइम इज ऑल्सो सिमिलरली इंपॉर्टेंट. हाउ मच इज योर क्लोज लूप सिस्टम एफिशिएंट. फैक्ट डिवाइसेस की हम बात करते हैं, कितना फास्ट है सिस्टम टू रिस्पॉन्ड द प्रॉब्लम्स. सब्जेक्ट से बाहर चला गया, मुझे वापस आने दो सब्जेक्ट में, मेरे साथ ये हमेशा होता है. तो ट्रांसफार्मर की बात करते हैं हम लोग. तो ट्रांसफार्मर में ये आपका कनाडा का केस है. आप ये सोचो कि इंडक्शन करंट है, इट इज नॉट इवन 0.5 pu, मतलब पर यूनिट क्या है आपका फुल लोड करंट ऑफ ट्रांसफार्मर 1000 एम्पियर है, 500 एम्पियर का इंडक्शन करंट है, सेकंड हार्मोनिक है एक फेज में. ये ग्रिड वोल्टेज, आप ये सोचो ग्रिड के ऊपर ऐसा वोल्टेज है. इंडिया में तो भाई साहब ऐसा वोल्टेज हम देखेंगे ही नहीं जब तक हम रिन्यूएबल में ज्यादा नहीं जाएंगे, वीक ग्रिड में नहीं जाएंगे, ये देखेंगे ही नहीं. ये एक्चुअल केस है कनाडा में. ये लगा है छोटा सा ट्रांसफार्मर. क्या हो गया मेरे कर्सर को भाई? हाँ, छोटा सा ट्रांसफार्मर है जो आपके एक ऑक्सिलरी सिस्टम को सप्लाई देता है एनिमल स्वेल्टर में. ऐसा वोल्टेज बैठ गया भाई साहब उसका. अब मैंने इंडक्शन करंट को जब कम किया, ये उसका रियल एक्चुअल वेव फॉर्म है. जस्ट सी दिस, हाउ इफेक्टिवली इज द मिटिगेशन हियर. But when you repeat the operations, you might end up into higher interest. This is a Bilaspur case, India, 1500 MVA, 765/400 kV/11 kV transformer. 400 kV side पे 2162 एम्पियर फुल लोड करंट है. 2162 RMS, पीक इज 3050. 765 पे 1132 एम्पियर है, पीक इज 1500. ये आपका 400 kV का ट्रांसफार्मर है, साइड है, कंट्रोल स्विचिंग से चार्ज कर रहे हैं, मैग्नेटाइज कर रहे हैं ट्रांसफार्मर को. 2162 एम्पियर RMS, पीक 3000 है. हमने इसमें मेरी मोनोपोली है वर्ल्ड में. इवन मैं बताता हूँ, मैं इंडक्शन करंट को 2000 से 20 एम्पियर लाता हूँ. ये मेरी मोनोपोली, एक्सेल शीट से करता हूँ काम में. मेरी PhD है, एक्सेल में किया है मैंने काम. मैं कोई हाईफाई टूल का यूज नहीं करता. सिंपल. मैं सिमुलेशन स्टडी जानता नहीं, लेकिन मैं जब काम करता हूँ कस्टमर्स के साथ, कंसल्टेंट का रिपोर्ट मेरे पास है. डोंट माइंड, मैंने बोला ये शॉप्स है. बहुत कम लोग जिसको समझ में आता है कैसे सिमुलेशन करते हैं. मेरे को सिमुलेशन आप बोलोगे, मैं मॉडलिंग नहीं जानता, मैं बता सकता हूँ कि इसमें गलती कहाँ है. अगर आपने सिमुलेशन केसेस सही लिए कि नहीं, मैं बता सकता हूँ. ये मेरा डेली का वर्क है. मैं बता सकता हूँ कि कौन से केसेस इसमें मिसिंग है, कहाँ पे आपने मॉडलिंग में गलती किया है, किस तरह से स्टैटिस्टिक्स करना है, किस तरह से मोंटे कार्लो करना है, ये बता सकता हूँ मैं लोगों को. और ये चीज बहुत ही क्रिटिकल है आज की तारीख में, जब बहुत सारे सिस्टम स्टडी कंसल्टेंट्स है, कंसल्टेंसी का काम करते हैं. ये रियल सिनेरियो से काफी दूर है, काफी जगह पे ये प्रॉब्लम है. सीनियर कंसल्टेंट्स का भी मैंने देखा हुआ है, बट उनमें उनका फॉल्ट नहीं है. द पॉइंट ये होता है कि जब कोई यूजर है, जब कंसल्टेंट है और जो सप्लायर, तीनों को साथ में बैठ के कोलैबोरेटिव वे में एक टेबल पे बैठ के डिस्कस करना चाहिए कि क्या कंटिजेंसी मोड्स है, किस तरह के केसेस आ सकते हैं. अच्छा, टेक्नोलॉजी क्या, देखिए एक चीज और है, कोई टेक्नोलॉजी 100% नहीं है. मैं जब काम शुरू करता हूँ ना, पहला चीज मैं क्या सोचता हूँ कि मेरा चीज कहाँ फेल होगा. मेरे टेक्नोलॉजी स्ट्रेंथ नहीं सोचता मैं, वीकनेस क्या है, और उसके ऊपर मैं काम करता हूँ कि ये किस पर्टिकुलर मोड में इसकी कैपेबिलिटी क्या है, एक पर्टिकुलर सिनेरियो में, एक पर्टिकुलर कंडीशन में इस टेक्नोलॉजी का कैपेबिलिटी क्या है. अगर ये हम समझेंगे तो सॉल्व कर पाएंगे. फॉर एग्जांपल ट्रांसफार्मर की बात है, इसके अंदर इतना इंडक्शन करंट वो झेल नहीं पाता था. माइंड ट्रिप हो गया लिटरली 200 किलोमीटर पे. और इसका इंपैक्ट, मैं ब्रिटिश कोलंबिया में काम करता था, मेरा इसका इंपैक्ट मॉन्ट्रियल में दिखा है ग्रिड पे. इतना वीक ग्रिड. सॉल्यूशन का सिंपल है सॉल्यूशन. अगर मेरा इंडक्शन करंट 0.5 to 1 per unit इज वेरी गुड. ये इंडक्शन करंट 10 PU जाता है. मैं आपको बता सकता हूँ, थंब रूल से मुझे मालूम है कि अगर आपका ट्रांसफार्मर 220 के लिए 3 लिंब है, 10 PU जाएगा इंडक्शन करंट. 1000 का 10,000 जाएगा. मैं इसको 1 PU लाता हूँ इंडक्शन करंट को रिपीटेडली. उससे अच्छा मैं कर नहीं सकता. फुल लोड करंट रेटिंग में ले आता हूँ मैं रिपीटेड ऑपरेशंस में. अगर इससे काम आपका नहीं बनता है तो आपको कुछ और करना पड़ेगा. क्या करना है बताता हूँ मैं आपको. वोल्टेज बैठता है बराबर इंडक्शन करंट से, क्या करो, बिफोर यू चार्ज दैट वोल्टेज को इंक्रीज कर दो ग्रिड पे. 5% बढ़ा दो वोल्टेज को, तो वोल्टेज आपको 5% 1.05 से बैठेगा, सर्वाइव करेगा ग्रिड. ये मेथोडोलॉजी मैंने काफी यूजर्स को बताई, दे आर वेरी हैप्पी. टांजानिया में मैं जब पहला रिएक्टर चार्ज कर रहा था 400 kV में, पूरे 7 कंट्री का एक रिएक्टर मैंने बताया था सुबह आपको, वोल्टेज 15 से 20% बैठता था. मेरा काम कंट्रोल स्विचिंग तो लास्ट रहता है. मेरे को कस्टमर बोलता है, मुझे नाम से पहचानता है कि उर्मिल तुम कब आओगे, हमको ये चार्ज करने को डर लगता है. मैंने कहा देख, मेरा काम भाई ये है नहीं, तुम्हारे कंसल्टेंट का काम है. कंसल्टेंट जाके होटल ढूंढ रहा था कि मेरा रूम खराब है, ये वो है. मैं गया साइड पे, मैंने बोला देख भाई, ये मेरा लायबिलिटी नहीं है, मेरा रिस्पॉन्सिबिलिटी ये है नहीं, मैं इसका कॉन्ट्रैक्ट लायबिलिटी नहीं लूंगा, लेकिन मैं इनफॉर्मल तुमको बताऊंगा मेरे एक्सपीरियंस से क्या कर रहा है. ग्रिड वोल्टेज को बढ़ा दो. हमने बढ़ाया, ग्रिड सर्वाइव हो गया. इजिप्ट में भी एग्जैक्टली सेम किया था। 500 केवी का वोल्टेज सिस्टम का 460 केवी 450 केवी पहुंच गया, 525 केवी 535 केवी पहुंच गया। इन्होंने आधे घंटे में 4 रिएक्टर के कमीशन करवाए मेरे से, आधे घंटे में 20 ऑपरेशन किए। इनको मालूम नहीं है कि वोल्टेज के साथ चेंज हो रहा है, मुझे बोलने का टाइम नहीं है, उनको खुद को नहीं मालूम कि ग्रिड के साथ क्या। इट वाज अ सोलर प्लांट which was connected a 500 kV system to another substation. Even grid जब डिजाइन करते हैं, प्लानिंग करते हैं, टू बी ऑनेस्ट विथ यू, रिकॉर्डेड कॉल पे फिर भी बताता हूं मैं आपको, थोड़ा सा पॉलिटिकल होता है, मुझे काफी यूजर्स ने बताया है। लोग सोचते नहीं है कि ये आप डिजाइन करोगे, आपके पास क्या बैकअप सिस्टम है इससे उभरने के लिए। सोचो आप 500 केवी सिस्टम में एक डबल सर्किट, एक सॉरी सिंगल सर्किट लाइन है, जो एक सोलर प्लांट बहुत बड़ा कैपेसिटी 500 या 1000 मेगावाट का प्लांट था, इजिप्ट से कहीं और कंट्री में जा रहा था, जहां तक याद है 300-400 किलोमीटर का लाइन था। रिएक्टर को इन आउट कर रहे हो तो 500 केवी का 535 540 545 केवी का। आप सोचो आपका इंसुलेशन का क्या ओवर वोल्टेज आ रहा है, और उनको मालूम ही नहीं वो कर क्या रहे हैं। दिस इज द इश्यू। ये केस के अंदर इंद्रस करंट 20 एम्पियर से 650 गया। पीपल विल बहुत ज्यादा गया, ऐसा नहीं सोचना है। फुल लोड करंट 3000 एम्पियर है, ये मेरा 625 इज ओनली 625 बाय 3000 इज नॉट इवन 0.2 पीयू। 20% भी नहीं है फुल लोड करंट का, 20-21% है, इट्स ऑलरेडी वेरी लेस करंट। तो ये भी एक चीज है जो यूजर को समझना है, जो मैं समझाता हूँ कि भाई आप ऐसा मत सोचो कि 600 एम्पियर ज्यादा है। आप ये सोचो कि आपका करंट जाता कितना, 3000 इंटू 4 5। जब 400 केवी का ट्रांसफार्मर होता है तो 4 पीयू तक जाता है, तो 4 टाइम्स आप सोचो ना, 3000 का 4 टाइम कितना होता है, 12000 एम्पियर। मैं उसको ले आया सिर्फ 600 एम्पियर तक, इससे अच्छा क्या कर सकता हूं मैं। करेक्ट। सो टेक्नोलॉजी को लिमिटेशन समझो, सिस्टम का लिमिटेशन समझो, समझ सकते हो टेक्नोलॉजी अगर 1 पीयू ला सकता है, अगर रिएक्टर को डालोगे तो आपका वोल्टेज 440 केवी बैठेगा, तो आपको ग्रिड का जो वोल्टेज रेगुलेटर से बात करके आपको सपोर्ट करना है। इस केस में टांजानिया में क्या हुआ था कि इन्होंने क्या किया, इट वाज अ ट्रांसफार्मर इट वाज अ रिएक्टर 400 केवी कनेक्टेड टू स्टेप डाउन ट्रांसफार्मर 220 केवी, इट वाज अ ट्रांसमिशन लाइन 300 kilometer, there was a statcom on opposite end, there were some capacitor banks in the grid, they used them to raise the voltage before charging. उल्टा सोचना है जब आप रिएक्टर को आउट कर रहे हो, जब रिएक्टर को आउट करोगे तो वोल्टेज ऊपर जाएगा, फरेंट इफेक्ट आएगा। तो 400 केवी ग्रिड को 380 पे ले आओ और फिर उसको आप आउट करोगे तो वोल्टेज आपका 410 420 केवी जाएगा, ग्रिड सर्वाइव करेगा। फिर भी बताओ उसके बाद क्या हुआ, एग्जांपल है, यही एग्जांपल में आई वाज वेरी हैप्पी। मैं क्यू साइड पे गया था, हम वर्ल्ड का स्मॉलेस्ट रिएक्टर कर रहे थे 400 केवी पे 50 एम्पियर का, और उसमें न्यूट्रल ग्राउंडिंग इंपेडेंस बहुत हाई था, तो ओवर वोल्टेज बहुत आई जाएगा। तो मैं इतना हैप्पी था कि मैं पैशनेट हूँ, कुछ नया सीखेंगे। सुबह 5 बजे कॉल आया मुझे कि पूरा आपका रिएक्टर और पूरा लाइन ट्रिप हो गया, क्योंकि स्टेटकॉम का कूलिंग सिस्टम फेल हो गया, अपोजिट एंड पे ट्रिप हो गया सब। और वहां पे उस कंट्री का राष्ट्रपति बैठा हुआ था, प्रेसिडेंट बैठा था, सोचो क्या हुआ होगा। ऐसे केसेस होते हैं रियल सिस्टम में, अब सोचो इसका कॉन्सिक्वेंस। 5 घंटा पूरा सिस्टम बैठ गया था, जब चार्ज किया फिर से ट्रिप हो गया ट्रांसफार्मर। क्यों? कितना बड़ा गलती किया रेगुलेटर ने, उसने ट्रांसफार्मर की सेकेंडरी पे लोड लगा के रखा और ट्रांसफार्मर चार्ज किया। द डिफरेंशियल प्रोटेक्शन, बिकॉज द लोड वाज कनेक्टेड, इट अंडरस्टूड दैट इट इज अ नॉर्मल साइनोसोडल फॉल्ट करंट, ट्रिप हो गया सब। तो पॉइंट ये है कि सिस्टम को समझ के काम करना है। This is the mechanical feedback which I was talking about. This is the actually auxiliary contact of the breaker with special that cam which I was showing you in the diagram right hand side. This is the main contact of the breaker, auxiliary contact, and this is the difference of them, which is almost stable, quite stable. And when we use this, the indirect currents were consistently within 0.5 pu. Very good results. This is a paper we published, I think, in SIGRE. Now I go to very, very interesting applications. I think we have still some time. I think very good. This is amazing example. This was my first job overseas, where my mentor, मैं जो गुरु मेरा जो है यहाँ पे, he is a head for this technology. He is retired now, पर जॉनसन। उसको मेरा ड्रीम था उसको रिप्लेस करो, और मैं उसकी जगह आके बैठूं। मेरा गॉड्स ग्रेस, भगवान की कृपा है कि मैंने उसको रिप्लेस किया। अभी मैं ये काम करता हूँ। उसने मुझे एक जॉब दिया था, पहला जॉब मेरी लाइफ का, ये था कनाडा में, जो मैं आपको बता रहा था। इसके अंदर लगा था एक रेक्टिफायर ट्रांसफार्मर और उसकी टर्शरी पे कैपेसिटर बैंक लगा था। ये फेरो रेजोनेंस है। जब इस ट्रांसफार्मर को आप ओपन करते हो ना इस तरह से, तो इसका 1/2 CV² कैपेसिटेंस 1/2 Li² इंडक्टेंस में ऑसिलेट करता है, और इट क्रिएट्स स्क्वायर पल्सेस। ये मैं आपको क्यों बता रहा हूँ, एक एग्जांपल है छोटा सा। ये ये फेरो रेजोनेंस है। इसके अंदर ये आपको जो स्क्वायर पल्स दिखता है नहीं, करेगा क्या मैं आपको बताता हूँ। आप ट्रांसफार्मर को जब ओपन करते हो ना, तो उसमें रेसिडुअल फ्लक्स रहता है, आप जानते होंगे ये चीज। व्हेन यू interrupt the current of a transformer, it has a residual flux because of the properties of the core. Now, if you have this square pulses because of a large capacitive element, क्या होगा मैं बताता हूं। आप ट्रांसफार्मर को डीमैग्नेटाइज कैसे करते हो, ओपन होने का डीमैग्नेटाइज, एक डीसी दो, पोलैरिटी रिवर्स करो, फिर से डीसी दो, फिर पोलैरिटी रिवर्स करो, फिर से डीसी दो। जैसे जैसे आप हर बार साइकिल देते हो, डीसी माइनस डीसी प्लस डीसी, सिक्वेंशियल वे में उसका वोल्टेज को कम कर दीजिए और टाइम पीरियड को कम करो स्पेल का, आपका ट्रांसफार्मर डीमैग्नेटाइज होता है। ये एग्जैक्टली अपने आप होता है। इसको मैंने पहली बार देखा था सिगरे में, इसको मैंने अपना खुद का नाम दिया वर्चुअल डीमैग्नेटाइजेशन, और ये हमने पब्लिश किया सिगरे के अंदर, ये एग्जांपल। और इसके अंदर क्या हो रहा था, एक और डेंजरस फिनोमेना, ये आपको दिख रहा है करंट ऑफ द ट्रांसफार्मर विच वाज इन विसिनिटी ऑफ अ जनरेटर हाइड्रो प्लांट, इसलिए करंट जीरो टच नहीं कर रहा है, आपको दिख रहा है ये, इट डजंट टच जीरो। Imagine that I'm charging this transformer and our differential protection mal operates. मतलब उसने गलती से फॉल्ट देख लिया। इस पॉइंट पे एक साइकिल के बाद इसके रिले एक साइकिल में सेंस करता है टिपिकली यहाँ पे, उसके बाद वो 15-20 मिली सेकंड में कॉन्टेक्ट ओपन हो जाते हैं, और यहाँ पे उसके कॉन्टेक्ट ओपन हो गए, आर्किंग स्टार्ट हो गया, आर्किंग 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 आर्किंग, करंट जीरो इतने टाइम के बाद आया। फॉर्चुनेटली 2 साइकिल में आ गया, पर ब्रेकर को एजिंग हुआ आर्किंग के कारण, क्योंकि ये करंट आपका होता है 1000, 2000, 2500, 3000 एम्पियर। ये मेरा इश्यू था कि भाई ट्रांसफार्मर को जब मैं चार्ज करता हूं, इसमें ओवर अंडर वोल्टेज आता है, लेकिन इसके अंदर कैपेसिटर बैंक लगा है, तो उसका ओवर वोल्टेज, मतलब अगर मुझे ट्रांसफार्मर क्लोज करना है, इनरश करंट कम करना है, वोल्टेज पीक पे क्लोज करना पड़ेगा मुझे, ऑलमोस्ट इंडक्टिव लोड है, नियर टू पीक। बट केबल के लिए और कैपेसिटर बैंक के लिए वर्स्ट टारगेट है। अगर कैपेसिटर बैंक को करना है तो वोल्टेज जीरो पे करना पड़ेगा, मैंने बताया था आपको मॉर्निंग सेशन में। तो बोथ आर एग्जैक्टली कॉन्ट्राडिक्टरी टारगेट्स। तो करे क्या, पीक पे क्लोज करो तो इंडक्टर खुश है, ट्रांसफार्मर खुश है, कैपेसिटेंस को दुख प्रॉब्लम है। वोल्टेज जीरो पे करो, हाईएस्ट सैचुरेशन ऑफ ट्रांसफार्मर वोल्टेज बैठ जाएगा। मैंने पहली बार लाइफ में आर्टिफिशियल रेजोनेंस किया था और इस तरह से इसको सॉल्व किया था, और इसमें इनरश करंट 1 pu कंसिस्टेंटली आया था। और वहां पे मेरे साथ आया था बीबीए कंसल्टेंट, बिगेस्ट कंसल्टेंट इन वन ऑफ द बिगेस्ट इन कनाडा। उसने बोला था अगर उर्मिल ये सॉल्व कर पाया तो होगा, बाकी हो नहीं पाएगा। गलती क्या हुआ था डिजाइन में, यहाँ पे एक ब्रेकर होना जरूरी है, यू नीड टू हैव अ ब्रेकर इन कैपेसिटर बैंक, व्हिच वाज नॉट देयर। एक बार अब ये भी एक चैलेंज है ना भाई, डिजाइन हो गया, ग्रिड सब स्टेशन डिजाइन हो गया, हमारे पास कोई चारा ही नहीं है, सॉल्वेशन करना है। तो ये हमने पहली बार किया था उस टाइम पे, और दिस वाज द बर्थ ऑफ अ कॉम्पनसेटेड लोड, मिक्स लोड। Another case was UK. If you remember, I told you I went to UK for world's biggest offshore wind farm in the 2015 near Manchester. There is a city known as Lancaster. हमने पढ़ा था फर्स्ट ईयर में Lancaster बॉयलर, अगर किसी को याद होगा, यहाँ पे ये बॉयलर का इन्वेंशन हुआ था। ये आपका एक एक्चुअल ऑफशोर विंड फार्म है। ये विंड फार्म में आपके 2 ट्रांसफार्मर लगे हैं, 4 ब्रेकर है, और ऐसा क्या सेक्शन, एंड देयर इज अ केबल 250 एम्पियर का चार्जिंग करंट है इसका, 80 एम्पियर 80 किलोमीटर का केबल। उसको मैंने बोला था कि इतना करंट अगर ग्रिड से आएगा तो रिएक्टिव पावर आपका 250 एम्पियर का पुल करना है 220 केवी से, कोई ग्रिड रेगुलेटर आपको परमिट नहीं करेगा ये। तो उसको कंपेंसेट करने के लिए रिएक्टर लगाया था। अब मैं बताता हूँ हुआ क्या, ये बहुत ही अच्छा एग्जांपल है। मेरा कमिश्निंग इंजीनियर हु इज इन ऑस्ट्रेलिया नाउ, बट ही वाज वर्किंग विद मी इन इंडिया। हम दोनों की जोड़ी बोलते हैं जो चंगू मंगू की जोड़ी। वो मेरा मंगू है, वो साइड पे गया था, उसने बोला उर्मिल भाई, शाम को फोन किया गुजराती में कि यार ये तो कुछ भी लगाया है, उसके ऊपर पीटी लगी हुई है केबल पे, भगवान जाने इन्होंने गलत सबस्टेशन डिजाइन किया है। फिर 5 मिनट में कॉल आया, सॉरी वो पीटी नहीं है, वो है ना आपका ट्रांसफार्मर है। फिर 5 मिनट में कॉल आया, सॉरी सर ये तो रिएक्टर है। मैंने कहा तू पहले डिसाइड कर क्या है, ऐसा बोलेगा तो कैसे चलेगा। फिर उसने बोला रिएक्टर है, मैंने कहा मर गए। मेरे पास अप्रूवल नहीं था विजिट का, रात को मैंने अपने आप, उसके बाद का एक विजिट का अप्रूवल था मेरे पास यूके का, लंदन का, अपना मैंने खुद का रिस्क लेके रात को टिकट करवाया लंदन जाने का, सुबह का फ्लाइट से पकड़ के मैं गया बॉम्बे। वहां जाकर मैंने बॉस को कॉल किया, सॉरी सर मेरे पास परमिशन नहीं है, लेकिन मैंने ये किया है, ऐसा ट्रस्ट था हमारा, तुम जाओ देख लेंगे बाद में। मैं पहुंचा वहां पे, पहला क्वेश्चन मैंने किया कि जब गाड़ी में बैठा साइट पे जाने के होटल से, पहला प्रश्न पूछा मैंने, ये रिएक्टर का भाई साहब करंट कितना है? 250। ट्रांसफार्मर ये केबल का करंट कितना है? 250। अगर ये दोनों 250 है तो ब्रेकर में करंट क्या जाएगा? 0 एम्पियर। अब ये केस मुझे मालूम नहीं सॉल्व करना कैसे है, क्योंकि अगर मुझे इसको क्लोज करना है, प्रॉब्लम क्या है, केबल का जो चार्जिंग करंट आता है उससे आपका ओवर वोल्टेज आता है। और एक चीज ये समझ लो, अगर केबल का इंसुलेशन डैमेज हो गया, अंडर सी केबल है भाई, ये आपका स्विच गियर के प्रोजेक्ट का 50% कॉस्ट गया और अवेलेबिलिटी गया आपका, सत्यानाश, सबसे बड़ा सत्यानाश है ये। तो ये केबल का इंसुलेशन फेलियर है, तो ओवर वोल्टेज कम करना है। पर अगर मैं वोल्टेज 0 पे क्लोज करा तो रिएक्टर के लिए वर्स्ट है। इसका कॉन्सिक्वेंस ये है भाई साहब, ये करंट देखो आप, ये एक केस है गल्फ का, जिसके अंदर मैंने ट्रेनिंग दिया था एक बंदे को, हाफ नॉलेज था उसका, उसने जाके अपना दिमाग लगाया और उसने वोल्टेज 0 पे मार दिया कॉम्पनसेटेड केबल को। ये दिख रहा है करंट 0 टच नहीं हो रहा है। कितना टाइम है ये भाई साहब? 500 मिली सेकंड रियल वेव फॉर्म है। इमेजिन करो कि ये आपने चार्ज किया और यहाँ पे ये डॉटेड लाइन पे अगर आपका प्रोटेक्शन माल ऑपरेट हुआ, गलत से सेंस कर लिया फॉल्ट, और ब्रेकर को ट्रिप कमांड गया, अगर ब्रेकर ने कॉन्टेक्ट ओपन किया, आपके पास करंट 0 ही नहीं है 400 मिली सेकंड पर। इवन इफ आपका 50 एम्पियर भी करंट है, दुनिया का कोई ब्रेकर, एसी ब्रेकर या डीसी ब्रेकर, SF6 ब्रेकर है या आपका इकोनिक ब्रेकर है, इको ग्रीन ब्रेकर है, वो इंटरप्ट कर नहीं पाएगा। आर्किंग होगा, इतने टाइम के लिए ब्रेकर ब्लास्ट करेगा। ये मैंने सॉल्व किया आर्टिफिशियल रेजोनेंस करके साइड पे। ये आपका ओवर वोल्टेज 1.7 PU के आसपास गया और आपका करंट में मिसिंग 0 नहीं आया। लेकिन फिर एक चीज है, यहाँ पे सेंडिंग एंड पे 1.7 PU है, रिसीविंग एंड पे 2.2 जा सकता है। मैंने बोला भाई ये आपका डिजाइन है, ये 2.2 PU जाता है, केबल मैन्युफैक्चरर को पूछो इतना वोल्टेज चलेगा। मेरा एक्सपीरियंस था एक साइकिल के लिए चलना चाहिए, और इट वाज 2.5 PU लिमिट, सो इट सर्वाइव्ड। एंड दिस मेथड टिल टुडे एवरी यूजर इज यूजिंग, whomsoever is the supplier of the breaker relay और whomsoever is the utility, यही मेथड यूज होता है आज की तारीख में। और ये बर्थ हुआ मेरा ट्रांसमिशन लाइन के लिए, टेक्नोलॉजी के लिए। हम अब बात करेंगे ट्रांसमिशन लाइन के लिए 20 मिनट के लिए, और ये मेरा लेटेस्ट टेक्नोलॉजी इनोवेशन है। ये बर्थ कहां से आया मैं आपको बताता हूं। जब भी ट्रांसमिशन लाइन को आपको क्लोज कर, ये इमेजिन करो एक ट्रांसमिशन लाइन है, चलो आप, हम इंडिया में ही बैठे हैं, भरूच में बैठे, भरूच की बात करते हैं। एक ट्रांसमिशन लाइन आपका जाता है भरूच में, एक सब स्टेशन है 400 kV का, वहां से आपका एक लाइन जाता है, चलो कुछ डिस्टेंस ढूंढता हूं मैं, सोचता हूं दिमाग में, यार 200-250 किलोमीटर का लाइन लेते हैं ना, वलसाड़ तक चले जाएंगे। इमेजिन करो एक लाइन आपका जा रहा है यहाँ से आपका वापी तक, 220 किलोमीटर का लाइन है, भरूच से वापी है, 400 kV लाइन है। तो ये लाइन के एक तरफ भरूच सब स्टेशन है, एक तरफ वापी सब स्टेशन है। इसको सोचो भरूच, इसको सोचो वापी। ये आपका लाइन ओपन है दोनों एंड से, मैं यहां से ब्रेकर को क्लोज करता हूं, तो ये लाइन का कैपेसिटेंस चार्ज होता है यहाँ पे भाई, और वो लाइन कैपेसिटेंस चार्ज होने से इसके ऊपर ट्रैवलिंग वेव आता है और ओवर वोल्टेज आता है लाइन के ऊपर। इसको बोलते हैं स्विचिंग ओवर वोल्टेज, जो यहाँ पे राइट साइड पे दिखा है। रिक्लोजर पे आऊंगा मैं, इसको बोलते हैं डेडलाइन चार्जिंग, क्योंकि लाइन आपका ओपन है सिंस लॉन्ग टाइम। केबल, ये जो लाइन का कैपेसिटेंस में एनर्जी नहीं है, कैपेसिटेंस में 0 वोल्टेज है, और मैंने क्लोज मारा, डेडलाइन चार्ज हुआ है। डिस्चार्ज केबल भी हो सकता है, ये क्लोज किया, ओवर वोल्टेज आया। इसको मिटिगेट करने के लिए हम क्या यूज करते हैं, क्लोजिंग रजिस्टर, जिसको बोलते हैं प्री इंसर्शन रजिस्टर। अब लोगों ने ये सोचा यार कि PIR है, अगर वो डैमेज होता है, इसमें कुछ प्रॉब्लम आता है, उसका रिप्लेसमेंट टाइम जाता है। और इवन कई बार क्या होता है कि 400 ओम का रेजिस्टेंस लाइन के सर्ज एम्पीडेंस लोडिंग से मैच नहीं होता। क्रिटिकल रेजिस्टेंस क्या होता है, व्हेन योर कैपेसिटेंस whatever value you have is matching with your critical resistance, so you have to have a resistance value optimized for a line configuration। तो कई बार ओवर वोल्टेज फुल्ली मिटिगेट, देखो एक चीज तो है, मिटिगेट आज तक तो होता है, प्रॉब्लम नहीं है टेक्नोलॉजी में। मैं खुद PIR ब्रेकर बेचता हूँ हिताची में। तो बट लोगों ने सोचा यार मैकेनिकल डिवाइस है, कॉम्प्लेक्सिटी है, गैस कंटेंट ज्यादा है, अगर फेल होता है तो ज्यादा टाइम डाउन टाइम है, रिले फेल होता है तो आपका 2-3 घंटे पे डाउन टाइम में आप सिस्टम को वापस ला सकते हो। तो लेट अस फाइंड आउट अ सॉल्यूशन, रिप्लेसमेंट और अल्टरनेट सॉल्यूशन टू कंट्रोल स्विचिंग, विच इज अ प्री इंसर्शन रजिस्टर्स को रिप्लेस कर पाए। तो हमने कंट्रोल स्विचिंग को यूज करना था। अब मैं टेक्नोलॉजी डेवलप करता हूँ, मेरे हर साल 3-4 पैटेंट निकलते हैं, आज तक 20, खुद अभी मुझे मालूम पड़ा मेरे 20 के ऊपर पैटेंट है, मुझे मालूम ही नहीं था। कोई भी सॉल्यूशन कहां से निकलता है, प्रॉब्लम से। तो पहले सोचते हैं यार कि लाइन स्विचिंग में होता क्या है। तो 2 चीज है, एक हुआ डेडलाइन चार्जिंग, जिसके अंदर प्योरली कैपेसिटिव लोड है, लाइक ए कैपेसिटर बैंक, और दूसरा होता है ऑटो रिक्लोजर। और मैं आपको समझाता हूं कि ऑटो रिक्लोजर में काम कैसे होता है। डेडलाइन चार्जिंग में क्या करना है कि इसको वोल्टेज 0 पे क्लोज कर दो, कैपेसिटर लोड की तरह, और वोल्टेज कम हो जाएगा। बट अगर आपका कॉम्पनसेटेड लाइन है तो आपको टारगेट रखना पड़ेगा बिटवीन पीक एंड जीरो बेस्ड ऑन द कॉम्पनसेशन। टिपिकली क्यों करना पड़ेगा, मैंने बताया था पहले आपको, डीलेड करंट जीरो को मिटिगेट करना है ओवर वोल्टेज के साथ, ये करना है आपको। और टिपिकली ये प्रॉब्लम आएगा जब आपका 50% से ऊपर है कॉम्पनसेशन, मतलब 250 एम्पियर अगर आपका केबल का चार्जिंग करंट है, अगर आपका 125 एम्पियर से ऊपर रिएक्टिव करंट है तो ये प्रॉब्लम आएगा, उसके नीचे इतना नहीं आएगा। तो अगर इसको मुझे वोल्टेज जीरो पे क्लोज करना है, नो कॉम्पनसेशन है तो चलेगा, पर अगर कॉम्पनसेटेड लाइन है तो मुझे वो डिटरमाइन करना पड़ेगा बेस्ड ऑन द कॉम्पनसेशन लेवल। अगर जितना हायर है 50 का 60% है तो टारगेट अगर मैं शिफ्ट करता हूँ 30 डिग्री, अगर मेरा 100% है मैं 45 डिग्री 63 डिग्री करूंगा मैं उसको, टू मिटिगेट द ओवर वोल्टेज एंड द मिसिंग जीरो। आप ये सोचोगे यार कि अगर हम वोल्टेज पीक के आसपास क्लोज करेंगे 63 डिग्री 50 से 70 डिग्री पे तो यार ओवर वोल्टेज नहीं आएगा। फर्स्ट पीक आएगा बट रिएक्टर लगा इसके साथ which is having a considerable inductance, because compensation is higher means inductance is having a higher current value, it will compensate for that over voltage indirectly, but still we have to evaluate it from case to case basis. Now अब हम बात करेंगे रिक्लोजर की। एक और चीज, ये ओवर वोल्टेज जो आता है यार सिर्फ लाइन को इंटीग्रिटी को प्रॉब्लम नहीं करता है, होता क्या है इस ओवर वोल्टेज से, आपका जो इंसुलेटर का स्ट्रिंग होता है, आपको यहाँ दिख रहा है स्ट्रिंग्स है लाइन की इंसुलेटर के ऊपर, ये स्ट्रिंग्स का जो इंसुलेशन है ना उसकी भी कैपेबिलिटी होती है, उसमें भी एजिंग होती है पोर्सेलिन में। ऊपर से उसके ऊपर अगर आपका वाटर डिपोजिशन है, हम लोग यहाँ पे रहते हैं डेनमार्क में साहब रहते हैं, मैं रहता हूँ स्वीडन में, उसके ऊपर स्नो रहता है बराबर, सॉल्ट डिपोजिशन होता है कई बार, अगर आपका नियर टू सी है, पॉल्यूशन रहता है कई बार इंडस्ट्रीज में है, तो इंडस्ट्रियल वेस्ट के कारण। तो पॉइंट क्या है कि इसका एजिंग होता है, तो अगर आपका ओवर वोल्टेज बहुत ज्यादा गया तो फ्लैश ओवर मारेगा टावर के ऊपर टक करके लाइन से ऊपर। ह्यूमिडिटी होती है, मैंने वैष्णो देवी जब दर्शन करने गया था आज से 15 साल पहले, अपनी आंखों से मैंने फ्लैश ओवर देखे 11 kV के ऊपर ह्यूमिडिटी, तब वो समझ में नहीं आता था इतना, बट ये फ्लैश ओवर होते हैं। और नॉट ओनली damages it creates issue with the insulator swing, it also creates issues with the CT, PT, whatever, even power transformer is connected on the grid, सबके ऊपर ओवर वोल्टेज जाता है, सबके ऊपर ये प्रॉब्लम करता है ओवर वोल्टेज। तो कंट्रोल स्विचिंग से कैसे करेंगे, डेडलाइन चार्जिंग तो मैंने समझा दिया। अब लेट अस सी ऑटो रिक्लोजर। तो हम देखते हैं आपका ये हो गया भरूच सब स्टेशन, ये आपका हो गया वापी सब स्टेशन। इमेजिन करो लाइन क्लोज्ड है दोनों एंड से, इसके ऊपर लाइन रिएक्टर लगे हैं। एनजीआर में समझाता हूँ, न्यूट्रल ग्राउंड रिएक्टर आपको मैं समझाऊंगा 2 मिनट में। आशुतोष सर हमारा खत्म होगा एग्जैक्टली 20 मिनट्स में खत्म हो जाएगा सर, बराबर? ओके
ओके सर, नो इशू।
आई होप इट इज फाइन सर, 15-20 मिनट में कर देंगे खत्म। एक और भी केस मुझे बताना है आशुतोष सर, मुझे याद करवाना, जो यहाँ पे बहुत बड़ा डिजास्टर था, फेरो रेजोनेंस किया था लाइन के ऊपर और ये सर्जी अरेस्टर ब्लो हो गया था। मुझे याद करवाना, ये केस मैं बताऊंगा 2 मिनट के लिए, मुझे एंड में बताना है, याद करवाना मुझे, भूल जाऊं तो। अभी ऐसा है कि इस केस में अगर आपका एक इमेज इन करो, देयर इज अ फॉल्ट ऑन अ लाइन नियर टू वापी, देयर इज अ प्रोटेक्शन आईडी हियर, डिस्टेंस प्रोटेक्शन, that will sense it is in a first zone and opens the breaker, and it will give a permissive underreach intertripping scheme to the opposite end of the breaker, and it will also open। एक्चुअली क्या होगा कि ये ब्रेकर का जो रिले है that will see in the second zone। तो पहला शॉक क्या मिला सिस्टम को, फॉल्ट हो गया। देखो यहां से शुरू करते हैं, दूसरा शॉक ब्रेकर ओपन हुआ लेकिन अपोजिट एंड से फीड हो रहा है क्योंकि सेकंड जोन में है। सेकंड जोन का टाइम होता है टिपिकली 400 मिलीसेकंड, तो 400-500 मिलीसेकंड में आपका ये ब्रेकर ओपन होगा। तो आपको क्या होगा, पहला शॉक फॉल्ट, दूसरा शॉक ये ओपनिंग, तीसरा शॉक ये ओपनिंग। इतना अगर होगा इतना टाइम गैप तो वो स्टेबिलिटी को प्रॉब्लम करेगा, डायनेमिक स्टेबिलिटी ऑफ द पावर सिस्टम। इसलिए हम क्या यूज करते हैं डिस्टेंस प्रोटेक्शन में, कैरियर एडेड डिस्टेंस प्रोटेक्शन, कैरियर इंटरट्रिपिंग स्कीम, परमिसिव अंडररीच ओवर। ये भी मैंने हर साल कॉलेज में पढ़ा है, मेरा फेवरेट सब्जेक्ट है प्रोटेक्शन, इट्स अमेजिंग सब्जेक्ट। तो इसके अंदर ये परमिसिव अंडररीच देगा ऑपोजिट एंड को, और ऑपोजिट एंड क्या करेगा, 600 मिलीसेकंड तक वेट नहीं करेगा जोन 2 के लिए। जितना टाइम ट्रैवलिंग वेव को लगेगा उतने टाइम के अंदर ये इसको ट्रिप करवा देगा एक आध साइकिल में। अब इंटरेस्टिंग पार्ट आता है, अब ये सोचो दिमाग में कि ये हो गया तो यार फॉल्टेड फेज तो आपका इंटरप्ट हो गया ना, इसको बोलते हैं फॉल्ट आइसोलेशन। फॉल्ट क्लियर नहीं हुआ है। इमेजिन करो एक ट्री है, ट्री का एक पेड़ है, पेड़ गिर गया लाइन के ऊपर, पेड़ तो ग्राउंड पे टच है अभी, अब क्या है, ये ब्रेकर से हमने लाइन को तो ओपन कर दिया। अब क्या है, हम लोग पढ़ाते कॉलेज में कि भाई आउट ऑफ 100 फॉल्ट्स ऑन अ लाइन 80% फॉल्ट्स आर टेम्पररी, अगर आपको याद होगा। और दैट 20% जो परमानेंट फॉल्ट है उसमें से आपके अगेन 85% फॉल्ट है सिंगल लाइन टू ग्राउंड फॉल्ट लाइक दिस, only one phase to ground fault, which are less severe typically, except if the fault is near to generating station transformer where the zero sequence impedance is very low. Otherwise, for transmission lines, typically single line to ground faults are less severe. Means मैं जानता हूं कि मेरी लाइन पे फॉल्ट हो गया, 80% तो टेम्पररी है। टेम्पररी का मतलब क्या, एक आप नॉर्थ ईस्ट में कोई रहता है तो वो समझ पाएगा इसको, बहुत डेंस फॉरेस्ट है। अब हम जो बोलते हैं कौन सा बोलते हैं, नेक बोलते हैं, इंडिया का जो नेक है चिकन नेक, जहाँ सिर्फ 15-20 किलोमीटर का पोर्शन है, उसके बाद हमारा त्रिपुरा मिजोरम पूरा नॉर्थ ईस्ट आता है। वहां से जो लाइन जाता है फॉरेस्ट के अंदर, फॉरेस्ट में डेंस फॉरेस्ट में बैम्बूज रहते हैं, वो बैम्बू जो बोलते हैं ना, बांस के पेड़, वो विंड से टच करके लाइन को वापस आते हैं। टेम्पररी फॉल्ट मतलब क्या, फॉल्ट हुआ लाइन के ऊपर, ट्री ब्रांच फॉल हो गया, ट्री इधर बर्न आउट हो गया या वाइब्रेशन से वापस आ गया, एक आपका पेड़ गिर गया, वो भी बर्न आउट हो गया, तो अपने आप फॉल्ट क्लियर हो जाता है। इसको बोलते हैं टेम्पररी फॉल्ट। लाइन के ऊपर स्टडी बोलता है 80% फॉल्ट्स आर टेम्पररी, 85%। रिमेनिंग फॉल्ट में भी 85% आर लेस सीवियर। तो हम क्या करते हैं मालूम है, अगर मैं ग्रिड ऑपरेटर हूं, मैं सोचूंगा यार फॉल्ट लाइन पे होगा जहां पे 85% तो टेम्पररी, चलो मैं कैलकुलेटर रिस्क लेता हूं। अगर मैं रिक्लोजर मारूंगा, मैं तो जानता हूं यार कि 85% तो टेम्पररी है, मैं सक्सेसफुल रेट है, मेरा सक्सेस का प्रोबेबिलिटी 85% है, फॉल्ट चला जाएगा। तो ये होता है रिक्लोजर। बट एक चीज है यार, मुझे ट्री ब्रांच को वापस वाइब्रेशन से आने के लिए टाइम देना है, मुझे ट्री को बर्न आउट होने के लिए टाइम देना है, मतलब मुझे टेम्पररी फॉल्ट को क्लियर होने के लिए भी टाइम देना पड़ेगा, करेक्ट। तो रिक्लोजर का डेट टाइम होता है, जो टाइम बिटवीन द ट्रिपिंग टू द रिक्लोजर आई हैव टू पुट सफिशिएंट। टिपिकली वर्ल्ड में जहां मैं गया हूं, एक सेकंड होता है 1000 मिली सेकंड। ट्रिपल पोल रिक्लोजर का रहता है 500 मिली सेकंड रहता है 3 फेज का। पर सिंगल फेज का इतना ज्यादा क्यों होता है, मैं आपको बताता हूँ रीजन। आपने पढ़ा न्यूट्रल ग्राउंडिंग रिएक्टर, लोग सोचते हैं न्यूट्रल ग्राउंडिंग रिएक्टर का यूज होता है फॉल्ट करंट लिमिट करने के लिए, पूरा गलत है ये। इसका यूज मोर इंपॉर्टेंटली क्या होता है मैं बताता हूँ अभी आपको बहुत मजा आएगा। अभी 10 मिनट जो मैं बताऊंगा आपकी आंखें फट जाएगी इसके ऊपर। और ये मेरा है हुक्म का इक्का जो बोलते हैं ना, ये हुक्म का इक्का है। इसको हमने सॉल्व किया है प्रॉब्लम को, विच इज वन ऑफ द क्रिटिकल प्रॉब्लम इन पावर सिस्टम। क्या मैं बताता हूँ, ये दोनों ओपन हो गया, अभी आपका ट्री ब्रांच ग्राउंड को टच है और आर्किंग हो रहा है। ये ट्री ब्रांच से होता है क्या, आर्किंग से फॉल्ट कंटिन्यू करता है और फॉल्ट करंट आपका फिर भी इवन इफ यू हैव ओपन दिस ब्रेकर्स, ये बाकी दो फेज है ना भाई, जो भरूच और वापी लाइन पे जो क्लोज्ड है हेल्थी फेजेस, उसके खुद के कंडक्टर के बीच में कैपेसिटेंस होता है और उनके खुद के कंडक्टर को ग्राउंड कैपेसिटेंस होता है, ग्राउंड पे भी होता है और इंटरफेस भी कैपेसिटेंस होता है। लाइन बहुत बड़ा है, 300 किलोमीटर का सिग्निफिकेंस कैपेसिटेंस है। ये होगा आपका कपलिंग इफेक्ट, जो आपके लाइन जो ओपन हुआ है ना, ये आइसोलेटेड लाइन, उसके ऊपर एनर्जी पंप करेगा। इसको बोलते हैं सेकेंडरी आर्क फिनोमेना, किसी को थोड़ा याद आया हो तो। एंड दैट विल कंटिन्यू अ करंट फ्लोइंग थ्रू अ न्यूट्रल। नाउ ये हो गया लाइन रिएक्टर। मैं आपको बताऊं लाइन रिएक्टर क्या होता है, एक और स्लाइड के ऊपर। ये हो गया भाई लाइन रिएक्टर, ओके। ये न्यूट्रल के अंदर रिएक्टर लगाते हैं आप। ये लाइन है, 3 फेज है, बैलेंस्ड है सर्किट है भाई। ये न्यूट्रल में कब करंट आएगा, जब आपका फॉल्ट होगा तब आएगा। तो उस केस के अंदर आप ये इमेजिन करो कि ये एनजीआर लगा है, तो आपका ट्री ब्रांच से करंट फ्लो होते 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 इधर गया और ये न्यूट्रल पाथ में आया, नीचे 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 नीचे, और यहां से ये पाथ कंप्लीट हुआ। तो ये इंडक्टेंस आपके, ये करंट का ये कपलिंग कैसा है यार, कैपेसिटिव है, राइट। ये कैपेसिटिव कपलिंग आपके इंडक्टेंस ऑफ द न्यूट्रल ग्राउंडिंग रिएक्टर इस रिएक्टर से अपोज करेगा एक्सएल माइनस एक्ससी। तो नेट करंट आपको 30-40 एम्पियर के अंदर लाना है, जो एयर ऑफ द आर्किंग विल नॉट एबल टू सस्टेन है, और आर्क आपका क्वेंच होगा। इसको बोलते हैं सेकेंडरी आर्क क्वेंचिंग। अगर सेकेंडरी आर्क क्वेंच नहीं हुआ है और यार हमने रिक्लोजर मार दिया ना, तो एक्चुअली फॉल्ट परसिस्ट कर रहा है और आपका रिक्लोजर फेल करेगा। इसको बोलते हैं फेल्ड रिक्लोजर। और आपका होता क्या है, लाइन को ट्रिप किया, रिक्लोजर अटेम्प्ट किया, सेकेंडरी आर्क अभी तक क्वेंच नहीं हुआ है, फॉल्ट है, तो वो जैसे ही क्लोज होगा फिर से रिले सेंस करके उसको लकआउट करेगा रिक्लेम टाइम में, और ये फेल करेगा। तो हमको क्या करना चाहिए, सेकेंडरी आर्क डिटेक्ट करना चाहिए। जैसे ही सेकेंडरी आर्क आपका क्वेंच हुआ, आप इमेजिन करो निकल गया सेकेंडरी आर्क विद इन डेट टाइम। पर ऐसा हो सकता है यार, ये जो फॉल्ट होता है ना भाई, उसके थ्रू आपका एनर्जी डिसिपेट होता है, जो आपका फॉल्ट का एनर्जी है ना वो भी डिसिपेट होता है। तो आपका एक बार सेकेंडरी आर्क गया, उसके बाद भी हो सकता है कि ये कैपेसिटेंस या लाइन का स्ट्रे कैपेसिटेंस, उसमें कुछ स्टील एनर्जी लेफ्ट है और वो करेगी ऑसिलेट। हाँ, एलसी सर्किट है भाई, ये आपका क्या लाइन रिएक्टर है, ये लाइन रिएक्टर ऑसिलेट करेगा स्ट्रे कैपेसिटेंस और एलसी सर्किट बनेगा आपका। उसका फ्रीक्वेंसी टिपिकली पावर फ्रीक्वेंसी 50 हर्ट्ज अगर मानते हैं सिस्टम में, कैन रेंज फ्रॉम 20 हर्ट्ज टू एज गुड एज 49 50 हर्ट्ज बेस्ड ऑन द कंपनसेशन लेवल। तो एक्चुअली क्या है, ये जो कपलिंग है भाई, उसके कारण आपका पावर फ्रीक्वेंसी तो रहता है ये वोल्टेज के ऊपर, लेकिन उसके ऊपर सुपर इम्पोज होता है आपका कपलिंग इफेक्ट का बीट फ्रीक्वेंसी, इसको बोलते हैं बीट, BEAT, बीट फ्रीक्वेंसी। ये इसके ऊपर सुपर इम्पोज होगा और इसके ऊपर वोल्टेज आएगा यहाँ पे। और जब मैं इसको रिक्लोजर मारूंगा इस पॉइंट पे, तो मुझे क्या करना है, ओवर वोल्टेज कम करना है, कैपेसिटिव लोड है, गैप वोल्टेज 0 पे क्लोज करना है। व्हाट इज द गैप वोल्टेज, सोर्स वोल्टेज माइनस लोड वोल्टेज, ये वोल्टेज 0 नहीं है भाई। और एक बहुत इंपॉर्टेंट चीज, फॉल्ट का लोकेशन कई बार यहाँ हो सकता है, कभी यहीं हो सकता है, कभी यहाँ हो सकता है, कभी यहाँ हो सकता है। फॉल्ट रेजिस्टेंस भी बदलता है, शॉर्ट सर्किट करंट भी बदलता है। तो सेम वापी टू भरूच की जो लाइन है, उसी लाइन का कॉन्फ़िगरेशन अगर सेम है तो भी ऑपरेशन टू ऑपरेशन, फॉल्ट टू फॉल्ट कंडीशन में आपका शॉर्ट सर्किट करंट बदलेगा, फॉल्ट ड्यूरेशन बदलेगा, सेकेंडरी आर्क का ड्यूरेशन भी बदलेगा, तो आपका बीट फ्रीक्वेंसी वोल्टेज भी बदलेगा। तो मुझे क्या करना पड़ेगा कंट्रोल स्विचिंग में, अगर मैं रिले हूं तो मुझे पहले ये सेंस करना है कि मेरा ब्रेकर ओपन हुआ। अच्छा, ये ओपन हुआ, अब रिक्लोजर कमांड आया। क्या ये ऑटो रिक्लोजर है, डेडलाइन चार्जिंग है, कैसे मालूम पड़ेगा मुझे? प्रोटेक्शन आईडी में हमेशा एक ऑटो रिक्लोजर रेडी नाम का कमांड जाता है, ऑटो रिक्लोजर रिले से, वो मैं अपने रिले में डालूंगा। अगर वो 0 है मतलब ये डेडलाइन चार्जिंग है, 1 है तो रिक्लोजर है। दूसरा मेथड क्या है, अगर मेरा डेड टाइम से ज्यादा टाइम बीत गया है ओपन होने के बाद, तो इट इज एक्चुअली अ नॉर्मल डेडलाइन चार्जिंग। अगर डेडलाइन चार्जिंग है तो लाइन का जो कैपेसिटेंस है ना भाई, उसके अंदर कोई एनर्जी नहीं है, तो उसका मुझे वोल्टेज यहाँ पे जो है, ये बीट फ्रीक्वेंसी वोल्टेज को इग्नोर करना है, बहुत कम वोल्टेज है, 0 है ऑलमोस्ट, तो मुझे ये इग्नोर करना है। अगर रिक्लोजर है तो मुझे क्या करना है, ओपन होने के बाद ये सेंस करना है कि मेरा ऑपोजिट एंड भी ओपन हो गया यहाँ का। अच्छा, फिर ये सेंस करना है सेकेंडरी क्वेंच हो गया, उसके बाद जो वोल्टेज आता है ना भाई बीट फ्रीक्वेंसी, उसके सैंपल उठाने हैं आफ्टर सेकेंडरी क्वेंचिंग लाइन साइड से, और उसको एक्स्ट्रापोलेट करना है फ्यूचर के लिए। फिर मुझे क्या करना है कि डेट टाइम कितना दिया है भाई, 1000 फ्रॉम द ट्रिपिंग। तो अगर मुझे 1000 पर रिक्लोजर मारना है, तो उसके पहले कौन सा मेरा टारगेट है, गैप वोल्टेज 0, कंसिडरिंग दिस वोल्टेज एंड दिस वोल्टेज, सोर्स साइड का गैप वोल्टेज सबट्रैक्शन का, जैसे करके मेरा ओवर वोल्टेज कम हो। और ये हमारा रिले इसके लिए एफिशिएंट है। और ये एक और इंटरेस्टिंग चीज क्या है, उस पर मैं आऊंगा 2 मिनट में। ये वोल्टेज कैसा दिखता है, ये एक्चुअली 400 केवी सिस्टम है, और ये जो आपको वेवफॉर्म दिख रहा है, मैं आपको जरूरी बोलूंगा, एक ही वेवफॉर्म पे मैंने पूरा रिले डेवलप किया है। ये जो दिमाग है इसमें, एल्गोरिथम मैंने नहीं बनाए, प्राइड टू से इट्स ए इंडिजिनियसली इंडियन प्रोडक्ट। मतलब क्या है, इसका एल्गोरिथम में इंडियन है, मेरा दिमाग चला। अच्छा, मैं आपको थोड़ा बता सकता हूँ, IIT बॉम्बे के साथ हमने ये डेवलप किए एल्गोरिथम्स, प्रोफेसर सोमन साहब के साथ। दूसरे मेरे गाइड है डॉक्टर भावेश बालजा, मेरे फैमिली फ्रेंड भी IIT रुड़की में, उन्होंने भी मुझे काफी हेल्प किया था PhD में, वो भी उन्होंने भी हेल्प किया। एक और हमारे PhD स्कॉलर है कुणाल भट्ट, आया वो LD इंजीनियरिंग कॉलेज में प्रोफेसर, उन्होंने भी मुझे काफी हेल्प किया डेवलपमेंट में। फिर हमने ये क्या एल्गोरिथम डेवलप किया, गोपाल गज्जर करके एक हमारे हिताची में काम करते हैं, 10 का रावण बोलता हूँ उनको मैं, इतना इंटेलिजेंट आदमी मैंने लाइफ में नहीं देखा है आज तक। हमने इंटेंजसली काम किया, और एक आदमी को मैं नहीं भूल सकता, एक प्रोफेसर जीवन आधार जोशी, जो आपके यहाँ ADIT में प्रोफेसर थे 12-13 साल पहले। हम लोगों ने, इन लोगों का जो एक्सपीरियंस है, उन लोगों का जो नॉलेज मुझे थोड़ा बहुत ट्रांसफर हुआ है, हेल्प किया है, हम लोगों ने साथ बैठ के इसका टेक्नोलॉजी प्रोजेक्ट डेवलप किया ऑलमोस्ट 2 से 2.5 साल। फिर उसके बाद मेरा एक स्टूडेंट था जो अभी मेरी कंपनी में नहीं है, GE में है, NIT वरंगढ़ का लड़का है, नवीन दुबे करके। हेलो, यस, बोलिए। अभी 7 मिनट है मेरे पास, राइट? मैंने घड़ी देखा 7 मिनट है, करेक्ट? मैं खत्म करता हूँ फटाफट, बराबर। ये एग्जांपल बताता हूँ कि ये लड़के ने लैब डेवलप किया। मैं बताता हूँ हम काम कैसे करते हैं। पहले टेक्नोलॉजी डेवलप किया यूनिवर्सिटी के साथ, उसके बाद ये लड़के ने लैब बनाया। उसके अंदर हमने मैटलैब के अंदर छोटे छोटे एलसी सर्किट बना के पूरा लैब डेवलप किया। ब्रेकर का आईजीबीटी बेस्ड सिमुलेशन का एक पूरा बॉक्स तैयार किया जो ब्रेकर की कैरेक्टरिस्टिक्स सिमुलेट करता है। उसके अंदर ये एल्गोरिदम्स को हमने टेस्ट किए जो हमने डेवलप किए एकेडमिक्स से, और उसके बाद हमने रिक्वायरमेंट स्पेसिफिकेशन मैंने खुद लिखा और उसके हमने दिया अपने रिले डेवलपमेंट टीम को प्रोडक्ट डेवलप करने के लिए। और पैरेलली मैंने क्या काम किया, मैंने इसको प्रमोट करना शुरू किया डिफरेंट एग्जीबिशंस में, कॉन्फ्रेंसेस में। कनाडा गया था एज ए एक्सपर्ट इन ट्यूटोरियल्स, एज ए इनवाइटेड गेस्ट इन सिगरे। इस टेक्नोलॉजी को प्रमोट किया मैंने। उसके बाद मैं 9 कस्टमर्स के पास गया आखिरी 1 साल में, जहां ट्रांसमिशन लाइन है वर्ल्ड की लॉन्गेस्ट, और इसको मैंने प्रमोट किया। पहला सेंटेंस लोगों ने क्या बोला, PIR ये हमको चाहिए, हम क्यों कंट्रोल स्विचिंग पे जाए। और मैंने ये टेक्नोलॉजी को बाय करवाया उनसे और पायलट विन किया। और मुझे एक पायलट तो वहां मिला है जहां पे हमारे ब्रेकर एक्सप्लोड हुए, कंट्रोल स्विचिंग ऑन द लाइन यूज करके, मिसिंग जीरो पे, हाईली कॉम्पोजिटेड लाइन पे। वहां पे मैं पायलट लाया जीत के, क्योंकि टेक्नोलॉजी पॉइंट ऑफ व्यू उनको मैंने कन्विंस किया। और ये आपको एग्जैक्टली वही दिख रहा है। फॉल्ट हुआ लोकल एंड पे, ये ब्लैक लाइन पे ओपन हुआ, ऑपोजिट एंड पे यहाँ पे ओपन हुआ, ये सेकेंडरी आर्क हुआ, यहाँ पे क्वेंच हुआ, यहाँ पे सैंपल उठाए मैंने, सैंपल को एक्स्ट्रापोलेट किया, रिक्लोजर मारा। एग्जैक्टली सेम चीज रिले के अंदर हमने डाला है। इसके सिवा और 3 चीजें हैं जो मैंने की थी बिफोर आई वेंट टू द यूजर्स। आई प्राइड टू से दैट एक ऐसा मुझे सिनेरियो आज तक नहीं मिला है जिसके अंदर फेल होगा ये। एक मुझे ऐसा यूजर ने यूटिलिटी ने बता नहीं सिनेरियो जहां पे ये लिमिटेशन है, ये हर एक सिनेरियो को मीट करेगा। पहला क्या है, सेकेंडरी आर्क क्वेंचिंग, उसके बाद ही मैं सैंपल उठा के रिक्लोजर मारूंगा। दूसरा चीज वेरी वेरी इंटरेस्टिंग, और ये मैं गया था ब्राजील, ईपी, हाँ ब्राजील गया था मैं, जहां पे प्लानिंग कमीशन को मिला था मैं, विच इज डिसीजन अथॉरिटी। इंडिया में भी मैं मिला हूँ प्लानिंग कमीशन को, CTU बोलते, चीफ ट्रांसमिशन यूटिलिटी है इंडिया में। अच्छा एक चीज और भी, उनके अंदर एक हमारा एक दोस्त है जो पावर ग्रिड में काम करते थे पहले, जो एक सब स्टेशन में काम जाते थे, मैं कमीशनिंग करने गया था, उन्होंने वो मोटिवेट होकर, उनको मैंने PhD गाइड की थी, और फिर उन्होंने मोटिवेट होके बोला कि मुझे इसमें कंट्रोल में PhD करनी है। तो हमने किया, और अभी वो CTU में है, और लाइन स्विचिंग भी हम साथ में बहुत काम करते हैं। उन्होंने बहुत हेल्प किया मुझे इन टर्म्स ऑफ गेटिंग सम इनपुट्स ऑन द हाउ एक्चुअल सिनेरियोज आर वर्किंग। तो ये जो भी हमने डेवलप किया है वो ट्रांसमिशन लाइन जो इंडिया के अंदर है पावर ग्रिड, उसका यूज करके ही हमने फील्ड एक्सपीरियंस को डेवलप किया है। राइट टू से इंडिजिनस इंडियन है ये। इसके एल्गोरिथम डेवलप होने के बाद हमने जो यूटिलिटीज को भी दिया, वो भी हमने किसको दिया था, सॉरी, हमने अपने R&D सेंटर को दिया डेवलप करने के लिए, हिताची के बेंगलोर में। इंडिया के अंदर इसके एल्गोरिथम्स डेवलप हुए हैं, पूरे कोड हुए हैं, टेस्टिंग हुआ है इसका, और इंडिजियसली इंडियन प्रोडक्ट है। प्राइड टू से इसका लॉन्च भी हमने लास्ट ईयर किया इंडिया में, ETW, इट वाज अ एग्जीबिशन विच वाज रन बाय हिताची एनर्जी इन इंडिया, 75 ईयर सेलिब्रेशन। 4 दिन पहले हमने लॉन्च किया। हमने ये कहा था कुछ भी हो जाए रात दिन काम करेंगे, हम इसको रिलीज करेंगे इसी प्रोडक्ट को। तो हमको इसको फॉर्मली, हमारी एक अंदर प्रोसेस है, गेट प्रोसेस, रिलीज करते हैं हम लोग उसको। हमने 4 दिन पहले, 4 भी नहीं, फ्राइडे इवनिंग 5 बजे लॉन्च किया। मंडे इसको हमने, फ्राइडे 5 बजे हमने इसको रिलीज किया इंटरनली कंपनी में, और मंडे इसको हमने लॉन्च किया एग्जीबिशन में। ये डिटर्मिनेशन रखना है कि इंडियन है हम यार, फ्लैग, वहां पे गोरे आए थे, पूरे वर्ल्ड के लोग आए थे, हमको दिखाना है हम साले इंडियन किसी से कम नहीं। मैं इमोशनली बोलता हूँ ये चीज, हम सबको बीट कर सकते, 10 सिर के रावण है, हम सबको बीट कर सकते हैं। और ये टेक्नोलॉजी ब्रेक थ्रू है, इतना मैं बोल सकता हूँ आपको। सेकंड केस क्या है, EPA में मैं गया था, उन्होंने क्या बोला कि इमेजिन करो कि वापी से आपका भरूच में एक लाइन है, अब वापी के बाद एक और लाइन बॉम्बे जाता है। इमेजिन करो वापी और भरूच एंड पे 2 रिएक्टर है, 40% ऑन दिस एंड 40% ऑन दैट एंड। वापी की तरफ एक रिएक्टर है लाइन की तरफ, लाइन साइड पे, और दूसरा एक रिएक्टर भरूच की तरफ लाइन साइड पे। अब एक सिनेरियो ऐसा है इनको प्रॉब्लम कि एक बार ऐसा हुआ कि आपका ये जो लाइन था वापी भरूच का 300 किलोमीटर, जब फॉल्ट हुआ तो उसके बाद का लाइन भी ट्रिप हो गया। मतलब रिएक्टेंस सेम है 80%, बट आपका लाइन का कैपेसिटेंस एक और लाइन का जुड़ गया, तो वही लाइन का रिएक्टेंस चेंज हो गया। तो मेरे कमीशनिंग इंजीनियर को लाइन को 80% कॉम्पनसेशन पे प्रोग्राम किया था, अपने आप कॉम्पनसेशन लेवल बिकॉज ऑफ हाई कैपेसिटेंस कम होके 40% हो गया। मेरा रिले क्या करता है, यही देखो आप, मैंने एक इंडक्टर उड़ा दिया, मेरा ये रिले अपने आप ये वोल्टेज का वेवफॉर्म से अपनी लाइन की फ्रीक्वेंसी निकालता है, बिट फ्रीक्वेंसी, और अपना कॉम्पनसेशन खुद निकालता है। तो अगर किसी ने प्रोग्राम 80 किया है, अगर ये बीट फ्रीक्वेंसी अलग कुछ आई तो अपने आप वो अडेप्ट करता है और अपना एल्गोरिथम बदल देता है वो। तीसरा काम ये करता है डिलेड जीरो कॉम्पनसेशन। मैंने बताया था कि डिलेड जीरो आता है रिले के ऊपर, वो कैसे हम कॉम्पनसेट करें। और ये जो चीज है ये समथिंग अमेजिंग, मैं आपको 2 मिनट बताऊंगा कैसे सॉल्व होता है। इमेजिन करो ये आपका लाइन वोल्टेज है। देखिए एक चीज, ये ऊपर को जो दिख रहा है ना, ये आपका लो कॉम्पनसेटेड लाइन का है, 50% कॉम्पनसेशन से लो है, इसमें डिलेड करंट जीरो का इश्यू नहीं आता है। पर ये हाई कॉम्पनसेशन में वोल्टेज जैसे एनवेलप जैसा दिखता है। अब ये वोल्टेज में मुझे क्लोज कब करना है गैप वोल्टेज 0 पे टू रिड्यूस ओवर वोल्टेज। पर अगर मैं 0 पे करूंगा तो इंडक्टेंस हाई है तो मिसिंग 0 आएगा, ब्रेकर ब्लास्ट हो सकता है। अगर एक चीज ये भी याद रखो कि ब्लास्ट हमेशा नहीं होता है। अगर ब्रेकर आपका क्लोज्ड है, करंट में अगर 0 क्रॉसिंग नहीं है, अगर आपने ब्रेकर को ओपन नहीं किया तो कुछ नहीं होना है। लेकिन अगर प्रोटेक्शन फेल हो गया, प्रोटेक्शन माल ऑपरेट हुआ, किसी ने गलती से ब्रेकर को ओपन मार दिया, करंट 0 नहीं है तो ब्लास्ट होगा। पर ये रेस्ट ऑफ रेयर इवेंट है, सीधा ये सेफ्टी के ऊपर आएगा, विच इज ऑटमोस्ट कंसर्न इन द वर्ल्ड। ब्रेकर एक्सप्लोड होगा, विच इज बिगेस्ट रिस्क ऑन सेफ्टी। तो इस पे कोई कॉम्प्रोमाइज नहीं है। तो ये सॉल्व कैसे करें इसको? तो मैंने क्या सोचा, यार इतने सारे 0 क्रॉसिंग है, देखो गैप वोल्टेज 0 पे बराबर। अब ये सोचो कि अगर मैं ये पीक उठाता हूँ वोल्टेज का, इसके पहले का 0 उठाता हूँ, इस पे क्लोज करूंगा तो डिलेड करंट 0 आएगा। पर अगर मैं इसको 45 डिग्री पे क्लोज करूंगा तो मेरा 0 डिलेड 0 भी जाएगा, ओवर वोल्टेज थोड़ा सा कम होगा, पूरा कम नहीं हो पाएगा। तो इसकी जगह अगर मैं ये पिक की जगह, ये इसको बोलते हैं वैली रीजन, ये पिक पकड़ता हूं मैं। कैन यू म्यूट प्लीज, आई एम अबाउट टू फिनिश इन 1 मिनट। अगर ये पिक का 45 डिग्री यहाँ पे आता है, मेरा कर्सर दिखता है, तो उसकी जगह ये पिक की जगह मैं ये वैली रीजन का पिक पकड़ता हूँ। ये टिपिकली 50% कम होता है, 40 से 50%। उसका 45 डिग्री यहाँ पे आएगा, तो ये इंस्टेंटेनियस वोल्टेज है। उसकी जगह ये इंस्टेंटेनियस वोल्टेज पे मैं अगर क्लोज करता ना, तो मेरा ओवर वोल्टेज भी कम होता कंपेयर टू दिस क्लोजिंग, और मिसिंग 0 भी नहीं आता। और एग्जैक्टली हमने किया है सॉल्यूशन, एग्जैक्टली सेम। ये 45 डिग्री है इन वैली रीजन। तो ये 3 चीज करने से ये चीज हो गया कि हमारा रिले हर एक सिनेरियो के लिए डायनेमिकली चेंज सिस्टम कंडीशंस के लिए काम कर रहा है। ये एक सिमुलेशन। अब ये एक आखिरी चीज हमने किया, 3.5 साल का प्रोजेक्ट व्हाइट पेपर बनाया हमने, IIT बॉम्बे के प्रोफेसर थे उनके साथ और कंसल्टेंट के साथ, कि हमने एक ट्रांसमिशन लाइन का मॉडलिंग किया और हमने इतने सारे पैरामीटर को सिमुलेट किया। शंट रिएक्टर है दोनों एंड के ऊपर, लाइन का आपका फ्रीक्वेंसी डिपेंडेंट मॉडल है। सेकेंडरी आर्क को हमने मॉडल किया IEEE पेपर से। इट्स वेरी टफ टू मॉडल दिस सेकेंडरी आर्क फिनोमेना। 1 सेकंड बताता हूं मैं आपको। ये सेकेंडरी आर्क है, उसका नॉन लीनियर रेजिस्टेंस रहता है, इसको मॉडलिंग किया, सिमुलेशन स्टडी किया हमने। कितना एग्जॉस्टिव वो देखो। अगर मुझे किसी कस्टमर को कन्विंस करे जो PIR यूज कर रहा है सक्सेसफुल है, कैसे कन्विंस करूं? मेरा सॉलिड बैकग्राउंड चाहिए, ये है मेरा बैकग्राउंड। 400 के भी 765 500 के भी लाइन, डिफरेंट लेंस, डिफरेंट फ्रीक्वेंसीज, अनकंपनसेटेड शंट कंपनसेटेड, सीरीज कम शंट कंपनसेटेड, डेडलाइन चार्जिंग, ट्रिपल पोल रिक्लोजर विद सिंगल लाइन टू ग्राउंड फॉल्ट एंड सिंगल। अच्छा एक चीज, अगर मैं सिंगल पोल रिक्लोजर को अगर सिमुलेट करता हूं, उसकी जगह ट्रिपल पोल करता हूं, ज्यादा सीवियर है। क्यों? नॉन फॉल्टेड फेज को ओपन करते हो तो सिस्टम में अनबैलेंस आता है, उससे ओवर वोल्टेज और सीवियर जा सकता है। और मैंने किया रैंडम स्विचिंग, मतलब कोई PIR नहीं है, कंट्रोल स्विचिंग नहीं है, सर्ज अरेस्टर कुछ नहीं है। सर्ज अरेस्टर लाइन पे रहते हैं स्विचिंग ओवर वोल्टेज के लिए, कुछ नहीं है। तो ओवर वोल्टेज कितना जाएगा? उसको कंपेयर किया PIR विद सर्ज अरेस्टर, और सेम सर्ज अरेस्टर बट इंस्टेड ऑफ PIR कंट्रोल स्विचिंग, मेरा 2 PU के अंदर वोल्टेज आया। और इवन मैंने इसके अंदर ब्रेकर का स्टैटिस्टिकल वेरिएशन भी कंसिडर किया है कि अगर आपका मैकेनिकल वेरिएशन आता है तो क्या होगा। मॉन्टी कार्लो सिमुलेशन किया है, IEC 60071 इंसुलेशन कोऑर्डिनेशन स्टैंडर्ड का यूज करके हमने सिमुलेशन स्टडी किया। हर एक में ओवर वोल्टेज 2 PU के अंदर रहा है हमने। और हमारा की मैसेज इसलिए ये गया कि कंट्रोल स्विचिंग कैन बी एफिशिएंट अल्टरनेटिव टू प्री इंसर्शन रेजिस्टर्स। एंड समरी ये है कि कंट्रोल स्विचिंग अगर हमको करना है तो इट कैन बी यूज फॉर all type. I will remove most now because when I made this slide the line was not launched. It can be used for any lines. Suitability check करना है ब्रेकर का, जो मैंने समझाया। रियलिस्टिक गोल करो यार, आप 20 एम्पियर नहीं ला सकते, 1 PU के अंदर इनरश करंट रहेगा, ओवर वोल्टेज आपका मिटिगेट होगा, पर वो उसका भी एक लिमिट रहेगा। राइट टाइप ऑफ CTPD यूज करो, सिंगल लाइन डायग्राम यूज करो। कई बार क्या होता है कि वायरिंग में इश्यू है, फर्स्ट फेज का कमांड सेकंड फेज को डाला हुआ है, मतलब रेड फेज का आउटपुट कमांड येलो फेज कॉइल को डाला है, रेड फेज का CT येलो फेज में लगाया हुआ है। काफी सारे इश्यूज है। उस कारण से क्या होता है कि लोगों ने अननोटिस जाता है, रिले गलत काम करता है, ब्रेकर एक्सप्लोड हो जाता है, लिटरली बाईपास रहता है ब्रेकर, रिले बाईपास हो जाता है। ये सारे बहुत सारे प्रॉब्लम्स है। सूटेबल सिस्टम की कैरेक्टरिस्टिक्स। और एक चीज और है, मैं रिले लोग क्या करते हैं, लगा दिया काम हो गया, ऐसा नहीं है। मैं लाइव स्विचिंग करता हूँ। हम लोग प्री कमीशनिंग चेक करते हैं, वायरिंग चेक करते हैं, और लाइव स्विचिंग करते हैं 5 से 6 ऑपरेशन ऑन द सिस्टम टू चेक द वैलिडेशन ऑफ द सिस्टम वर्किंग। और मेरा की मैसेज सबको रहता है कि पूरा सिस्टम समझो, अकेला रिले मत समझो। और अब मैं आपको दिखाऊंगा लास्ट वन स्लाइड विच आई टोल्ड यू, विच वाज टू बी शोन वेयर इट वाज अ फेरो रेजोनेंस केस, एंड दैट इज माय लास्ट स्लाइड टू शो फॉर टुडे। ये केस था भाई साहब, ये केस था यूरोप के अंदर, कंट्री में कॉम्प्लायंस में बता नहीं सकता आपको। वो न्यूक्लियर पावर प्लांट हो जाता था, 2 घंटे खींच का लाइन था, वाटर टाइम था। इसके अंदर क्या हुआ मैं बताता हूं आपको। कम ऑन, जस्ट 1 to 2 minutes मोर, आई एम डन। इसके अंदर ये हुआ कि मुझे ये बोला गया भाई कि ये रिएक्टर है, लाइन का एक लाइन लगा है, ट्रांसफार्मर है, और एक रिएक्टर लगा, इतना सारा लगा है टांग जांग। ये रिएक्टर इनका आउट है बिकॉज ऑफ अ प्रॉब्लम इन द बुशिंग। इन्होंने बोला कि मुझे इसका रिएक्टिव पावर मैनेजमेंट करने के लिए ये ब्रेकर जब क्लोज करूंगा, जब ये ट्रांसफार्मर रिएक्टर क्लोज करूंगा। मैंने लिख के दिया कि मत करो, लाइन था 400 kV, फेरो रेजोनेंस बनेगा ये, क्योंकि फिक्स कैपेसिटेंस ऑफ द लाइन एंड इंडक्टेंस ऑफ द ट्रांसफार्मर नॉन लीनियर, ऑन टॉप ऑफ इट रिएक्टर 765 kV। ये करने से इस टाइप का वेवफॉर्म आया। अब देखो हार्मोनिक्स, ये इंपॉर्टेंट नहीं है, ये वोल्टेज से यहाँ पे सर्ज रेजिस्टर एक्सप्लोड हो गया। तो पॉइंट ये है कि कई बार सिस्टम को समझोगे नहीं और ऐसा कुछ करोगे तो यू विल एंड अप इन अ डिजास्टर। ये इज अ लाइव क्लासिक एग्जांपल ऑफ इट। ये केस मैंने आपको ऑलरेडी दिखाया। आई थिंक दिस वाज द केस व्हिच आई वांटेड टू शो यू। आई थिंक कुछ और तो बचा नहीं है जो मैं दिखा पाऊं एक आधे वेवफॉर्म। आई थिंक दिस वाज द वन, करेक्ट। ये भी दिखाया मैंने आपको ऑलमोस्ट। ये सिस्टम स्टडी का पूरा एक पेपर। अच्छा, एक चीज, एक पेपर पब्लिश हुआ है सिगरे में 2024 में, यही चीज को पूरा समझाया है। और लास्ट ईयर सिगरे कनाडा में एक पेपर पब्लिश हुआ है, सिगरे कनाडा, उर्मिल परीख लिखना आपको ऑथर में। आपको 2 पेपर मिलेंगे, जो सब कुछ लिखा है सब कुछ उसके अंदर अवेलेबल है। आप उसको डाउनलोड करके आराम से स्टडी कर सकते हो, पूरा एक्सप्लेन किया है ये सब उसके अंदर। डन, आई थिंक आई एम डन। थैंक यू सर, आई होप आई फिनिश्ड ऑन टाइम। हाँ, एग्जैक्टली 1.5 hour.
Yes, sir. Thank you very much. Thank you. I hope so because.
सर को कुछ क्वेश्चन है?
संजीत सर, yes, you are welcome, sir.
I hope it was बुलेट ट्रेन था मेरा, हमेशा बुलेट ट्रेन बोलते हैं मुझे, बट ट्राई किया, कुछ एक्सपीरियंस शेयर किया सर।
Sir, I have enjoyed your lecture and it was full of energy, and I can resonate with your thought that what I'm doing here in Denmark from last 2 decades, I'm trying to propagate and share with Indian colleagues, Indian students, Indian friends, and the same zeal I can see in you. You also trying to do this. That's great. So very great presentation, Dr. Urmil. I enjoyed a lot, and I was not even for a minute to go away from here.
Sir,
I have a practical question. In our wind turbine industry, we are working on 690 volt supply because there is a, there are disapproval and these, standards and the regulatory commission requirement. So they are not going for medium
सर, मैं 690 किसका बोल रहे हो आप? सॉरी टू इंटरप्ट किया आपको।
in turbine में जो हमारा जो कन्वर्टर है, हमारा जो जनरेटर है, उसको हम 690 वोल्ट पे ही रखते हैं। तो प्रॉब्लम यहाँ पे है,
मुझे समझ दीजिए, आप ये बोल रहे हो कि एक विंड टर्बाइन रोटेट होता है जिससे एक वोल्टेज बनता है, इन्वर्टर से आप उसको जो देते हो ग्रिड को, वो आपका 690 वोल्ट पे, आप ये बोल रहे हो क्या?
तो अंदर हम जो रखते हैं ग्रिड पे, तो हम फिर 66 केवी 132 केवी और वो 220 वो डिपेंड करता है। इनसाइड की बात कर रहे हैं।
समझ गया।
वहां पे सर, वहां पे सबसे क्रिटिकल कंपोनेंट है सर, वी हैव दिस सर्किट ब्रेकर, ग्रिड साइड सर्किट ब्रेकर एंड जनरेटर।
66 केवी की बात कर रहे हो आप? ग्रिड मतलब 66 केवी?
ना, लो वोल्टेज 690 वोल्ट सर्किट ब्रेकर ऑन grid side, because to connect the grid we need this supply to be fed in.
So
तो साहब ये है कि 620 तो स्टेप अप ट्रांसफार्मर के आपका और कुछ है बीच में?
हाँ,
इसमें कुछ ऐसा SLD है आपके पास? SLD दिखाओगे?
हाँ, स्टेप देखिए मैं बता रहा हूँ, जनरेटर है 690 वोल्ट, देन
SLD खोल लो ना साहब, SLD खोल लो ना द्विवेदी साहब, SLD खोल लो ना अगर 2 मिनट है। अरे गिरी साहब थोड़ा बात करेंगे 5 मिनट, थोड़ा प्रैक्टिकल है, डिस्कशन हो रहा है, 5 मिनट लेते हैं यार, आपके कंप्यूटर कंटेस्टेंट को भी मजा आएगा।
I am also learning through your discussions.
और
That's why
बाइट
there is
गिरी
no
साहब
worry,
मैं
sir.
आपको कसम
I
से
am
बोल रहा
also
हूँ
here.
साहब, आपको कसम से बोलता हूँ, जो आपका एक्सपीरियंस मिल रहा है ना कि इस टाइप का प्रैक्टिकल डिस्कशन, ये बहुत रेयर है, मैं बता रहा हूँ आपको, लोग तरस जाते हैं।
Yes. If there are two field experts are talking, we people should listen very carefully. Yeah. Please go ahead.
बोलिए साहब, क्या बोल रहे हैं आप?
I'm trying to draw the single line diagram.
अरे छोड़ दो साहब, बोल दो, चलो ड्रॉ करने में कहाँ टाइम निकालोगे?
तो जनरेटर
है
690 वोल्ट जनरेटर है, फिर उसके बाद एक सर्किट ब्रेकर आपने लगाया 690 वोल्ट, इसके बाद फिर पावर कन्वर्टर है, वो आपका बैक टू बैक VSC है, उसके बाद फिर आपने एक सर्किट ब्रेकर लगाया, और उस सर्किट ब्रेकर यू हैव फीड इनटू स्टेप अप ट्रांसफार्मर. सो माय क्वेश्चन इज, this circuit breaker that is having limitation in terms of current, so can you design what is the limitation and what is the maximum current possible with low voltage?
आप 690 मुझे सर, मैं पूछता हूँ, मैं आपके पहले आपके वो क्या बोलते हैं, सिंक हो जाऊं। आपका एक जनरेटर है,
हाँ,
ब्लैक बॉक्स है, उसमें से 690 वोल्ट मेरे पास आया, बराबर, और उसको आपने क्या किया, इन्वर्टर सर्किट यूज करके स्टेप अप किया, एक और ब्रेकर लगाया, उसके बाद आपने एक स्टेप अप ट्रांसफार्मर 66 केवी या 132 केवी या 220 केवी पे किया, बराबर।
या
अब आप पूछ रहे हो 690 वोल्ट का जो ब्रेकर है, बराबर, ये अब मुझे बहुत फीली क्वेश्चन है साहब, ये एसी, सॉरी,
दोनों ब्रेकर, जनरेटर का भी और जो इन्वर्टर के बाद जो ग्रिड में फीडर कर रहे हैं, दोनों AC ब्रेकर है, 690 वोल्ट ब्रेकर है। तो
अच्छा, 690 वोल्ट के AC ब्रेकर है,
हाँ, तो AC 690 वोल्ट ब्रेकर, so what is the current limitation of that and why that current limitation is there?
अब ये बताइए साहब कि ये आपका वैक्यूम ब्रेकर है या ये आपका SF6 ब्रेकर है, किस टाइप का है
ये हमारा आर्क किंचिंग ब्रेकर है, ना तो वैक्यूम है ना तो SF6 है, दोनों आर्क किंच करते हैं, स्पेशल आपका
अब इसमें साहब मैं बताता हूं सर, मेरा
प्रेशर से मूव करते हैं, प्रेशर से मूव करते हैं कॉन्टैक्ट।
ठीक है साहब, तो एयर ब्रेकर होगा नॉर्मल,
हाँ, स्प्रिंग लोडेड ब्रेकर है ये, हाँ, एयर ब्रेकर स्प्रिंग लोडेड है।
अब साहब मैं बताता हूँ, मैं इस एरिया का, लेकिन मैं आपको ब्रेकर R&D का बंदा हूँ, मैं आपको थोड़ा बताता हूँ। एट द एंड ऑफ द डे इसमें हमारे लिमिटेशंस क्या होता है, दो चीज पे हम डिजाइन करते हैं, थर्मल डिजाइन, डाइलेक्ट्रिक डिजाइन। थर्मल डिजाइन में क्या होता है साहब, उसका शॉर्ट सर्किट करंट। तो पहला चीज क्या है कि आपको जो करंट इंटरप्ट करना है, अच्छा ये करंट आपका हमारे एसी साइड पे X/R रेशियो रहता है, आपके सिस्टम में क्या रहता है, मेरा एरिया नहीं है। अगर आपका डीकेइंग डीसी के ऊपर सुपर इंपोज एसी करंट होता है, X/R रेशियो कितना रहता है, जिस पॉइंट पे आपका कॉन्टेक्ट सेपरेट होता है, उसके बाद जो नेक्स्ट करंट जीरो आता है, उस पे आपका डीसी कंपोनेंट का मैग्नीट्यूड क्या है। हम बोलते हैं ना कि भाई 45 टाइम कांस्टेंट बोलते हैं, तो आपका ये टाइम कांस्टेंट वहां पे कितना होता है, शॉर्ट सर्किट करंट कितना होता है। अच्छा, अगर आपका कोई बैकअप सिस्टम है तो आपका थ्रू फॉल्ट करंट कितने ड्यूरेशन के लिए जाएगा, ये कोई थर्मल कैपेसिटी। डाइलेक्ट्रिक कैपेसिटी इज वेरी क्रिटिकल, थर्मल जनरली मैनेज होता है, पर ओवर वोल्टेज जो इश्यू आता है ना, वो बहुत टफ रहता है। उसमें क्या होता है मैं आपको बताता हूँ साहब, एक पावर फ्रीक्वेंसी वोल्टेज होता है, जो वोल्टेज का वेव शेप बहुत अजीब रहता है। आप सॉरी, पावर फ्रीक्वेंसी साइनोसॉइडल रहता है। दूसरा आपका होता है स्विचिंग ओवर वोल्टेज, लाइटनिंग ओवर। तीसरा आता है वेरी फास्ट ट्रांजिएंट ओवर वोल्टेज, जिसपे हार्मोनिक्स रहते हैं। और एक ओवर वोल्टेज होता है जिसको बोलते हैं बहुत DI/dt इज वेरी स्टीप, और dV/dt इज वेरी स्टीप। वोल्टेज बहुत कम है लेकिन उसका स्टीपनेस बहुत हाई है। तो नेचर ऑफ द वोल्टेज है, उसके ऊपर ये सब डिजाइन होता है। एक चीज और है, अगर आपका एयर ब्रेकर है, अगर करंट आपका बहुत, अगर चॉपिंग इंपैक्ट आता है, और अगर आपके सराउंडिंग में एक LC सर्किट ऐसा बनता है कि जिससे बहुत स्टीप ओवर वोल्टेज आता है, सीधा ब्रेकर को डैमेज कर देगा ये, सीधा। तो एट द एंड ऑफ द डे ये सब हम जो डिजाइन करते हैं ना साहब, वो पॉसिबल वोल्टेजेस क्या होते हैं, शेप्स, और करंट क्या होता है, उसका ड्यूरेशन, उसके ऊपर हम डिजाइन करते हैं सर।
मैंने आपको इनविटेशन भेजा है लिंक्डइन में, तो आपका जो 690 वोल्ट में जो भी आपका सर्किट ब्रेकर है,
हमारा नहीं है साहब, हम
क्या शेयर करेगा, आप नहीं बनाते,
नहीं साहब, हम तो नहीं, हम 66 केवी ऑनवर्ड्स, क्योंकि हम हाई वोल्टेज सिस्टम से। लेकिन मैं आपको बताता हूँ कि कोई भी सिस्टम में आप जाओगे ना, लेट इट बी लो वोल्टेज हाई वोल्टेज, एट द एंड ऑफ द डे ये है। तो आपको ये देखना चाहिए, अगर आप इसके ऊपर सोच रहे हैं, तो आपके जो स्ट्रेसेस क्या क्या आते हैं वोल्टेज में, एक्सट्रीम स्ट्रेसेस इन टर्म्स ऑफ मैग्नीट्यूड, राइज टाइम और शेप ऑफ द वोल्टेज, बराबर। और करंट में क्या आते हैं, क्योंकि आपके सर्किट नाइदर इज प्योरली डीसी प्योरली एसी, क्योंकि आपका इन्वर्टर्स लगे हैं उसमें। तो इट्स हाँ, मुझे थोड़ा समझ में आता है। अगर हम HVDC की बात करें तो कई बार क्या होता है कि वी हैव अ डीसी स्ट्रेस ऑन वन साइड, एसी स्ट्रेस ऑन अनदर साइड, और इसका बिहेवियर फील्ड का जो होता है ना, वो बदलता है। इसलिए HVDC में भी अभी स्टैंडर्ड इवॉल्व होता है, ब्रेकर के लिए इवॉल्व हो रहा है। तो आपके केस में जो स्ट्रेसेस है ना, वो कैसे आएंगे अक्रॉस द ब्रेकर? अगर आप लेते हो AC साइड ब्रेकर, एक तरफ विंड प्लांट है आपका, एक तरफ का इन्वर्टर है, अगर वो हार्मोनिक इंजेक्ट करता है, अच्छा ग्रिड साइड से आपका अगर कंट्रीब्यूशन फॉल्ट का आता है, सोर्स साइड जैसे जनरेटर सर्किट ब्रेकर हम बात करते हैं ना साहब, तो अगर आपका विंड से इनर्शिया के कारण कुछ करंट फीडबैक फीड होता है, उसका एक्सपायर रेशियो बहुत हाई होगा फॉर एग्जांपल। अगर आपका ग्रिड की तरफ से आता है शॉर्ट सर्किट, तो उसका रिजल्टेंट करंट क्या आएगा? ये फॉर एग्जांपल करंट के लिए मैं आपका थॉट प्रोसेस ट्रिगर कर रहा हूं कि हम किस तरह से सोचते हैं। तो ये स्ट्रेसेस क्या क्या है वो लेके आपको जाना चाहिए, जो आपको ये ब्रेकर देते हैं उसके पास।
See, why I'm asking you this, because that is the limitation right now in the wind turbine industry, and we cannot go for higher megawatt power. This is one thing which we can get from limited supplier, and that is having its own
इंटरप्शन
current
का इशू
meter.
आपका शॉर्ट सर्किट इंटरप्शन का इशू है आपका, के लोड करंट का आपका इशू क्या है?
नहीं, load current,
Specifically
that is the right now it's the load current. This short circuit current is that is having 135 kiloampere, that is no problem. But this load current and interruption current, that is the issue. So you need to, this trip curve it dictate that, and according to that you cannot go beyond 7,000.
एक चीज हो सकता है यार सर मैं तो बहुत ही प्रीमैच्योर हूँ इसके लिए, पर एक चीज मुझे समझ में थोड़ा सा दिमाग में आ रहा है, मेरा आंसर आप 100% मत लेना, पर मुझे जो लगता है सर एयर मीडियम को आप लोगे ना तो उसकी डाइलेक्ट्रिक स्ट्रेंथ बहुत कम है, तो हो सकता है वो इंटरप्ट ना कर पाए। तो वो एक चीज और कर सकते संजीव साहब, आप एक चीज और कर सकते हो। हाँ, ये बहुत वाइल्ड थॉट है लेकिन सोचना आप, व्हाई डोंट यू गो फॉर अ हाई वोल्टेज रेटिंग ब्रेकर? मैं बता दो क्या।
No, I have
मैं
given you the
example
reason.
देता हूँ।
No, but I have given you the reason that this industry is very, conservative, and they don't want
अच्छा,
to.
cost constraint होगा तो।
No. They don't want to explore this regulatory framework and other, approval and other challenges.
नहीं मैं समझ गया संजीव साहब, लेकिन इसका एक रास्ता है।
So they still want to stick on this, and if we
पर सर
can
एक
invent or
एक सेकंड सुनिए, इसका एक रास्ता बताता हूँ मैं आपको, थोड़ा वाइल्ड थॉट है। हमारे यहाँ 20 kV के सिस्टम में है ना, कुछ टर्शरी में ट्रांसफार्मर सॉरी रिएक्टर पे ब्रेकर लगता है 20 kV, 11 kV, 6.6 kV, लोग यूज करते हैं 72.5 kV ब्रेकर्स, 132 kV ब्रेकर्स। मैं आपको ये बोलता आप उतने वोल्टेज पे मत जाओ, लेकिन आप ये कर सकते हो 690 वोल्ट है ना, उसके लिए आप शॉर्ट सर्किट लेवल आपका अगर है तो उसके लिए आप सोच सकते हैं SF6 ब्रेकर, MV स्विच गियर के ब्रेकर पे जाओ ना आप, हो सकता है कि वो ब्रेकर आपका आपको कैपेबिलिटी दे पाए जो आपको एयर ब्रेकर नहीं दे पा रहा है। आप समझ रहे हो क्या बोल रहा हूं?
and then there is a space constraint also, so you need to,
No, I
you cannot
understand.
install the, so but I will
But
look
देखिए
into
सर,
it, but thank you so much for your thoughts.
पर साहब एक चीज
I
मैं
think,
बोलता
yeah,
हूँ, मेरा एक्सपीरियंस कस्टमर्स के पास, सब एक एक्सपीरियंस मैं आपको बोलता हूँ, मेरा कस्टमर्स, मैं वर्ल्ड के हर एक कस्टमर के पास गया, ऑल कॉन्टिनेंट, एंटार्क्टिका नहीं गया, बाकी हर जगह गया हूँ मैं है ना, इनको वाइल्ड थॉट यूजर सर बहुत ओपन रहते हैं। मेरा एक्सपीरियंस क्या है, मैं बोलता हूँ कुछ वाइल्ड थॉट वो एक्सेप्ट करते हैं। तो मेरा सर, आप तो मेरे से बहुत सीनियर है, आपका 20 साल यहाँ काम करते, मैं तो नया हूँ, और मेरे भी अभी भी क्या है कि इतने बाल आपके जितने सफेद नहीं हुए हैं, बट कस्टमर को मैं जाता हूँ सब, मैं डरे भी ना बोलता हूँ और वो एक्सेप्ट करते हैं। तो आप ऐसा कुछ बताओगे ना तो वो खुश हो जाएंगे। कई बार तो क्या है कि ऐसा सोच के उनकी आई ब्लिंक हो जाती है, तो दे आर ओपन टू चेंज, क्योंकि सर एट द एंड क्या इनको ग्रिड चलाना है। हाँ,
I will look into it, and then we will be connected. So
आप
thank you so much
लिखिए ना
for
सर,
enlightening.
लिंक्डइन पे
Yeah.
मैं अपना ईमेल आईडी
I
दूंगा
have
आपको।
I have
लिखिए
sent you
मुझे।
that. I invited you
Okay.
on LinkedIn, so we'll connect. And thank you
ठीक
so
है
much, Dr. Giri, and participant also. Although they were some point of time they were little panic, but you attended our lecture, so thank you so much, and enjoy your time, and bye for now.
Thank you,
गिरी
Dr.
सर, मैं
Sanjeev sir.
बहुत टाइम
Thank you very much.
मिस कर रहा था।
It
गिरी
was
साहब,
very
मैं मिस कर
insightful
रहा था लेक्चर
discussion
को गिरी
after
साहब।
the session in between two field experts. I hope so participants have also enjoyed this discussion, and this was that means coincidentally both field experts met, but it was very nice to meet on the at this platform, and I was fortunate enough we had two field experts from different area, and they interacted to each other, they shared their thoughts, and we all are have gained something from this discussion. So thank you, Dr. Urmil Parikh sir, thank you, Dr. Sanjeev sir, and I hope so. I am looking forward to work with both of you at somewhere at some point of time, and we will collaborate in some publications as well. Our research team is working basically at the microgrid system wind, solar, all these are the renewable energy sources. We are working on the power quality issues, but we are continuously moving towards electrical vehicle segment also. And that means there are so many other domains we are exploring with some control algorithms. And hopefully we will cooperate and collaborate in some segments. Dr. Sanjeet sir area is more closer with me. But I would like to, because I have that means I have collaborated with Professor Kunal Bhatt. Urmil sir has mentioned him, and we had collaborated on 3 papers, different papers. Last year we have published in very nice journal. Yes. Dr. Bhalja, me and Kunal Bhatt has published one paper in Ambient Energy Journal. That is ESCI, and 2 more papers were published in some other journals. That was
community साहब, छोटा सा community है हमारा.
जी हम सब एक दूसरे को जानते हैं. And fortunately Sanjeev sir has come in our program. This is the second time.
Very nice.
Previously when he that means when he accepted our invitation, at that time Commissioner GT Pandya sir was he was also joined at that time, and he interacted with Dr. Sanjeev sir. Even some problem related to power sector of the Gujarat state, he mentioned in front of Dr. Sanjeev sir, and Dr. Sanjeev sir has given some insightful solution at that time also, as I remember here. So it was very nice interaction, sir, with both of you, and it is rarely happen when 2 field experts at the same session available. So this was rare. Sometimes because we feel
first time this also. First time
and the important thing is Sanjeev sir has given a lot of time to us today. Even after his session delivery, he attended your session of 1.5 hours. So it is quite it shows his humbleness and grounded that means grounded attitude. So we are very much thankful to you, Sanjeev sir and Urmil sir, and hopefully we will meet once again in some conferences or somewhere very soon. I am planning to organize.
I appreciate Dr. Giri. You submit one paper in UPCon, so hopefully we will meet there in UPCon IIT. So submit one paper there, and we will talk about it. And then all pleasure is mine. Thank you so much for this opportunity and giving opportunity to interact with Dr. Urmil. And take care and bye for now. Bye-bye.
And
thank you, sir. Bye-bye.
Sir, I also leave now, and thank you. And
yes, sir. Urmil Parikh, sir.
After 2 years, I given a lecture, sir.
Yes.
After 2 years, I interacted with some professors and also students. I would say really I'm happy because after a long time I interacted. So thanks.
Really, it's pleasure, sir. It's pleasure to meet.
Thank you.
और हम बोलते हैं जय श्री कृष्णा. मैं रखता हूँ जय श्री कृष्णा.
जय श्री कृष्णा. चलिए सर, thank you very much. Thank you. Okay, sir. Bye. Dear participants, now your quiz has started, and I hope so. You are doing good in the quiz, and you will submit it soon. And then at 7:30, we will again meet for valedictory function. My personal request: you share your independent feedback without any that means without any influence of mine. There is nothing from my side. Whatever the things you have learned from this platform, you can share your original views, and so that once you are sharing or telling us the original views about this FDP, in future when we are organizing such more FDPs, definitely your views will be helpful to us to make it more convenient for the participants and to make it more that means make it more that means make it more better. So it's nice, and I am hopeful that after attempting the quiz, you all will join once again, and we will allow your mic and camera both, and we'll take photographs also, and the attendance of that session will also be taken. That means downloaded from this MS Team. So please join after your quiz, and you take some refreshment, take some tea. Definitely we will be meeting at 7:30, for the valedictory function. There are some messages received from the guest invited, and hopefully some of them may join also. So please be there and cooperate us for the final session of this FDP, and then we will say goodbye to all of you and for all the best for your future. So please attend the 7:30 valedictory function. Thank you very much. Thank you.